Hi, and welcome to Advanced Application Management with Red Hat OpenShift. My name is Marek Czernek. I am a senior curriculum developer at Red Hat. I am one of the developers of this course, and I'll be the instructor for this course. So, if you have taken some of our previous courses were focused on Kubernetes and on upstream Kubernetes, on how do we use Kubernetes, how do we develop for Kubernetes. This course focuses on Red Hat OpenShift, right? So if you are familiar with our previous courses, this course, just like our previous courses, comes with a handy PDF, right? And so this accompanying PDF comes with text, right, with lectures and guided exercises. And I would definitely encourage you to grab that PDF, download that PDF, go through that PDF, because these videos contain maybe slightly different information, or I do not read just from that PDF, right? And so let's take a look at what actually we are going to be doing within this course, right? So we have our handy PDF at hand, right? And let's just take a very, very quick look at our at the contents of the PDF. We have our in the first chapter, right? We are going to be configuring our development environment. This course is focusing on developer experience, right? For our OpenShift experience. And so we have to configure our development environment. That means configuring an IDE such as VS Code, configuring Git, right? Understanding what Git is, how we use it, and we are going to use Git extensively throughout this course, right? As well as VS Code. Then we're going to take a look at how we can deploy some applications, right? We are going to be hands-on right away and deploy some applications to Red Hat OpenShift, right? We are going to take a deeper look at how we can customize these applications, right? So we have our source code of our application, and we now know how to deploy it on Red Hat OpenShift, right? How do we decouple that from our configuration, right? By using something like secrets and configuration maps. And if you have taken our previous courses, this might be slightly familiar to you, but we'll take a look. We take a look into more depth, right? We will connect the application to database, right? And we will decouple the database configuration by using something like secrets, right? So this is our next chapter. We are going to take a look at scalability, right? So we talk about cloud, and in cloud, you often hear about scalability and what it means to scale an application, right? So we are going to explore that world, and we are going to scale our application and even configure auto scalability within Red Hat OpenShift, right? We are going to take a look at how we troubleshoot an application, right? This is something that many users struggle with, many developers struggle with, especially in the beginning. It's very easy to make mistakes, make typos, right? Assume that something works in a way that it doesn't. So what we want to do is give you the tools to be able to troubleshoot your application, troubleshoot a failing build, so that you know where to look in case your application does not behave in the way you want it, right? So this is our 5th chapter, right? And last but definitely not least, right, we have our 6th chapter. And in the 6th chapter, what we want to do is essentially, right, we don't do anything that we haven't done already, but we are going to take a look at a deeper level at what we have done so far, right? So we are going to take a look at the CLI, right? We are going to use the OC command line utility, and we're going to use the OC command line utility to peek behind the curtain just a little bit and see how some of the concepts that we have explored work under the surface, right? So, for example, we are going to take a look at the Kubernetes and OpenShift architecture, right? We are going to take a look at various resources, right, that we can use within Kubernetes as well as OpenShift, right? We are going to take a deeper look at the OpenShift routes, right, and how the routing is done within Red Hat OpenShift, how source to image works, right, etc., etc. And so this will hopefully give you more confidence in your ability to use Red Hat OpenShift as a developer and deploy your applications to OpenShift, right? So what do we need to know in order to start? Well, this course was designed just like previously, just like our previous courses, with the bring your own developer workstation in mind, right? We support a number of operating systems. You can use Linux, Windows, as well as Mac OS operating systems. What I'm going to be using throughout this course is a Linux machine, right? We at Red Hat love Linux. So what I want you to do is take a look at the systems requirements. Make sure that you fulfill at the very least the minimum requirements, and hopefully the recommended requirements and better, right? One thing that I would like to notice is that we will need to install some applications, right? We will have to install Git, right? We will use Git extensively, and so you should be able to install some applications on your machine, right? Node.js is nice to have to install in case you want to try some of the applications before you deploy them to the cloud, right? Or to the OpenShift environment, whatever environment you will be using. Within this course, I'm going to use the cloud environment, but you can also deploy other environments as you want, right? And as I said, we are going to be using the OC command line utility, right? And so we will have to install that one as well, right? So at the very least, these two applications we will have to install on our operating system, right? So then we have our some support system considerations, right? This is just something that might confuse some people reading the PDF. The PDF contains guided exercises as well as lectures, right? And so we try to provide the PDF in a form such that it is very precise, right? We write out commands that hopefully you can type out and execute. And so what might confuse you is, for example, that the bash prompt, right? Or well, the terminal prompt rather than bash prompt might look different from the prompt on your system, right? So we are supporting multiple operating systems, and the prompt that we use for our commands looks like this, right? So this is the prompt that we choose to use, or alternatively, just like this, right? Just like this. And so what is this prompt I'm talking about, right? What am I talking about? So let me open up my terminal application. And so now I am in my terminal application, and this is what I see. And right now you see a prompt, right? So a prompt is basically everything on the left before when I can type, right? So this is my prompt. And so my prompt consists of my username, right, at my host name, and then location brackets, right? And then I see that it is a non-root shell, right? And then I can type my commands, right? However, if you use something like a Windows machine, you will have a different prompt. The prompt will consist of something like PS, which stands for PowerShell, and then the location and angle brackets, right? And then you can type out your command. And so the main thing that I wanted to say is that when you see our commands, especially in guided exercises, do not be discouraged by a prompt like this, right? The commands should work on all of the machines, provided that you use PowerShell, which is on Windows, which is the only supported shell on Windows, right? If the command does not work on Windows, then we will provide a command that should work on Windows, right? So this is one of our main system support consideration, and take a look at the PDF for further notes, right? One thing that I definitely wanted to take a look at is this executing long commands section, right? So this course uses some long commands sometimes, right? And we break long commands into multiple lines, and so we use this this backslash character, right? This backslash character, and so you can see that here. And I will note that when we are going through the guided exercises, and I'll definitely encourage you to do those guided exercises with me on your local machine. So the backslash character works on Unix machines, right? So the backslash character works on the Linux as well as Mac OS machines, right? If you are on the Windows machine, the backslash character does not work. You need to use the backtick character, right? In order to break long commands. Or you can just write a long command in one line, which is what I'm going to do in most cases, right? So let's take a look in my terminal, right? Let's say that I have a long command to type. So for example, I want to type echo hello world, right? And so this is a long command, and on a bash, right, on a Unix system, I use this backslash character. So this executes just fine on a Unix machine, right? And this echo broken into multiple lines by using the backslash character is equivalent to one line, right? So we can write echo hello world on one line, and these two are the same. If we are on the Windows machine, we can write the same, right? So we can still write our echo command. However, instead of our backslash character, right, we have to break the command by using the backtick character. So now I have added my backtick character, and I can continue on my next line, right? And so this command is equivalent to writing the command on one line, which means I get the same result, right? So this is our consideration for breaking long commands. And let's take a look at our handy PDF, right? And the last thing that we are going to mention is additional accounts and services. This course uses a free GitHub account and a free Red Hat account. the free GitHub account we are going to use for free Red Hat repository, and the free Red Hat account we are going to use for a free OpenShift cluster. So that was our introduction, and I hope I'll see you in the next video. All right, so welcome to our first video. And in this chapter, in this first video, what we are going to be talking about is configuring our cloud application developer environment, right? So before we get to deploying our applications to OpenShift, what we first have to do is set up our environment such that we can take our applications and deploy them to the cloud, right? So how do we do that? Well, first in this video, what we are going to be talking about is developer environment, right? And so we start right away by talking about the integrated development environments, or IDEs, right? An IDE is something that many developers talk about, and IDE is something that everybody, I think, has heard of, but it's one of those terms that might be loosely defined in people's mind, right? And so I think it's quite helpful to stop and think about the words, right? Integrated development environment. What are we integrating, right, into the development environment? And it is integrated development environments, right? And so let's take a step back and think about what a software developer, a software engineer, right, does on a daily basis. So we can compile and build source code, right? Quite non-controversial statement, right? We can correct syntax error or debug runtime errors, right? That's all quite reasonable statements, right? We probably do something with source code, right? We make some changes to the source code. If we like the changes, we move forward with the changes, but sometimes we don't like the changes and we have to go back to the previous changes, right? Or to the previous version of the source code. So we have to maintain some versions of the source code. And this is part of our job as a software engineer, right? Refactoring source code is definitely one of the big pieces of being a software engineer, right? And of course, executing some tests, right? Writing tests, maintaining tests, making sure that tests pass, etc., right? So this is what an engineer does, right? And so an integrated development environment integrates tools for one or more of these tasks into one place, right? So we have one program, right? One IDE, and this IDE, for example, comes with syntax highlighting, and the syntax highlighting goes back to, for example, correcting syntax errors, right? Right away, by having syntax highlighter within our IDE, we can see that we have forgotten a semicolon at the end of a Java statement, right? We might have a source code management tools integrated in our IDE, right? And this is not correct. That means that we can maintain multiple versions of our source code, right? Within our IDE, right? And so, in essence, IDE, as I've said, has multiple tools integrated in the program, such that it enables us to do multiple tasks that we need to do from one place, right? So we have many IDEs, and depending on a developer, some developers like different IDEs, and there are many IDEs, right? Within this course, we are going to be using VS Code, right? And VS Code is a simple but very powerful IDE, right? And it's very easy to install, very performant for our purposes, right? Very, very easy to use, right? So just a very simple interface, right? In a nutshell, we have our activity bar on this side, right? On this side, we have our activity bar, right? And in this activity bar, left-hand side, we can take a look at, we can switch between multiple views, right? So we have our file view, right? We have our source control view, right? Etc. etc. Then we have our sidebar, right? Which corresponds to whatever we have selected, right? So we go from left to right, right? So whatever you select on the activity bar goes to the sidebar, right? And then we have our main bar here, right? So for example, when we select this Go file, right? This touchstroll.go, it opens in the editor group. One thing that I would like to point out is this this panel at the bottom, right? It's called the status bar. And so that's over here, listed as number 5. What I really like about the status bar, right, is this this Git integration right here, right? And so this is going to be very useful in our course, and we are going to use it a lot throughout the course. It's going to tell you right away on which Git branch we are. And so if you are not familiar with Git, that's perfectly fine, but just know that it is there and keep an eye on which branch you are on. And we are going to talk about branches in a little bit, right? So we have our Git branch, and you can actually click this. This is not just a status indicator. It's actually a functional button in essence, right? Functional label. You can click, you can switch to different branches, and it's very easy and convenient and fast, right? So this is just a very basic VS Code interface, quite easy to use, quite easy to get started with, right? VS Code uses workspaces. That's it's quite all right, right? And we are going to use workspaces. We are going to actually download our repository, our Git repository, into a VS Code workspace. So we are going to use all of that. VS Code comes with an integrated terminal window, right? Or actually with integrated terminal, and you can have multiple terminal windows within the terminal, right? So that is the integrated part, right, of the IDE. It integrates the terminal application into your development environment, right? And so again, very handy. For example, when we are going to use the OC command line utility to clean up some of our environment parts, right? Some of our resources that we have created in OpenShift, we can do that from within VS Code, right? So very easy to do, very quick to do. If you prefer to use a different terminal application, that's perfectly fine. But you can do so from within the VS Code environment, right? The only thing that I would like to mention here is that, again, if you are using Windows, remember to use the PowerShell shell. If you are using some Unix system, then Bash is preferred, right? VS Code comes with many extensions. You can download extensions, you can install extensions. For this course, I don't think any extensions are strictly necessary to install, but you can experiment with any extensions that you want. So this course is going to use Node.js a lot, right? And so Node.js is a JavaScript-based application runtime. And a lot of the applications that we are going to use in this course and we are going to deploy to the OpenShift, right, are written in Node.js. So why are we using Node.js? Well, there are several reasons. Node.js, because it is a JavaScript-based runtime, is very easy to understand, right? It's very easy to read for a lot of people, and it's very easy to modify. So that's number one. Number two, Node.js has quite a good support in OpenShift, right? So that's another reason. So if we wanted to install Node.js on our local machine, we can do so by using the URL, and we are going to do so in the next guided exercise, right? And so then we get this Node command line utility, and this is how we execute our applications, right? So we can execute something like Node and then our script. So for example, app.js, right? And that would execute our app.js Node script, right? Very simple, very easy to get started with. You can essentially immediately get something out of your Node.js application, right? So let's delete that. If you are familiar with Node.js, then this is going to be very familiar to you. But if you are new, then if you are new to Node.js, then let's take a look at some basic features of Node.js so that you have some basic understanding of what we are going to work with throughout this course, right? And so in Node.js provides several modules, right? And modules as we write here are the smallest units of reusable code, right? Node provides several built-in modules which you can import, right? And for example, you can have the built-in HTTP module, right? Or you can write your own module and then import it in your other module, right? Node.js also provides packages which you can download from something like a Node.js remote repository, right? And these we can declare in a file called package.json, right? And this is a very, very important file, package.json. So every time we have our application, right? Every time you open up a new Node.js based application, right? What I would definitely encourage you to do as a first thing, right, is to take a look at the package.json file. Why? What is the reason? Well, first of all, you get some metadata, right? You get some name, version, that's fine, right? You get some description, that's also fine. But most importantly, right, you get the scripts, the scripts configuration. And here you might have the start script, right, which tells you how to start the application. And here we see that the way you start the hello application, right, the hello application, is by executing node app.js, right? So immediately, right away, you know something about the application, right? What it also tells you is what are the dependencies of the application, right? What does the application depend on? And then you see that there are two dependencies in this particular application, cookie parser and HTTP errors, right? So this is how we declare dependency on external packages, right? So we have our package.json file. And when we declare our dependencies, that's a first step of getting these packages, right? But then we have to download and install these packages, right? And so the way we do that is with the Node Package Manager, right? Or NPM. And so when you declare a package within package.json, right, as a dependency, what we can do then is use the npm install command, right? Npm install. And what npm does, and npm, just for recap, means the Node Package Manager, right? What npm does is then it reads all of the dependencies, right, declared in the package.json file, goes to the internet and downloads these dependencies, right, based on the versions that are declared here, right? So this is how we can get the application, the dependencies, right? So we have to, this is a two-step process, right? We have to declare it, and then we have to download them. If, on the other hand, you want to start a new application, right, and a Node.js based application, what we can do is use the npm init command, which essentially creates a package.json file, right, so that you don't have to write it by hand, right? And so one last thing that I wanted to take a look at within the npm is the scripts part or section of the package.json, right? In this section, we only have one script, right? So how do we execute this script? Well, what you do is the start script is a little bit special, right? For this start script, you can only execute npm start, right? npm start, and npm takes a look at the start script, right? And executes whatever it points to. What if there is another script, like a build script, right? If there is a different script or script with a different key, right, such as build, for different script, you can execute different scripts by npm run. So we can execute npm run and then the key, right? So for example, npm run build. And so for npm run build, for example, you have a TypeScript based application, and npm run build has a script that transpiles your TypeScript into Node, right? And so that's how you execute further scripts in this package.json file. So this is a lot of information about Node.js, but this is just a very basic getting started with Node.js. And if this is a lot of information, or if you are unfamiliar with Node.js, then you will get a lot of practice with Node.js as we start getting through our guided exercises, right? And so last but not least, we are taking a look at the Express web framework, right? And so Express is used a lot throughout this course, right? A lot of our applications are based on Express. And so Express is the dependency, a package, right, that you can use to create a web-based application, a web service, right? And so we can declare it as a simple Express dependency, right? And what it enables us to do is simply declare a set of endpoints, right? A set of endpoints such as this, and a set of responses at these endpoints, right? So for example, this very, very simple small program, right, enables us in a couple of steps, right? Import the package, right, Express, initialize the Express application, declare the /endpoint, right, and respond to that endpoint with hello world, and declare that this application should listen on the port 8080, right? And right away, within a couple lines of code, we essentially have a web-based application. So this is an incredibly powerful web-based application or web service, right? That we can write very easily and very simply. And this is exactly why we use Express throughout this course. All right, so this was our introduction to IDEs and to Node.js and Visual Studio Code, right? I hope you'll follow me to the next video where we will install Visual Studio Code on our local machine. All right, so welcome to our first guided exercise. And in this guided exercise, what we want to do is we want to take a look at downloading and installing VS Code. And by VS Code, I mean down here, right? We want to also download and install Node.js. In VS Code, we want to create a workspace. And because we have downloaded the Node.js runtime, we also want to, within our VS Code, we want to create our first program and execute it, right? So let's take a look at how we can do that. So first things first, we need to download and execute the Node.js runtime, right? And so let's take a look at the Node.js website. So what we want to do is we want to download the LTS version of the Node.js runtime. So on the Node.js website, all that we need should be this LTS download, right? And that should give you the proper version. We can also take a look at the downloads version. Click the LTS version. We have our Windows installer, our macOS installer, and if you are using a Linux-based system, you can take a look at installing Node.js via a package manager, right? So on my system, I have Node.js already installed, and so to verify that the installation was successful, you can open up a terminal application. So for example, on Windows, you can open up PowerShell and you can execute something like node-h, right? And if you get some kind of an output, that means that the installation was successful. If you get something like can't find binary, right? So if I do something like this, so I misspelled the node, right? Command not found. So if you get this command not found with the actual node, right? That means you probably have misinstalled or you did not install the application correctly and you need to return to the installation procedure, right? So we should have our Node.js installed. And at this stage, we can take a look at installing our Visual Studio Code. And the procedure is quite similar, right? In the Visual Studio Code website, we should right away get the installation file for our platform. So for example, I have the RPM installation package, right? I can select other platforms right here. So for macOS, Windows, or Linux, right? And so you simply download and install Visual Studio Code, right? So on my machine, Visual Studio Code is already installed, So I can open it up, and I already have a workspace opened. So I can select File and close a workspace. Right? So at this point, I have my VS Code ready, and we can get started with our creation of a new workspace. Right? So I can select File, and I can create a new workspace. Right? Save workspace as, and we can create a new directory. And this directory, for example, we can name something like do101x workspace, right? And so I already have that. And so within that directory, we can add our workspace, right? And so there we go. We have our workspace, right? So we have file save workspace as. So this is exactly what we did, right? And then we want to add a folder, right? So we want to create a directory, and this directory should be called hello node.js, right? So let's switch to the Explorer and want to select file, add folder to the workspace. And for example, we can add that folder anywhere we want, right? But I can add that to the same directory, and it could be called, what should it be called? Hello node.js, right? So let's do that. And we trust this this folder, right? We trust the authors because we are the authors. So that's quite all right. And we want to manage, and we want to trust this. We want to trust this workspace, right? And so at this point, we have our hello node.js directory, right? So that's quite all right. Let's close this get started dialog. And in this folder, what we want to do is we want to create an app.js file, right? So this is our first Node.js application. I can do this better. App.js file, and the contents of its file will be simple console.log, right? So all this application is going to do is print a hello world into the console, right? So in this directory, what we want to do is create a new file called app.js or named app.js, right? And the contents of this file will be console.log. And we can already see this IDE, right? I get some IntelliSense. I get some, I know which methods I can call on this console object, right? For example, and I get some syntax highlighting, so I can already see, for example, if I make a typo. So that's already quite helpful. So console.log. Hello world, right? Hello world. That is our application, right? And we can save that. I save it with Control S, but you can also save it by File, Save, right? And so at this point, all that we need to do is execute this application. So how do we execute our applications, right? The most basic way of executing a Node.js based application is simply pointing node binary to the app.js script, right? So we need to open up a terminal window, and we can do that by clicking terminal and new terminal, right? And conveniently, the terminal opens in the hello node.js directory, right? And so I can take a look by issuing ls, right? I can take a look that there is the app.js file. And so I can execute this file, right, by using the node binary. And there is our first program, right? Hello world. At this point, I can kill the terminal. And this was our introduction into setting up our environment, right? So we are ready to continue, and we are ready to take a look at the world of source code management, right? So I'll see you in the next video. All right, so welcome to our next section. And in this section, we are going to be talking about version control. And so this is one of my favorite topics, right? So I want to spend a little bit of time on version control. And so I want to pause right away, right? Version control. And I want to think about the name, right? Version control. We are controlling the version, right? And so controlling the version of what? You can control the version of a number of things, right? You can control the version of your thesis, right? If you're writing your BA, your master's, your PhD thesis, that's perfectly fine. From a software engineering point of view, we are controlling the version of our source code, right? So what do we want from our version control system? Well, from the software engineering perspective, we definitely want the ability to review and restore previous versions of files. Ideally, not only previous versions of files, but we want to restore previous versions of files. And then we say, okay, well, this does not work actually as well as we wanted it. I want to unrestore this old version of file to the newer version of file and see whether the newer version actually worked better, or I want to restore half of this file from this previous version and leave this other half as the newer version, right? So ideally, in an ideal world, this is what we would want, right? We definitely want to compare, right, two or multiple versions of the same file. What I want is to identify changes, right? And that's why I want to compare two files. So if we are working on the same project and I leave for a week of vacation and I return and somebody has worked on my project, I want to see exactly what has happened, right? I want to see exactly which lines have changed and how, right? I don't want to guess. I don't want to have to ask. I want to come to my version control system and ask, okay, what exactly has happened on which lines, which words have changed in the source code, and I want to review these changes, right? I might not necessarily do anything about it, but I want to see exactly what changes, right? Then we want to have a log of who, right? Of who made these changes and at what time. So this is quite useful, especially if you have, from an engineering perspective, software engineering perspective, when you have a pipeline, right? A pipeline is basically a system which checks, for example, your application. Let's say that it continuously tests your application. And let's say that at some point, one of the tests breaks, right? Like one of the tests stops working. What we want to see is which particular change caused this test to not work and who is responsible for the change. And the reason we want that is not to put blame on that particular person. The reason we want that is to be able to say, hey, it was this particular change set that caused the problem. You need to fix it, right? You are the person with the most knowledge about this change set. Can you please fix it such that this test continues to work. It's quite possible that the test is faulty, right? But we need to know who has the most knowledge about that particular change set. And what else do we want from our version control system? We want to have a mechanism for multiple users, right, to collaborate on multiple files, but not only on multiple files, but on the same file, right, and resolve conflicting changes, right? So what we want from our control version system, or from our version control system, excuse me, is to be able to say, if I make change to file A, and the changes line 1 in one way, and my colleague makes change to line A in a different way, what is the proper way to resolve that conflict, right? What we definitely don't want is for the version control system to say, okay, whoever was the latest wins, right? Or whoever is the most senior developer wins, right? We don't want to lose changes. We might want that, but that has to be our decision, right? We might want to say, I collaborate with this developer and I say, okay, your changes win because later I did not know about X, Y, and Z, right? But we definitely don't want the version control system to make these decisions for us, right? And so there are a number of open source version control systems. And in this course, we are going to be using Git, right? Git has emerged as one of the winners in the open source community. It is widely used by a number of projects, a number of companies, such as Red Hat, use Git extensively, right? Linux is developed by using Git, for example. A number of great projects are developed by Git, right? And so when we talk about Git, one thing that we have to make the distinction between is we have to distinguish Git and something like GitHub, GitLab, or Bitbucket, SourceForge, etc. We have to distinguish between what is on your computer, which is Git, right? That is a local Git repository, and a remote server that hosts the source code, right? So we have a Git, right? And Git can convert any local, let's say, local system directory into a Git repository, right? So when I said that you can version control your thesis, for example, you don't need any remote server by default, right? There is nobody forces you to upload your thesis to the internet. You can get a number of the benefits that we have discussed above, right? Just on your local system. For example, you can review and restore old files, right? Just on your local system. However, if your local system crashes, you have no backup, right? It is just on your local system. And that's why we use many remote code hosting platforms, for example, GitHub or GitLab, right? And these platforms implement protocols that can talk to Git and basically synchronize the local state of Git with the remote state, right? So then you have some kind of a local state. And for example, in this course, right? So this is going to be your DO 101 X apps, right? And in this course, you are going to be talking to do101x-apps in GitHub, right? And you are going to push commits, push branches, push change sets, etc. Right? So, technically speaking, you do not have to have a remote server for using it, but it is definitely advisable for, what if your local machine crashes, or for example, what if you want to deploy your code to something like OpenShift, right? To something into the cloud. The cloud does not have your local state available, right? And this is all that this course is about. How do we deploy to the cloud, right? How do we utilize the power of OpenShift? And therefore, we basically have our local state. We synchronize our local state to GitHub, and then OpenShift, OCP, OpenShift Container Platform, pulls from GitHub and possibly pushes, but in our course, actually, it just pulls, right? So it's more like, it's actually more like this. Right? So OpenShift, basically you push your code to GitHub, you synchronize your code with GitHub so that it's available to OpenShift, and OpenShift then pulls it from GitHub and uses the code and deploys the code such that it's available in the cloud. So that's Git and remote server. So what is the basic Git workflow, right? If we say we work with Git, what does that mean? What is the day of a Git of a developer that uses Git? What does that look like, right? Well, we first have to retrieve the files, right? And we do that by using the clone. And this is actually a command, right? We use git clone, and this downloads everything about a Git repository. This downloads every change set that everyone has ever made in the Git repository. This downloads all of the branches in a Git repository, all of the tags, etc., etc. So for now, we don't know what are commits and branches and tags, but just know that when you clone a repository, just by cloning a repository, you can move to previous states in that repository. So you get the latest state of the repository, and right away you can move to the previous states, right? Which is pretty amazing. You can review what has happened in the past. You get the history as well as the latest state, right? So how do we do that? Well, when you clone, as I said, you get the history, right? And let's say in a very simplified manner, the history consists of commits. Again, this is a different Git command, right? And a Git commit is basically a change that you are making into the repository. And a commit consists of a few things, right? A commit consists of commit message, right? So basically a message is a metadata for developers, for us, that says what has happened. It is a summary, right? A timestamp, right? So this Git adds timestamp automatically so that you know in which order these changes happened, right? Then we have an author so that you know who created the change, right? Who authored the change. And then we have a commit hash. And a commit hash, at first it might not seem that important to you, but it is actually one of the most important things about a commit. It is a unique identifier of a commit. And so when I say unique, that means that when you have a commit, you return to a commit by its hash, right? So a commit hash consists of some hexadecimal characters. Git generates the hash by itself, right? When you create a commit, it automatically generates a unique hash. And so when you say, I don't like this change, I want to return to a previous change, you are essentially saying, I want to return to a commit with the hash of X, right? So, so far, we have cloned a repository. We know that a repository contains a history, and we know that the history is a list of commits, right? So that's all well and good. When you start working in a Git repository, Git does not automatically make any changes to the remote repository, right? Basically, there is no automatic synchronization of your local repository to the remote repository, right? Remember that we install Git, and for example, we use GitHub or GitLab or some other remote server, right? And so just like when you download a Git repository, you get a list of commits. When you work in a repository, to actually make changes to that repository, you first modify files, and then you create a commit out of the files that you modify, right? And so only then, after you create a commit, you can push the commit. And so when you push the commit, this means that you have made a change to the repository, and you want this change to last. You want this change to be trackable. This change has your name on it, and you stand behind this change, right? Similarly, when you have your local repository, just like there is no automatic synchronization from your local repository to remote repository, there is no automatic synchronization the other way, right? When somebody else pushes in that into the remote repository, you don't get these changes automatically. To do that, you have to pull. So what does that mean, right? If both of us work on a do101-apps repository, right? Basically, when I make changes and I push into the repository, these changes are not reflected in your repository that is stored on your file system, right? On your computer. For you to get these changes, you have to pull them. So this is, Git is called asynchronous, right? Git has asynchronous workflow. And this is what it means. There is no synchronous events. And this is because we don't want, whenever somebody pushes something, we don't want to block everybody else, right? Imagine that one repository has thousands of developers, and whenever somebody pushes something, we don't want to block everybody else and let them wait for like, for let's say 25 seconds, right? Before everybody gets distributed this change. No, this is the responsibility of each of the developers to push when they are ready to push and pull when they are ready to receive. That was just very basic Git workflow. So we know about clone, Git cloning. We know about commits, which are basically the change logs. We know that Git clone has a history of commits. And then we know about push and pulls, right? So far, very simple. And we will use all of that in our guided exercises. So it's a lot of information. Don't worry if you are getting a little bit lost in all of the information. All right, so how do you get Git? Well, of course you have to install it, and we are going to be installing Git in our guided exercise. So for now, we can skip this section. All right, so with the basics of Git under our belt, let's take a look at how Visual Studio Code helps us to manage Git, right? And so this chapter, this part of this section is mostly for you, and I encourage you to go through this section on your own. I'll just pinpoint basically the important parts, or what I consider important of this subsection, right? So we have the view SCM view that helps us with the source control management. Of course, you can just click this this button, right, which is basically the same, which brings you to the source control view. And one important thing to mention is that in this course, we are going to be using basically one Git repository, a single Git repository, and so by default, the source control view in VS Code does not display the source control list in VS Code, and so we can enable that, right? Or we can open the settings view and select preferences, open settings. In there, we click the user features, right? SCM, and always show repositories. So this is a setting that we are going to be using throughout this course, and it's totally fine. It's totally fine not to do it right now. We are going to do it in the guided exercise. It's just something to be mindful of, right? So if in the guided exercises, my source control view looks slightly different than yours, it is possible that you forgot to turn the always show repositories feature on. So VS Code, of course, enables you to clone a Git repository. So that is a command, right? So you can bring up the command palette. This is a very useful feature of VS Code. Bring it up by using the view command palette, right? And then you have the git clone option. And then you simply type in the remote URL. So this is the clone command. This will bring a remote repository to your local machine. Whenever you are working on a Git repository, as we've said, you have to create, in order to make changes to the repository, you have to make commits, right? But not everything that you do in the repository has to be a commit. And therefore, when you are changing files, Git has two stages of, or two statuses of each files, right? When you modify a file is modified, which means that a file differs from whatever it was in Git, right? Git simply tells you something has changed in the file. And when you say, I know, and I want to add this file to my next commit, you flag that file, and that file becomes staged, right? So basically, whenever you have a file, this might be your index.js or app.js, you modify the file, you like the modification. If you want to include the file in your next commit, you add it to the staged right? You make it a staged, you add it to the staged list, right? And when you create a commit, the commit takes a look at all of your staged files and adds it and creates a commit from the list of staged files. So we are going to take a look at all of that in our guided exercise. Just know that sometimes when you are working on a Git repository, when you change a file, sometimes you don't want to make that a commit, right? This gives you the power and the flexibility to say these changes will be commit 1, for example. Those changes will be commit 2, and the remaining changes I did not intend, for example, or the remaining changes do not work. And that's why we have these modified and staged lists, right? So we are going to see that in our guided exercises. Just know that simply editing a file is not enough. You have to stage it, right? And VS Code helps you to do that from the source control view. Again, the view SCM view, or simply the source control view, right? You create a commit from the staged list by clicking this button, right? That will create a commit. VS Code will prompt you for a commit message. You will write a commit message, and that will create a local commit. So, as we have said, whatever Git does is on your local repository, right? In order to synchronize your changes to a remote repository, you have to either pull or push, right? When you create a commit and you want to synchronize your local commit with an external repository, that is a push, right? You want to push something that you have locally to an external server, right? That's fine. That's fine. We can do that. We can see the status. We can see the status here, right? So that is the status. That means that we have one commit that we can push to the remote. I think that we can actually click this button and it will attempt to synchronize with the remote repository. Whenever we are talking about synchronizing your repository with a remote repository, especially when we talk about a public repository like GitHub or GitLab, we have to talk about authentication and authorization, right? You don't want just anyone to be able to have access to your repository, and vice versa. You do not want to accidentally push into somebody else's repository. And so in GitHub, especially or specifically in GitHub, there are two types of authentication that are widely used nowadays. One is the GitHub token or GitHub access token, and this is the way that we are going to be using throughout this course, right? And so GitHub access token enables you to authenticate as a user. It's essentially a time-bound password where you can select the scope of what you enable a person that authenticates with this password to do. And this is what we are going to be using. Another way to authenticate is by using SSH keys. And this is outside of the scope of this classroom. But if you have the time, it's definitely helpful to set up your SSH key authorization or authentication rather. So this is the way you set up your personal access token. We are going to do that in the guided exercise, so I'm going to skip this. VS Code also enables you to initialize a new Git repository. At this point, we should know, is this a remote Git repository or local? It is, of course, a local Git repository, right? Because we are still talking about Git. We're not talking about GitHub, GitLab. We're talking about Git. So when we initialize a new Git repository, this is a local. This is a new Git repository on the local file system, right? You can later synchronize this new Git repository to a remote GitHub or GitLab URL, and that's perfectly fine. But just know that when we talk about Git, it's local until you add a remote URL, right? And of course, this is what we are talking about. If you add a remote repository to a local repository, this is basically the setup that we are talking about. So when you clone a repository, it already has a remote setup, right? Because that's where you clone it from. You clone it from a remote repository, and it creates a local repository. When you initialize a local repository, it does not have any remote repository set up. So when you initialize a new repository, you have to set up a remote repository. And when you set up a remote repository, you can choose either the HTTPS URL or the SSH URL, right? And so unless you set up SSH access to Git, you have to use the HTTPS URL. So in this course, we are going to be using the HTTPS URLs, and in this course, we are mostly going to be just cloning a Git repository. So we are not going to be adding a remote repository to our local repository, but it is good to know nevertheless. So this is how Visual Studio Code can help us with managing our Git repository. Let's take a look at how all of this works in action. So welcome to our next guided exercise. And in this guided exercise, what we are going to do is we are going to install Git, right? And we are going to take a look at the directory that we used previously. And we are going to initialize it as a local Git repository, right? We are going to stage a file in the local Git repository. We are going to commit that file, and we are going to push that file into our remote repository into GitHub, right? So that sounds quite exciting. Let's take a look at how we can do that, right? So step number one, we need to install Git. Installation of Git is quite easy on a Unix-based system. So if you have something like a Ubuntu, you can use the package manager. So on Ubuntu, you can use the apt package manager. On Fedora, you can use the DNF, right, to install Git. Very, very simple. On macOS, Git might come pre-installed, right? So all you have to do is try and open up terminal and see whether git -- version is pre-installed, right? And on the Windows system, Git is not pre-installed, and so you will need to navigate to this URL, right? And try to take a look and see how to install Git, right? And if Git is not installed on your macOS machine, I would definitely encourage you to visit the same URL, right? gitscm.com, and take a look at how to install it on a macOS machine as well. So let's take a look. Let's verify that a Git is installed on my machine, right? So I can open up a terminal in VS Code, and I can issue something like git -- version, and I get some kind of a version back, right? One thing that I would like to say is do not worry about the exact version of the Git. As long as you have something relatively recent-ish, right? Git will work. So you don't have to have the latest Git version, as long as you have something that is relatively recent, right? So let's continue. Right? So we have executed our git -- version. So that's fine. Now we have to configure our Git, right? So we issue the git config, and this essentially serves as the metadata, right, for our commits. So this is git config -- global user.name, right? So let's do that. And this is going to be my GitHub user, right? So that's fine. And then we issue the same, but instead of user.name, we issue user.email, right? And there we go. All right, Git is now configured. Now, of course, I have skipped a step with GitHub, right? So if you don't have a GitHub account, take a look at github.com, navigate to github.com, register a GitHub account. It's of course free, and we are going to use the github.com account throughout this course, right? So this is a free account that we are going to use. So now we are going to enable the always show repositories, right, in the source control management option within VS Code. So this is a settings, right? Settings preference. So let's take a look. So view, command palette, right? So open settings UI, right? And now let's navigate to user features SCM, right? So we need our user, right? Then we need our features, and we need our SCM, and always show here, always show repositories, right? So for me, I already have it selected. If you do not have it selected, select it, right? So that's all well and good. And at this point, we are going to be working with the Hello Node.js project. So I have created that in my previous guided exercise, right? If you have not followed with me, then continue with the step 4. We provide a URL, right, in which you can download the repository, and you can import that into your workspace. If you have followed with me, then you have this app.js file with this console log contents in your directory, right? And let me just add this, right? And we can skip step 4, right? So step number 5, we can initialize the Hello Node.js project as a local Git repository, right? So we can access the VS Code command palette and initialize the Git repository, initialize the repository as a local Git repository. So remember that this is always the git command, right? So let's do that. We have the view command palette, right? Git, and we have the initialize repository, right? And we want to initialize the Hello Node.js repository as a Git repository. And there we go, right? Something has changed here. Suddenly the app.js changed to green, right? And there is a letter U next to app.js. That means app.js is untracked, right? What that means? What does that mean? That means app.js is a new file within our repository, right? If I change to the source control view, the app.js is a changed file, right? Which means that previously there was nothing, right? There was nothing here. And then we have added a new file which adds something on line 1, right? And this something is a text with console.log hello world, right? So what we want to do now is we want to create a commit, right? So remember, what do we need to create a commit? We need to stage the changed file, and we create a commit only from the staged files, right? So what do we do? To demonstrate this staged files, right, and commits, I can actually create a new file, right? And I can name this file will not be included in commit, right? And so now I have two files, right? One file I do not want in the final commit, and a next file I do want in the commit, right? So only the app.js I want in the commit, and the will not be included in the commit I do not want in the commit. So what do? I go into the source control, and I stage only the app.js file, right? So I click stage changes, right? And then I have two files, right? The app.js is added, right? It has a little a, and the will not be included, right, in commit is untracked still. And so then what I can do is I can create my commit. So for example, right? So I can create my commit. So commit app.js application, right? So this is my commit. I click this commit button, right? And suddenly my added file disappeared, right? From this view, from the source controlled view, which means that the Git source control knows about it, right? It is actually committed to the local repository, right? So far, it's nowhere in GitHub, right? It is just a local commit in the local repository. And this file will not be included in the commit, is still not committed, right? And so what I can actually do is I can discard the changes, right? So I can discard the changes, and VS Code warns me, right? This is irreversible. This file will be lost forever. I can delete this file, which is fine. Suddenly this file is deleted. And if I close it and go back, indeed, it is no longer there, right? So this is exactly the power of the version control. I made several changes. One change I deemed not to be useful, right? So I discarded it. I discarded the change, right? And next change, I added into a commit and committed it, right? I staged and committed it. At this point, we have our commit, right? And what do we need to do? Well, we at this point want to push this. This commit into a remote repository. So what do? Well, I first create a remote repository in GitHub, right? So let's open up my GitHub account, right? And I scroll up and add a new repository, right? And the name is going to be hello Node.js, right? So it is a hello Node.js repository. It is public. I do not want to initialize this repository with nothing, right? So that's fine. And I can create this repository. So at this point, I have an empty repository. One thing I will do right away, and if you are following along with me, I would advise you to do the same, is switch to HTTPS. Okay, right away. And we will use, unless you set up SSH keys, right? We will use HTTPS throughout this course, right? So if you have set up SSH keys, then feel free to use SSH, right? And SSH keys are a better way of interacting with GitHub authentication, right? But for us, HTTPS is just fine. Let's take a look. And what we need to do is create a personal access token, right, to enable us to authenticate, right, and to be able to push our commits into this repository, right? So how do we do that? Well, this is in the settings, right? So my profile, settings, right? Then we have developer settings, personal access token, right? And generate a new token. And I can create a my access token. For example, right? Let's set some expiration date, for example, 30 days, right? And the scope, all we need is the repository scope. Now, remember that this personal access token is essentially your password, right? Treat it as your password. Do not show it anywhere. Do not push it into your GitHub repository. It is your password, okay? So we have our personal access token. We do not need any other scopes, right? This is OAuth scopes, so that's fine. And let's click generate the token. Now at this point, this is the only time that you are going to see the token, right? So it's important for you to copy it, right? And once you leave this page, you will not see this token anymore. So copy it, paste it locally somewhere, right? For example, into Notepad or something, and keep it hidden somewhere, right? So that's fine. And at this point, I can go back to my repository, right, that I have created. So this is my hello Node.js repository, right? And we are going to be using it in just a second. So we have generated our personal access token. So that's quite fine. So at this point, we are ready to add our remote URL of the local Git repository in Visual Studio Code, right? So let's open up Visual Studio Code and let's view the command palette, right? And this is another git command. So let's start with git. And we want to add a remote, right? At this point, we need to provide the repository URL. So that's quite fine. Let me provide this repository URL, right? And I can delete the .git. You can leave the .git, that's fine. But this is not the whole URL, right? Remember that we have generated the token, and the way we authenticate ourselves by using the token is that we add this token between the HTTPS and the github.com, right? So we have the HTTPS. Then what I'm going to do is I'm going to paste in my developer token at github.com, right? So that is my developer token. And the name of my remote is origin. This is important. It should be origin, right? So that is our remote, right? And at this point, we should be able to publish our changes. So let's switch to our source control, right? And we should be able to push our changes. So the branch master has no upstream branch. That's fine. We can create that. And I was able to synchronize my local changes with the remote repository, right? So let's take a look at my repository and let's refresh. And I see that my app.js is in my remote GitHub repository. So in a few simple steps, we are able to download Git, right? Initialize local Git repository, create our first commit, add a remote repository, and push our first commit into a remote repository, right? So that is all for this guided exercise, and I hope I'll see you in the next video. All right, so welcome to our next section. And in this section, we are going to take a look at how Git works when we talk about collaboration and when we talk about slightly more advanced features. So at this point, this might seem a little bit daunting because there is going to be a lot more information coming in, but definitely do not worry. There is a lot of information at the beginning, especially if you have not used Git previously, but it's definitely not as challenging, especially when you start using Git, right? There is a lot of information at the beginning, but once you realize how it works, it's definitely not as daunting as it seems. So let's get to it. So far, we know about git clone, right? Git clone clones a remote repository, and we essentially bring down a series of commits, right? So we know that so far we have a series of commits in a repository. What we do not know is that each commit builds on a previous commit, right? So when we take a look at this graphic, we have some initial state, right? We have some initial state. And for example, we have 1, 2, 3, and 4 commits here, right? Each of them has a certain hash, and each of them has a certain commit message, right? And so, for example, the first commit, we take the initial state, which is empty directory, for example, and we say add code skeleton. So we could say plus, right? Add, and we could say add app.js. Okay, so let's add some code skeleton. And this we create as a commit. Git adds a hash to it. So this is some hash, right? And we added some commit message. And this is just for us, for the other developer that reads it, right? And that's perfectly fine. It's perfectly acceptable. So next, the second commit, right? It says add draft readme. So for example, we already have the app.js file in the repository. So we take that commit, we take that app.js file, and we say, okay, we already have that. So point to that commit, right? So instead of pointing to that initial state, the second commit points to the first one, right? And add the readme.md, right? So in the second commit, we build on top of the first one, and so on, right? So in the third commit, we build on top of the second commit. And so each of these commits has a parent commit, and in a repository, the latest commit that we have created is called simply a head, right? And this is just something for us to make it easier for us to refer to the latest commit. So whenever you work with Git and Git tells you something about head, right? Like detached head or something with head, right? Git is referring to the latest commit. For example, detached head means you are working with commit without a branch, right? So head is the latest commit. So we are working with a series of commits, right? Each commit relates to the previous commit in a certain way. So what Git enables us to do very, very easily is take this series of commits, right? We want to take all of these and name it, right? That's all we do. We take a series of commits and name it. And in this particular case, we name it main. And this is exactly what a branch is called, okay? A branch is a series of is a named series of commits, right? So that's all well and good, right? From the software engineering perspective, the main branch has kind of a special function, right? On the main branch, typically the code is stable, right? The default is that on the main branch, or historically on the master branch, right, all the tests would be passing, all of the environment would be working, right? On the code on the main or master branch would be simply stable and working as expected, right? So what happens when somebody asks me or you or somebody else to develop a new feature, right? So I need to go in and start developing new code. And chances are that the new code that I'm going to develop is going to be unstable for some time, right? That's just the nature of software engineering. I don't know about others. I'm definitely not smart enough to code a feature to be stable and ready and good just at a first try, right? And my experience tells me that many people are not capable of doing that just by sitting down and writing, right? And this might not even be based on people's skills. This might be based on misunderstanding, miscommunication, etc., etc. So what this branch feature enables us to do is to simply take whatever commit, right, we have on the main branch. So we have the main branch, and this commit we know is stable, right? We know the tests are passing. We know that this commit is good, right? Or at least supposedly it's good. And we create a new branch, and this branch can be called feature 2. This branch can be called whatever you want it to be called, right? It's simply a name, a pointer. And in this branch, we base our code on the latest stable commit, right? And we create our new commits, right? And so we point to the latest good commit, right? And create new commits from the latest known good commit. And so we develop new commits, right? And this brings us to our next issue, our next problem, right? When we do that, at some point, for example, at this point, right, the head is pointing here, right? And at this point, I think I have developed my feature. My head is good, right? I think my feature is ready. And I say, my feature is complete. The problem that I'm facing right now is that my feature is complete, but on the branch that's called feature 2. So how do I resolve that? Well, in Git, we resolve that with something that we call merging, right? And so merging is the process of taking a series of commits, right? Series of changes from one branch and pushing them into a different branch, right? So we take all of the commits from the branch feature 2, and now I want to create a new commit on the main branch. Because what I'm saying is everything that I've done on the branch feature 2 is what I would like to have on main now, right? And there are a number of ways that you can, do this. For example, you can preserve the history, right? In Git, you can literally just take these two commits, and you can basically copy paste them and have them here, right? Instead of one new commit. Alternatively, you can simply squash the two commits, right, into one and create a new commit on main, just like we have created here, right? But the process is still the same. We merge one branch into another, right? So this is exactly what Git enables us to do. We have a series of commits. We can name a series of commits, which in Git terminology, we call a branch, right? And when we have a branch, we can merge one branch into another. Now notice that there is nothing special about the main branch, right? We might have just as easily merged the main branch into the feature branch, right? Depending on what you want to do, depending on what is your intention, you can merge one branch into another. There is nothing special about one branch or the other. But in this particular case, the main branch contains the stable code. The main branch is the one branch that we want to protect, right? We want to protect the stability of that branch. And that's why I am developing my code in the feature2 branch. If the feature2 branch is unstable, if the tests are failing in the feature2 branch, that's fine, right? That is my branch. That's my responsibility. And other developers are still using the main branch to develop from, to deploy from, right? To use the latest code from. And once I'm done with feature 2, I'll merge it to main, and then it's everybody's responsibility, right? So this is the flow that Git enables us. So one problem that arises from this workflow is what we call merge conflicts, right? So we have a merge conflict. So what is a merge conflict? Imagine a situation where in this commit, right, I change app.js, right? So in this commit, I change app.js. And in this commit, in the second commit, right, in head, I also change app.js. And I'm working in the app.js file, right? And that's perfectly well and good. I'm working in the app.js, and that's because in this particular commit, right, on main, the main file was called app.js, right? What happens when in this commit, right, rename app.js to app.ts? In this particular case, the app.js file on main no longer exists. However, my feature branch does not know that, right? Because we know that Git does not automatically receive the updates, right? I did not, my branch did not update the parent of this particular commit, right? That's not even what we do in Git. If that was the case, I would have to rewrite the history of that branch, right? And so in my branch, I'm happily working on the app.js file, and on the main branch, app.js file no longer exists because it was renamed to app.ts in a different commit, right? So this is exactly when a merge conflict arises, right? Because I want to change something that has already changed on main. So what we have to do is we have to resolve these conflicts. In Git, there are different ways of resolving a conflict. So this is the way it looks in VS Code, right? When we have changes within a certain file, we get these nice markers. So for example, we know that in our latest commit, right, which is head, we wanted to make this change, whereas on master or main, right, we have these changes. So these are basically somebody on main changed the contents of a file, and we change the contents of a file differently. So this is slightly different version of a merge conflict, right? How do we resolve our merge conflict, right? Well, we would see that the app.js file was deleted, basically. And we would have to see, okay, what happened to app.js file? I would have to go to the history and see, okay, it was not deleted, it was renamed. I would have to rename my app.js file to app.ts file, and then add the code that I added to app.js to app.ts, and that's how I would resolve the merge conflict, right? But basically here, what I want to demonstrate is the situation that causes a merge conflict. You are editing a file, and the file that you are editing changes on the branch to which you want to merge. In the same way, here we are editing the readme.md, and we want to add the points. We want to add the points 2, 3, and 4, whereas on main, I assume, right? After point number 1, somebody has added a different point number 2, right? So you as a developer have to resolve what is the correct content of the file, right? You might say my contents is better. You might say the contents on the main is better, right? You might have to collaborate with the developer who pushed the contents onto main and collaborate what is the best scenario of going forward. What is the best contents in your particular use case? So once you resolve a merge conflict, you essentially have to create a new commit, and then you push that commit into your branch, and then you can merge. All right, so those were basically the 3 cornerstones of collaboration within Git, right? So we have the Git branches, then we have Git merges, and sometimes merges lead to merge conflicts. All right, so now that we are equipped with the knowledge of branching and a series of commits, right, being named as a branch and merges, we can take a look at some collaboration strategies with Git, right? And so this is a section that I'm going to go through very quickly, because this is a topic that we could spend hours and hours on, right? And different engineering teams choose to implement different strategies. And so I would definitely encourage you to look into the PDF, into the provided PDF, and read through the strategies that are interesting to you. I would definitely encourage you to read up on the topic if it interests you. But here I'm going to just point out a few important details of these collaboration strategies, right? So out of this centralized workflow, the only thing that I would like to point out is that in the similar manner that we can name a series of commits, right? Which is a branch. So we can have a branch that's a named series of commits. We can have a tag, right? And a tag is a named commit. Okay, that's all a tag is. So basically, what you say, for example, is when you want to release, you can say on the main branch, for example, this particular commit is called, whatever you want it to be. For example, release underscore date underscore whatever, right? Windows 11, Linux, Ubuntu, Fedora, whatever, right? And that is your tag. And so this serves as a point in time so that you know which particular commit you released into production. So that instead of memorizing or instead of noting down a hash, you can simply refer to a tag, right? So this is quite straightforward. Again, I would encourage you to read through the centralized workflow on your own. I definitely want to spend some time on the feature branch workflow. And this is for the simple reason that we have basically talked about it in the previous subsection, right? In the previous video. So in the feature branch, we have the main branch, right? And the main branch has, as we have said, a deployable and stable code, right? So again, historically, this used to be the master branch. This can be the main branch. This branch name is irrelevant, right? This can be whatever name you choose it to be. But there is one branch that has a stable code, right? Stable and deployable code. This the tests on this branch always pass. The code is in a deployable state. Whenever there is a new feature, right, as we commonly have in software engineering, we have a dedicated branch, right? And on that branch, we can have multiple collaborators, one or more collaborators that create commits on that branch. And when we are done with that branch, we create a pull request or a merge request, right? So in GitHub, when you're working on GitHub, this is called a pull request. In pure Git terminology, it's called a merge request. But essentially what we want to do is we want to take all of the commits on that feature branch and merge it into the main branch, right? So we know this flow from our previous video. That's why I wanted to repeat it. Remote repositories such as GitHub enable us to implement this workflow quite easily, right? So you can, in GitHub, you can open up a pull request. You can provide a title for the pull request. You can provide a description of the pull request. You can then create a pull request. What's more, you can have reviews for the pull request. You can assign people to pull requests, right? So if you are using, for example, GitHub to develop your project at work, then you can use this interface for collaboration on your code. In the same way, you do not have to use GitHub. You can use GitLab. You can use other platforms that enable you the same style of collaboration, or at the very least, very similar collaborative style, right? Notice that we are still talking about one repository, okay? We have a single repository where we have the main branch and we have one or more feature branches, okay? So I work on a feature for the front end, for example. So I implement the front end feature. You might work on the feature for the back end. So you create a different feature branch for the back end feature. A third developer might work on the gateway gateway feature, right? Might be gateway microservice that creates another feature branch. This is still within one repository. The implication being that all of us must have push permissions to the one repository. I mean, this is not necessarily true, but all of us are developers into one repository, right? And so we'll get to that in a bit, right? But for now, it's important to mention that all of this is within one repository. So after that, we create the pull request, right? In GitLab, this can be called something else. This can be called merge request, but that's just terminology, right? Then after we create the pull request, we have a tab in GitHub, for example, where we have our new pull request, and we can merge it, right? We can see what exactly changed. We can see how many commits are there in the new feature, right? This is the feature branch that we want to merge into the master branch. So that's great. And after that, we can merge it or we can refuse it, for example, depending on what we want to do. But when we merge it, for example, when somebody says, okay, this code is good, we want to merge it, the tests are passing, this looks like the code is stable, right? We merged it into the main or master branch. The feature branch is no longer relevant, right? Because the code is already in the master branch or in the main branch. Therefore, we can delete the feature branch. The code is already in the master branch or in the main branch. The feature branch no longer serves any function. If we want to iterate on that feature, we can create a new feature branch from the main branch, right? So we have the Git workflow. That's another flow that I would definitely encourage you to read about. I don't want to spend too much time on Git workflow, but it essentially combines the two previous workflows where we can name the individual commits, right? So that's fine. But what I definitely want to spend time on, and this is because it's relevant for our course, is the forked repository workflow, right? And this is very important to us. So in this feature branch workflow, right? Notice that I said we have to have push permissions to a single repository. The reason for that is we need to create branches within one repository. So technically speaking, we don't have to have push permissions to the repository. I could create the commits locally and I could mail it to a developer with push permissions and they could push it for me. But usually that's not how we do it. Usually, most commonly, right, we give push permissions to our repository, to the developers, and then they have the ability to create new branches, right? They have the ability to delete other branches, etc., etc. This is not suitable for all projects. This is especially not suitable for large open source projects. So for example, consider something like OpenShift, right? So OpenShift is an open source project. What that means is that, among other things, anybody can go and take a look at the source code. Anybody can clone the repository, but we definitely don't want anybody, just anybody on the internet, to be able to modify the source code of OpenShift, right? What we want is to have a set of dedicated developers, right? And these developers do not have to be from, for example, from Red Hat, right? These can be open source or upstream developers. These can be hobbyist developers. That's perfectly fine. But we want to trust these developers. We want to establish trust first before we give somebody the ability to modify the code, right? However, we have a problem here. We first have to establish trust to modify code, right? But we also have to modify code to establish trust. How do you establish trust in order to modify code without having the permission to modify code, right? Like, to be able to collaborate on open source software is to modify code. That is the cornerstone, or one of the cornerstones, right, of open source development. Of course, you can help in other ways. You can create issues. You can help with documentation, right? You can do many other things. But then the issue gets there as well. You do not have the trust to create and modify documentation from the beginning, right? And so without you do not get the trust to create documentation without proposing changes to the documentation, right? And we don't want anybody to be able to just modify the documentation, right? And this is exactly returning to our Git collaboration flows, right? This is exactly where the forked repository workflow comes in. So what we can do is we can create a fork, right? So what does that mean? Notice that when we have for example, a GitHub repository, the repository consists of two parts. There is OpenShift, origin, and these are divided by a slash, right? In this particular course, we are going to be using something like Red Hat training / and then do101x/apps, right? So it's interesting to note that a repository has two parts that are separated by a slash, right? The first part, right? We have the first part and we have the second part. The first part is the organization or the user, right? The second part is the actual repository name. So in the case of Red Hat training / do101x-apps, the organization is Red Hat training. The repository name is do101-apps. Now, you do not have the permission to push into Red Hat training / do101-apps. So what you can do is you can fork it, right? And what forking does is it preserves the second part and modifies the first part. And so instead of Red Hat training / do101-apps, it will be your username -do101-apps, right? In a similar manner, you could, so let me delete this, right? In a similar manner, you could fork this OpenShift / origin, right? And it would be your user origin. And so what would happen is that you create a copy of the repository under your Git user. And this is the exact copy of the source code. You get the permission to create any changes you want to that repository. Consequently, you can propose changes from your forked repository to the original repository. So this bridges the gap between gaining trust, right? So let's say you want to become a developer for the OpenShift project, right? Or for the Kubernetes project. What you would do is you create a fork, and you see that here over 4,000 people have done it, right? You make modifications to the source code in your forked repository, and you propose these modifications from your forked repository to the original repository, right? When the maintainers of the original repository, right, of the OpenShift /origin, when they understand that your intentions are good and you are capable of making changes that are good and stable and that move the project forward, right? Then you gain their trust, and then you can get access to push directly into that repository. So different projects manage this differently, but this fork workflow is very important and very common in the upstream open source community, right? And so I'm mentioning it because it's very important for our course. In our course, you don't have the permissions to push into our Red Hat Training DO101X-apps repository. And so what we will do is we will create a fork, and in that fork, you can push whatever code you want, right? So the intent of our fork will be simply to distribute our code and make it available for Red Hat OpenShift, right? For our OpenShift in the cloud. However, in the upstream community, the forked repository workflow is very common in order to establish trust. And there we have it. So these are just some of the ways that Git enables us to collaborate with others. All right, so now that we know about Git branching and various collaboration workflows, let's take a look at how VS Code enables us to create and use branches. So managing branches in Visual Studio Code is actually quite simple. So we see that we are in the source control view, right? So this is this particular view. This is the SCM view. And when we take a look at the source control repositories, we see that each repository has a branch, right? And so these two repositories have the master branch. And so this is basically all that there is to it. Essentially, you can click this branch, and once you click this branch, you can create a new branch, right? And remember that when you are creating a new branch, the branch that you're creating the new branch from matters a lot, right? Because as we have said, you have to have a parent commit, right, to your new branch. So it matters a lot when you're creating a branch from the main branch or master branch, for example, or from your previous feature branch. So be sure to remember that if you are creating a feature branch, you first have to switch to a different branch, right? You first have to switch to our master or main branch, and then you can create a branch, right? So if you take a look here, and if this indicator is not on master, that's a good indicator of, okay, I first need to switch the branch, right? And when you click it, you see that there is actually a list of branches that are already there, right? So not only can you create a new branch, right? You can also switch to other branches. So that's essentially the majority that there is to it in VS Code. You can also, of course, create a new branch from, right? So you can create a branch from a different branch. But I would, just for simplicity's sake, especially at the beginning, I would recommend you first to switch explicitly to, for example, a master or the main branch, and then you create a new branch. The last thing that I wanted to mention is summarized in this note, and it says that basically we should name our branches properly, right? And so, for example, a lot of engineering teams create naming conventions for their feature branches, right? So, for example, we might have a convention where every branch starts with a branch type. So, for example, it can be a feature type or a hotfix type or a release type, right? And then we are separated by slash, and then we can have some kind of identifier. So if it is a feature branch, we must have a feature ID, right? So there must be an ID associated with the feature. If there is a hotfix, we might have an issue number, for example, a Jira. And if we have a release, we might have some release string, right? And similarly, we might have some kind of a description, some further description in the branch name, right? So we can have a number of standards in the branch naming, and these branches names for the branches can be delimited by a number of separators, such as the slash character, underscore character, or the dash character. And so when you create your branch in Git, one thing we have to remember is where does the branch get created? And the answer is only in your local Git repository, right? As with everything in Git, it is only in your local Git repository. And so in order to publish it to a remote Git repository, we have to push it, right? If there is a remote repository associated with your local Git repository, then you can publish the changes, right? So we can publish the changes or synchronize the changes, right? So even if you create the branch, until you push the branch does not appear in your remote repository, for example, on GitHub, right? And we can do that, for example, by clicking this button over here, right? And that's all there is to it. So let's take a look at actually forking a repository and cloning it into our local file system in our next guided exercise. All right, so let's take a look at how we can take our knowledge of Git and Git branches and Git forks and put it to use in practice. And so in our guided exercise, we will fork our repository from GitHub. And so this will create the copy of the do11x-apps repository under your local user, right? And this gives you the permission to modify the files, right? And create branches in that repository. We will clone the fork, right? and we will create some commits into our clone, right? Or in our clone, and push the commits which we have created on a new branch into our fork, right? So what do we need for that? So we need Visual Studio Code. Of course, we will be using Node.js and NPM. So just to execute the application we'll be modifying in order to create commits. And of course, we have to have Git installed on our operating system. So step number 1, we have to fork the do101x-apps repository, right? So we go to the github.com/Red Hat training/do101x-apps. And on this URL, what I'm going to do is I'm going to click the fork button. Okay. And I want to fork it into mchernek, which is my user. And there we go. I have my fork, right? I have the mchernek, which is my user, /do101x-apps. And we see that this is forked from Red Hat training /do101x-apps. And so this is our fork. And what this means is that this copy of the repository is where we can push branches and push commits and make modifications, right? So this is exactly what we want for our course. Every change that we will make within this course is into your fork. You'll most likely want every change to stay in your fork. So step number 2 is clone, right? And so to clone the repository, we use the command palette in VS Code, and then we have the git clone command, right? And so the way we do that, again, is I go to my fork URL, and again, verify that this is your fork, right? So this is under your user /do101x-apps and not the Red Hat training, right? This is your local fork. Then what I want to do is I want to copy the URL, right? And this URL should be the HTTPS URL. It should not be the SSH. It should be the HTTPS URL. Then in my VS Code, we can close this. And in the command palette, right? View command palette, we can git clone. So the git URL, just like before, is going to be the URL. And then we cannot forget about the token. So it's going to be your developer token at github.com and the URL. Okay. So if you don't know what token I'm talking about, either refer to the PDF or to one of the previous videos in the guided exercise where we created the token. Okay, so this is our clone, and then we select the repository location. So that is going to be fine. And then we want to add it to the workspace. Okay, and I trust the authors of the workspace. And then we have two directories in our workspace, right? We have our hello Node.js, and we have our do101x-apps. So if we switch from the Explorer view to the source control view, we see the hello Node.js and the do101x-apps repositories, right? The hello Node.js repository is on master, and do101x-apps is on the main branch. So that's exactly what we want. And we have successfully cloned the repository to our local file system. And this is our fork. right? So then we want to add a feature to the Express Hello World application, right? And we want it to display the Hello Mars message when a user accesses the /Mars application endpoint. And furthermore, we want it to implement in the defend -versioning branch, right? So this is a lot of information. Number one, we want a separate branch. Okay, we want a devend-versioning branch. So how do we create a new branch? Well, that's very easy, right? In VS Code, click main, and then we create a new branch, right? What is the name? devenv-versioning. Okay. And simply create a new branch. So remember that it matters a lot what is the source of our branch. Okay, the source is main, and that's exactly what we want. So because the source is main, source branch is main, I can simply create our devenv versioning, right? So now we have our devenv versioning branch, right? And we can move on, right? So then we have the Express -hello world application. What could that be? So we have Express -hello world, right? So in this application, let's take a look. We have the only thing that's here is the app.js, right? File. Then we have our gitignore, which is simply a file for Git, right? What should Git ignore? Hence the name gitignore, right? Some files we do not want to push to Git, and therefore Git should ignore them. And then we have package.json and package-log.json. We talked about these in our previous videos. And so in the package.json, we see that this is a simple Express application, right? We see that in the dependencies, we have only one dependency, which is an Express dependency, right? So this is going to be a simple Node.js application that declares a dependency on the Express package. So outside of that, we start the application by running node app.js. And so in the app.js, we see that we have a number of endpoints, right? Well, actually, we have just one endpoint, right? We have an endpoint with the dash, with the slash, and it returns hello world, right? And now we want to add a new endpoint with a /Mars, and we want to return hello Mars. So let's take this, and we can copy paste it. And instead of get at slash, we want to add get Mars, right? Because that's in our that's what we want to do, and we want to display hello Mars. So instead of hello world, hello Mars, right? So there we go. It would be nice if now we could test the application somehow, right? We have made some changes to the application. How do we test it? Well, we know how to run a Node.js application. So let's try it, right? So let's open up a new terminal. And we want to open up the terminal in the do11x-apps, but you know what? Let's do it a different way, right? Let's right-click the Express-hello world and open an integrated terminal. And there we are. We are already in the correct space, right? If I ls, I see that we have app.js. So from the package.json file, I know that I can start the application by simply executing node app.js. But if I try to execute this now, the application will fail to start. So let's try it, right? Let's try it. And we see that there is module not found issue, right? And the error is cannot find module express. And the problem is that we have a package.json, right? And we declare a dependency express, but I did not download this dependency. The fact that it is declared does not mean that I downloaded it, right? So how do we get around it? We get around it by using npm, right? So we can execute the npm install command. So if I execute the npm install command, what the npm install command does is it takes a look at the dependencies, it reads the dependencies section, and fetches every single dependencies declared in the dependencies section, right? And so let's execute it, right? And what happened is there is a new directory called node modules, right? And here there is a number of new files, right? Or new directories as well as files. And one of these is express, right? And so this is where our packages live. And so now I could execute node app.js, but what we want to actually do is execute npm start, right? Because we want these node modules to be accessible to the application. So there we go. It is a success. Example app is listening on port 8080. So that's great. So how do we test the application? Well, that's quite simple, right? We know that the application is listening on port 8080, and we have two endpoints. We have an endpoint on the slash and on /mars. So let's open up our browser and go on the localhost 8080 / and we get our hello world message, right? And what if we go to our Mars endpoint? We get our hello Mars message. So let's verify that that's what we wanted, right? And indeed, this seems like we wanted this behavior, right? When we navigate to localhost 8080, we get hello world. When we navigate to localhost 8080 /Mars, we get hello Mars. So that's reasonable, right? It seems like our application seems to be working fairly well, or reasonably well at the very least. All right, so our testing seems to be fairly successful. So let's stop our application, Control C, right? I have stopped our application. I can close this terminal window. And what we now want to do is commit the changes locally and then push the changes to our GitHub repository. All right. So we want to create a new commit with the message add Mars endpoint. So that's great. How do we do that? Let's take a look at our source control view, right? And we have some changes. So remember that whenever we make changes, Git does not know which changes we want to add to our commit, right? We want to stage them. So we first have to stage the changes. So I add the app.js because that's the file that changed, right? These 3 lines are new and they are now in the staged changes. Then I create the commit message. So what was the commit message? Add -Mars /Mars endpoint, okay? And then I can create the commit, right? So we have created our commit. We are on our devenv version branch. So now we are ready to push the changes, right? And we can do that in multiple ways. We can publish the changes. We can publish the changes here. So let's publish the changes from here. That's perfectly fine. And there we go, right? The changes are synchronized. So let's take a look at our forked repository. So back in our GitHub fork repository, right? I see right away there's a new branch. What I can do is I can click the branch, right? And I can take a look at our commits. So I can click here at our latest commit, and I can see what exactly has changed. I want to bring your attention to one last thing, right? And that is when you click this compare and pull request button, in this header at the beginning, what you are asking GitHub to do is you are merging the changes from your new branch, right? From the dev-env versioning branch, from your forked repository into the main branch, however, into the Red Hat training -do11x-apps, right? And so remember in our previous video, this is all about the upstream workflow, right? This is how in upstream you can suggest changes to the original forked repository, right? You create a fork with the intent of modifying the original repository to which you do not have access. You do not have the right permission. In our case, however, this is not the case. We do not want to modify the Red Hat training repository, right? And so therefore, be very careful when you want to create pull requests, especially within our case, right? Especially within the do11x-apps. If you want to play around with pull requests, that's perfectly fine. But make sure that you select the base repository to be your own Git repository, right? And when you do that, you see that you are basically creating a pull request from one branch to another branch within your repository, and that's probably what you want to do within the context of our class, right? And then you can create a pull request and play around with how that would look, right? So I definitely don't want to do that. And we are going to be using this branch in our next guided exercises. So do not delete this branch. But I just wanted to bring your attention towards the compare across forks functionality of GitHub. All right, so that concludes our guided exercise. In this guided exercise, we are able to create a fork of a repository, create a new branch. In the new branch, we were able to push new code into that branch, synchronize that branch in our remote repository, and view that change, that new branch, into our remote GitHub repository. All right, so welcome to our next section. And in this section, we are going to be talking about OpenShift, okay? What OpenShift is and why we'd want to use OpenShift. And we are finally going to be deploying some applications to OpenShift. All right, so let's start with introducing Red Hat OpenShift Container Platform. All right, so right now, what I want us to think about is I want us to conceptually think of OpenShift as a platform, right? It is a platform that Red Hat built. Red Hat took Kubernetes, and if you've taken our previous courses, you should be quite familiar with Kubernetes. So everything that Kubernetes does, 100%, OpenShift does as well, right? So we took Kubernetes and we added features on top of Kubernetes, right? And so from our perspective, from the perspective of this course, I would like us to think, at least for now, of OpenShift as a platform that makes it, that simplifies the process of build and deployment of our applications for us, okay? So OpenShift is a platform that tries to get out of our way and let us, the software engineer, focus on our workflow, right? We work in Git and we create our commits, we create our applications, we push our code, and OpenShift can automatically pick up these new commits, right? Build our application and automatically deploy these applications. And so as a developer, what I want to do is I want to focus on writing the application. What I expect from Red Hat OpenShift at this point is to take care of my application, build it, and deploy it, right? And we're going to take a look at how we can do that. So, of course, there are a couple of caveats, right? OpenShift works with Git. That's why we spend so much time on Git, and Git is quite central to OpenShift from our developer/software engineering perspective, right? We have to use some supported languages, right? So not all languages not every single programming language is supported on OpenShift. So for example, we have languages like Java, we have Ruby, we have Python, we have PHP.NET, Node.js, and others. So there are a number of very popular cloud-native languages, right? Or languages that many cloud-native engineers and developers use nowadays that are supported in OpenShift, and that is excellent, right? But if you are using maybe some less popular language, you cannot expect OpenShift to enable you this workflow. And so platform architecture-wise, to be able to use OpenShift, of course, we have to be able to deploy OpenShift somehow, right? We have to get OpenShift somewhere somehow, right? And there are several ways of doing that. We can use the Red Hat OpenShift Online offering, which essentially we can come to Red Hat and we say, I don't care about anything except for give me a login page, give me credentials, and I want to use OpenShift. You make it available, you make it fast, you make it scalable. I just want to use it, right? So this is a platform as a service offering, similar to a number of other cloud providers such as AWS and Google Cloud, right? That can provide these offerings for Kubernetes, right? It provides the same offering for OpenShift. Similarly, we can use the developer sandbox. And as the name suggests, this is a developer sandbox. So this is an environment used for studying purposes, for learning purposes, right? Most commonly for developers. And in this course, this is exactly what we are going to be using, right? We are going to be taking the developer sandbox. We are going to create an account at developers@redhat.com. And we're going to provision our own developer sandbox where we are going to develop and deploy our code. Last but definitely not least, of course, if you are interested, for example, within your organization or company, school, etc., you can of course deploy the Red Hat OpenShift Container Platform as a standalone software on your own infrastructure. So basically, Red Hat says, here is the software, right? You get your own machines, you get your own infrastructure, you maintain the networking, you maintain the machines, the virtual machines, you get any supported configuration, and you deploy the software on it, right? And then it will work. So obviously each of these has certain advantages and disadvantages. For now, for our purposes, the developer sandbox is free and it fits the needs of this course perfectly, right? So from the perspective of an application, right? Of course, as I said, OpenShift builds on Kubernetes. And if you have taken our previous courses, you know that Kubernetes deploys pods, right? A pod is the smallest deployable unit of Kubernetes, and it's the same with Red Hat OpenShift. Pod is the smallest deployable unit in OpenShift, right? And a pod runs one or more containers, right? And so a container is simply an isolated process. So we have a pod, right? We have a pod. Within that pod, we have our application code. This application code requires some type of dependencies, right? This could be, for example, if our application is Node.js based application, it probably has some kind of Node.js packages, such as Express or some other packages, but we also have to have some Node.js runtime, right? We have to have the runtime that executes our JavaScript files in order to execute our codes. And all of these, right? All of these together create one container. And a pod encapsulates one or more containers. So in this course, usually one pod means one container. So in OpenShift, a pod has its own IP, right? IP address. A pod has its own storage. A pod is independent from any other pods, right? So a pod is it's a very important concept in OpenShift. So how does that work? As a developer, what we do is we push our code into Git, right? Once we have coded our application, we can go, for example, into the web application, web UI, right? Which is right here. And we can create our application. And in the web UI, we can select a number of parameters, right? We can say, create an application from this Git URL, and I want this application to be managed by this deployment. This deployment will deploy a number of pods, right? And it is on this branch or that branch. I want this application to be available on the internet, for example, etc., right? Sometimes you do not want an application to be available on the internet, such as a database, right? And other times you do want the application to be available through the internet, like the front end application, right? Once you do that, the web UI, for example, but not necessarily web UI, but it's one way to create an application. You configure, for example, in the web UI, you configure, for example, the branch name, right? dev version. And so the web UI fetches the appropriate Git repository, checks out the branch, right? Checks out the appropriate directory. And if it finds everything that it should, and if it finds a supported language, right? It creates the application and in the end spawns a pod, right? And the pod is running, and this is when the pod is finally running. This is when you can access your application. And so we have a number of OpenShift resource types and OpenShift resources, and for now we can just stay with the pods, right? Pod is where the application is running, so that's your container, and a container is your isolated process, right, with its own unique IP address and its own unique storage. And a pod is ephemeral by default, right? So that means that by default, unless specified differently, it is not persistent, right? So this is a pod, very important OpenShift resource type. And a route is a different resource type which associates your pod with a public URL. So if you want to expose your application, you create a route, and that route will associate your pod with a URL. And so for now, I think this is just about enough for resource types, but we will definitely delve deeper into all of the resource types. And if you have taken our previous courses, for example, for the Kubernetes course, all of the resource types on Kubernetes apply to OpenShift. So a deployment manages pods, right? A service routes requests to pods, right? A route, is similar to ingress. So that's the basic workflow of deploying an application by using the web UI. All right, so at this point, we have some theoretical knowledge of the OpenShift container platform. Let's take a look at the web console. And this is going to be the interface that we are going to be using a lot in this course, right? So I thought that I would actually take a look at the developer sandbox. And so I have logged in to the developer sandbox and provisioned my sandbox environment, right? And so I can log in to my developer sandbox environment. And one thing that I want to immediately point your attention to is that the developer console has two perspectives, right? If you click this perspective, it has the administrator and developer perspective. In the administrator perspective, this is, as the name suggests, more of an administrative perspective. So, for example, you can verify the installed operators. If you have the administrator rights on your OpenShift cluster, you can, for example, deploy new operators. You can also take a look at all of the workloads within your cluster. You can verify your networking, etc., right? In this particular cluster, we do not have the administrator privileges, right? And so therefore, this administrator perspective is mostly informative. It informs us of, number one, what has been created for us and what is the status of the cluster, what is deployed in the cluster, etc. And number two, what we have created, and for example, how we can delete it, right? So this is the administrator perspective. And I would definitely encourage you to browse through the administrator perspective. And then we have the developer perspective, right? And so in the developer perspective right now, it seems it is quite empty. What I want to bring your attention to is this add section, right? This add button. And so we can click the add button and we see that there is a number of possibilities, right? And there is this subsection called developer catalog. And this developer catalog contains a number of possibilities for us, right? So Red Hat OpenShift Container Platform comes with a number of pre-packaged templates and services that are ready to be deployed, right? We have a number of databases ready to be deployed. We have a number of languages that are supported, right? We have a number of middleware products that Red Hat supports out of the gate, right? Just by default. And so, for example, I can take a look at some templates. Let's see all items. And for example, I can select this HTTPD template. And when I click the instantiate template, it brings me to this form, right? And this form is exactly what we talked about. This is where you would specify, for example, the Git repository URL, right? The Git reference, which is the branch name, right? Or a tag name or something similar, directory or host name or something similar. So I will change the name, and this is just a demo. You do not have to follow along with me because we will have our guided exercise, but this is just a interactive demonstration of what the OpenShift web console looks like. And so when I'm ready with the application and I'm quite happy with the way it looks, I can see what exactly the template will create, right? I can click the create button, and this kicks off the build and deploy process. And so right now we see that the build is pending. So let's wait until the build is complete and our application is ready and available. All right, so several things have happened with the application, right? Number one, I can actually click the application, right? And we see that there are a number of tabs. There is one pod, which is running. We see that the pod is in a certain namespace. It has some labels, etc., right? And from our previous video, we know that the pod is what we care about the most, right? The pod is the actual application that is going to serve the content that we want to see, right? But notice that there is also the resource tab. And in the resource tab, there are also other resources that the template has spawned for us, right? So we have some builds, and we see that there was one build that has completed, right? And we see a service and a route. And so from our previous video, we know that a route should lead to our application. So this is the URL that makes our application accessible on the internet. So if I click on this application, it should actually lead me to my application, and that's correct, right? So based on basically pre-packaged template in the OpenShift Container Platform, we have built and deployed an HTTPD-based static website, right? And so each of these resources has certain actions, right? So not only can I click on this location, but I can also click on the route. And this route has certain actions associated with it, right? And so, for example, I can delete this route, and that's perfectly fine. And if I return to the topology view, suddenly this application is no longer accessible from the internet. So one more thing that I wanted to mention is that we have deployed the application into a certain project. And in the developer sandbox, we cannot create more projects. We only have 2 projects, and a project is basically the same as namespace in Kubernetes. It's essentially where we encapsulate all of our resources, right? So if I create an application into one of my projects, which is my username -dev, my application lives in that particular project, Okay, so if I switch to a different project, which is, for example, my username -stage, my application will not be there. And so this is something to keep in mind. This project, this course uses the -dev project, but because we are using just a single project, it means that we have to clean the resources after we are done with the application. So at the end of every guided exercise, we will be deleting our application just so that the name will not clash with other application, right? So what I mean is, if in one guided exercise we create an application called instructor HTTP demo or HTTP demo, and we do not delete it, in another guided exercise, we cannot create the same application with the same name, right? Because otherwise it would clash. And so we want to prevent that. And so what I can do is I can click Action and delete deployment config. And that's perfectly fine. I also want to delete the dependent objects of this resource. And that will delete the actual part as well. We can also take a look whether there are some config maps and secrets. And there seem to be 3 config maps, right? So we can delete these 3 config maps. And there is HTTP example seems to be also one of the secrets that got created. And there we go, right? So in the future, I will give you a better way of cleaning the cluster by using the command line interface. For now, we are just going to use the web UI. All right, so that was our introduction to the Red Hat OpenShift Container Platform and the Web Console. Let's go ahead and deploy our own application to OpenShift in our guided exercise. All right, so welcome to our next guided exercise. And in this guided exercise, we are going to be using the Express Hello World application. All right, and this is the application that we have developed in our previous guided exercise. And so if you are unfamiliar with this application, return to our previous guided exercise, either in this PDF or in one of our previous videos. And so in our previous guided exercise, we have modified the application and we have pushed the application into the forked repository, into the do101x-app repository. So this is our forked. And on top of that, we created a new branch called devenv-versioning branch. Okay, so let's quickly take a look at what happened. So this is our application, right? We have added the /mars endpoint. And so this is what we are going to be testing, right? Our application is in the express-hello world directory. And let's just verify in the source control view that the branch exists on the devenv versioning. The branch with the name devenv-versioning exists, right? All right, so let's get to our guided exercise. In the step number 1, right, in the first step, we are instructed to create a developer sandbox account. So in this course, we are going to be using the Red Hat Developer Sandbox, which is an OpenShift sandbox environment. And for that to work, all you need is a free Red Hat developers account, and then you get an essentially free OpenShift sandbox environment where we can deploy our applications and test the behavior of our applications in the OpenShift environment. So I have opened up my Red Hat OpenShift sandbox environment. And if you are unfamiliar with this web UI, be sure to check out our previous videos on the web UI. You might be in the administrator perspective. And if you are, be sure to check the administrator perspective and switch to the developer perspective. I'll also be working in the -dev namespace or project. So the project that we are working with is your username -dev, right? So at this point, what we want to do is we want to deploy our application, right? So let's take a look in step number 2, right? What we want to do is we want to create a new application. The application is a JavaScript-based Node.js application, right? We want to name it Hello World. That's fair enough. We want to use our Git repository, specifically a Git repository hosted on GitHub, right? And the application, as we have seen, is in the express -hello world directory, right? So in the Git repository, there is a directory called express hello world or express -hello world, which hosts our application. And we cannot forget that we made our changes in the devenv-versioning branch, right? This is very important because this is where we actually pushed our change. So that's all well and good. Let's deploy our application. So in the OpenShift environment, what I want to do is I want to click the Add button. And this brings us to our developer catalog, which enables us to create our applications. So we can click All Services, and OpenShift comes with a number of services that enable us to create a number of applications. And so I can select languages, and we want to deploy a JavaScript-based application. And we see Node.js applications, right? And what I want to do is I want to select the builder image, right? I have my Git repository, and out of the Git repository, I want to build my own application. So I will select my builder image, and I will click the Create Application. So this is the source to image application, and that is exactly what we want. So step number 1, we have to provide the Git repository URL. And this is the URL to our forked repository, right? So I can go to my forked repository and select the HTTPS version of our cloning URL and paste it in. So OpenShift does some validations for us, and we see that the URL is validated. However, we also have some advanced parameters, such as the branch and the directory that we want to build inside of this repository, right? So let's click Show Advanced Git Options. And the first option that we have is the Git reference. And so this is the branch that we want to build. And the branch name is, and let's just double check, is the devenv-versioning, right? So the second parameter is the context directory, right? And this is the directory that we want to build. Again, let's double check. And this is the express-hello world subdirectory, right? This parameter starts with a dash. And this dash is very important because this is a path within the Git repository. So leave the dash in. This directory starts with a dash, and then has the name of the directory. And then all we have to do is change the name. So we have application name is Hello World, the name is also Hello World. And then we are also instructed, if I'm not mistaken, to create a deployment config. So that's fair enough. We can do that. And because we want to make this application accessible on the internet, we verify that the create a route to the application is checked, right? So one last check. The Git repository URL is a fork repository, right? The URL contains your user. The Git reference is the branch name. So that will be devenv-versioning. And you should double check that this branch name actually exists. So if you created a branch that's called devenv-version, and here in the OpenShift Web UI, you specify the branch name versioning, for example, the two will mismatch and you will not be able to build your application, right? So I have verified that the devenv versioning does exist in VS Code, right? Then the context directory parameter starts with a dash and then contains the name of the directory. In our case, it is the express-hello world. And sorry, it starts with a slash, not a dash. So starts with a slash and then contains the name of the directory. And then we have simply a name of the application, right? And so this all seems fairly good. Let's create our application. And there we go. So we have our application. If I hover over this green check mark, I see that the build is complete, right? I can also click on this application and click the details tab. And I see that one pod is running, right? And so from our previous videos, you know that a pod contains a container, one or more containers, and a container is the application, right? And so a container is a process that contains the application. And so this seems like our application should be accessible from the internet, right? And so we have selected that the route should be available. And so I can either return to this resources tab, scroll down, and there is a route, right? Or I can simply click this open URL button. And so I can open it in a new tab and fair enough, there is our hello world message, right? However, this is not, this is just part of the application that we wanted, right? This is the original application. Now, what I'm really interested in is the Mars endpoint, because this is my part of the application. This is the part of the application that I added. So let's test that part of the application. And there we go, right? If I add the /Mars endpoint and I hit enter, I see the Hello Mars application. So we see that we were able to instruct OpenShift to basically go and clone our Git repository. And we were able to take our branch, right, and build and deploy our code to on Red Hat OpenShift, which is in the cloud. So this is an excellent first step on becoming a cloud native developer with Red Hat OpenShift, right? So there's just one last thing that I want to do, and that is because we are using the developer sandbox, and the developer sandbox has one restriction, which is the namespace or the project restriction, right? We are using the same project throughout the course, and so what I want to do is I want to clean up the project. So I want to delete all of the resources that we have created throughout this guided exercise. So we can do that in a number of ways, right? We can, for example, click this project view, and in the project view, we can delete the resources one by one. So later, I will show you a better way of deleting the resources, but for now, we can delete them one by one. So let's start with the route, right? I can delete the route, and I can click these three dots and delete the route, right? And one thing that I wanna mention, so I can refresh my browser to see whether the route has already deleted. One thing that I want to mention is that previously I have noted that a route is a way to get back to my application from the internet, right? And so back on the topology view, we can verify that the application is still running, right? We see that there is a one pod that is running. However, in the resources, the route is no longer there. And so I still have my, my window open that previously worked. Now that I have deleted the route, I can refresh. my application is no longer available, right? So this is just a nice verification that the route actually does what it's supposed to do. When the route does not exist, the application is not accessible from the internet, right? Okay, back to deleting our resources. So that was our route. We can delete our service as well. So in the same manner, let's delete our service, right? And let's go into our project again. We have 0 services, so it seems like our service has been deleted. That's excellent. Let's click our deployment config. And in the same way, I will delete the deployment config. Here, I definitely want to keep the delete dependent object of this resource checked, right? So this deployment config manages the pod with the application. And so when I delete this deployment config, it deletes automatically the application pod. So let's delete this deployment config. And back in the project view, we still have some secrets. We have 2 secrets to delete, which is the Hello World generic webhook secret and Hello World GitHub webhook secret. So I can delete them one by one. And definitely let's not forget about the builds, right? We have the Hello World build, which is represented by the build config object. So let's delete that one as well. So back in the project view, this looks fairly well. Back in the topology view, we see that our topology is clean. All right, so this concludes our guided exercise, and I'll see you in the next video. So welcome to our next video. And in this video, what I want to do is I want to come just a little bit closer to understanding what happens when we deploy a new application to OpenShift from our source code, right? So in our previous guided exercise, what we did was we had our source code and we deployed it to OpenShift, right? But we know that OpenShift builds on top of Kubernetes. And we know that in Kubernetes, pods build or use container images. And so if you are not familiar with Kubernetes, I definitely recommend taking a look at one of our previous courses where we delve a little bit deeper on Kubernetes. But right now, just know that pods use container images, and a container image is essentially a binary package that contains the application layer as well as everything that the application needs in order to execute, right? And so the pod takes this container image and instantiates it and executes it, right? So there's a bit of a mismatch. We gave OpenShift source code and OpenShift created a pod that expects a container image. How is it possible? Well, there is a hint. When we were cleaning our project or namespace in the previous guided exercise, we clicked the build view, right? And we were deleting build config resource, a build config resource. And so this suggests that there is some kind of a build happening, right? So let's take a look at what kind of a build is happening in OpenShift. So when we have our source code, what we are doing is we are using this process called source to image, or S2I for short. On one hand, we have source code, which is the input to the build process. And then there is this build process, right, that happens. And as the output, we have an image, right? So this solves a little piece of our mystery, right? We input our source code, we execute this S2I build process, and therefore the pod gets its own image and the constraint of the pod is satisfied, All right, so what happens with this source to image build process, right? We have solved one mystery. Pod gets its image because the container image is created in the S2I build process. Well, what happens in the S2I build process, right? Well, the S2I build process requires what we call the S2I builder image, right? And remember that in the previous guided exercise, what we did was we clicked the developer catalog, right? And we clicked the JavaScript language, and we clicked the Node.js builder image. And that's because we were selecting the source to image method, right? What we have is essentially Git repository, and we want to build it into an image. So what happens is that this builder image kicks off a build process, right? And in the build process, the build process clones the repository. That's step number one, right? It gets the source code. It downloads all of the dependencies. So let's actually take a look at our Node.js application, right? In our Node.js application, the build process takes a look at our package.json file, right? It determines all of the dependencies of our application from the package.json file and downloads them, right? In our example, in our previous guided exercise, it was just the Express package, right? And after this is done, we have an application that we can execute, right? We have the Node.js runtime, and we have the application source code with all of its dependencies. And so we can combine this basic Node.js runtime with our application, and we can create a container image. And so this build process pushes a new container image, right? We have our new container image. And where do we push this container image? Well, we push it to a built-in container registry. Well, where is the container registry built in? It's built into the OpenShift platform. It's internal to OpenShift, right? And so at this point, OpenShift can say, all right, we have a new image, and there is a deployment or a deployment config waiting for this image, and this pod can use this new image that we have just created. So in a very simplified manner, this is the S2I process, right? And we are going to delve a little bit deeper into the S2I process a little bit later. But for now, this is how we can think about the S2I process, right? So this brings us to one of the problems or one of the challenges that we want to resolve, which is updating our application. How do we update an application that was deployed by using the S2I process? And there are essentially two ways that we want to mention right now. The first one is essentially manually, right? So what does it mean to manually update our S2I application? First of all, when we talk about updating our application, we are talking about modifying its source code, right? So we have to, as a prerequisite to modifying the application or updating the application, we have to modify the source code, and we have to push the modification into the repository. In our case, it can be GitHub. It could be whatever a different Git repository you want, right? Then you as a developer go to the web console, right? And you manually click a button. You say, I want a new build, right? What happens then? Well, you kick off a new build process. And so everything that we have configured before is there. So we still have our Git URL, right? This remote, for example, GitHub URL. We still have configured our branch. We still have configured our context directory, right, in the Git repository. But the new build downloads the repository again, right? There is a new Git clone, which means it gets the latest code changes, which means it can get the latest application. And so then it builds a new container image, right? And when we have our new container image, what happens is OpenShift is notified, right? In the internal registry, we get new container image, and therefore OpenShift is smart enough to know that what we probably want, most likely what we want, is to update our deployment. And then there is automatic OpenShift spawns a new pod, right? With the new container image. And if the new pod is successful in spawning, right? If the new container image can start running, then OpenShift automatically scales down the previous deployment, right? The version 1 deployment. So that was the manual trigger of the build, right? What we can also do is utilize this webhook mechanism. And this webhook mechanism is a way to call back certain code, or to execute certain code when something happens, right? And so, for example, GitHub implements webhooks. In GitHub, you can execute certain actions after, for example, somebody pushes new commits to your repository. And this is exactly what we want, right? So for example, imagine that we want to redeploy our application every time somebody pushes a new commit, because a new commit means that somebody changed the application, right? So what we can do is we can leverage or utilize this webhook mechanism that GitHub implements. And we can tell GitHub, after every commit event, call a URL, and this URL will be OpenShift's URL. And on this, when we call this OpenShift URL, OpenShift will automatically rebuild our application. So let's take a look, right? We are updating our application code on GitHub, and this is identical, right? So we push new code change on GitHub. Here, we configure GitHub with the webhook mechanism. So we have an OpenShift URL, and we say to GitHub, after every commit, call this OpenShift REST API, right? Call this OpenShift URL. And after this, right, everything stays the same. After this, OpenShift kicks off a new build process, and everything stays the same. So the build process clones the directory, clones the Git repository, right, from GitHub, builds a new container image, attempts to scale up the pod with the new container image. If it is successful, then it scales down the old pod, right? The only thing that has changed is who is pushing the build button and how, right? In the previous scenario, I as a developer or you as a developer are pushing the button, right? In this scenario, GitHub is virtually pushing the button, and the button is nothing more but a URL, and GitHub is pushing the button by using a webhook trigger, right? But the concept is the same. The way we do it is slightly different. And so, depending on what you want, different applications might have different use cases, and might be suitable more for different style of updating, right? So these are our two styles of updating our S2I application. Let's take a look at how these work in our next guided exercise. All right, so now that you're familiar with S2I and how that works, in this guided exercise, we're going to take a look at how it all works in a real OpenShift cluster. So what we are going to do is we are going to download the OC command line utility. And if you have followed our previous courses that were focused on upstream Kubernetes, you are familiar with kubectl, and in fact, you might have used kubectl with OpenShift. OpenShift is fully compatible with kubectl. However, kubectl does not enable you to use all of the OpenShift capabilities from the command line. So what we are going to do with OC is use the new app command, which right away enables us to use S2I to build and deploy S2I application from the command line. Then we're going to go into the web console. We are going to check in the web console, we're going to check the application, and we're going to trigger a new build manually, right? And finally, what we are going to do is we are going to leverage the webhook concept that we explored in the lecture, and we are going to configure GitHub, which provides, which implements this webhook concept, and we are going to leverage the OpenShift S2I URL such that with every new change to GitHub, every time we push something to GitHub, GitHub is going to invoke this URL of OpenShift, and this signals to OpenShift that it needs to rebuild our application. So in essence, what we are going to do is automatically trigger a rebuild of our application whenever we push a new change to our GitHub repository. So what do we need to do all of that? Well, first of all, what we need to do is do my favorite thing, which is install the command line interface, right? The OC command line interface. And so how do we do that? Well, let's take a look at our OpenShift Web Console. And OpenShift Web Console comes with this helpful toolbox, or this question mark toolbox. And one of the links that it provides is the command line tools. Now, depending on what system you use, you can download the OC for Linux, for Mac, or for Windows. So download the OC for your operating system. And I have already downloaded the OC for my operating system, which is Linux. So the next step is to unzip the OC binary. So let's do that in the terminal. And so on the Linux operating system, the binary comes in the tar archive. So let me untar it. And so what this has done is it has created this OC binary in my current directory, right? So if I can actually ls for it. So I see that I can list the OC binary, and in fact, I can also execute it right away. So I can specify ./OC, right? And I can say version on the client side, and it returns some version, and therefore I can execute the OC utility, OC binary. The problem with this approach is that I can only execute it by knowing the full path, right? So what I've done here, I have cheated a little bit. I know the full path, but what I'm using is the full path is in this current directory, right? Which signals the full stop and forward slash, right? Now, what we want to do is we want to be able to use the OC binary from anywhere on the system. So for example, if I change to a different repository, different directory, I want to be able to just say OC, right? And right now I cannot do that. because my system does not know where the OC is. And so we can do that by placing the OC binary on our path. So this is another step in our installation procedure. On the macOS or Linux, we can use the, for example, the usr/usr/local/bin. On the Windows system, this is a bit more complicated, and that's why we have provided this documentation link, right? And so essentially what you need to do is either place the OC binary on a Windows system, either place the OC binary into one of the directories that is already on your path, or simply create a new directory and place that new directory onto your path environment variable, right? So I am on the Linux system, so I can simply copy the OC into usr local bin. So let's do that. And at this point, I should be able to actually use OC. So I can simply say OC, and I got some result. So in fact, I can delete the local version of OC that I have unpacked. And I can re-execute the OC version, and I will still get the result, which means that this OC is actually from our path. So if you cannot execute this this command OC version --client, there are two possibilities. Either you need to reload your Visual Studio Code, or you have misplaced your OC binary. For example, either it's not on your path, or the directory that you want to put on your path you have not, for example, on the Windows system, and so you need to put that directory on your path. So right now I have my OC binary installed. That's a great news. So can we deploy our application? Well, the problem that we have right now is that the OC binary does not know which cluster to communicate with, right? Which OpenShift cluster to communicate with. So in reality, you can use one OC binary to communicate with multiple clusters. So for example, you could download an application to a stage cluster. You could then have a ticket to configure an application or to update an application to a production cluster. And then you might log out and log in back to your stage cluster and do some work over there, etc., right? So right now, if I try to do anything with my OC binary, it does not know which cluster to communicate with, which makes sense to me. And so we need to authenticate with our OpenShift cluster. So how do we do that? The easiest version, again, is to return to our web console, and I can click at my username, and I can click the copy logging command, right? And so this brings me to a window where I need to re-authenticate. That's perfectly fine. And after re-authenticating, I can display a token. Now this token is sensitive. Treat it as your password. It is time bound, so if it leaks, it's not the worst thing in the world. But again, if somebody steals or gets to this token, they can do something to your cluster depending on your privileges, on the privileges of the user. So treat it with respect. Treat it as you would treat your password. Do not put this token in your GitHub, for example, or anywhere else that is visible to other people. So we can display this token, and we can copy the login command. After I copy the login command, I can paste it in my terminal, and because OC is on my path, I can simply execute OC login. And there we go. If I scroll, basically the OC has provided me with some feedback, and I have logged in to the sandbox environment because I'm using the sandbox environment, and as I'm using a certain user, and this user has two projects available to the user. One project is my user-dev. The other project is my user-stage. So that is excellent. We have our command line utility ready, installed, authenticated. So let's take a look at what we need to do next. So at this point, what we want to do is we want to create a new branch, right? And this new branch is called update-app. So let's create our new branch. And this branch is for our hello Node.js. So what we want to do is change to our do101x, right? So let's create our branch. So from main, create new branch, update-app. And there we go. We are on our update-app branch, and we can push the branch. And there we go. This branch is now in our remote repository, right? This branch, because we have pushed it, it is now on our in our fork in GitHub. So that's excellent. Now, what we want to do is we want to deploy a new application, right? The application is going to be named version, right? That's just a name of the application that we are going to be using. We are going to be using our fork. So we are going to be using our forked GitHub repository. We are going to be using the do101x-app, right? Or do101x-apps. Then there is the pound symbol, right? Then there is the update-app. So this is the branch that we have just created. This is how you signal the branch name to in the command line. And then we specify the context directory, right? So the context directory is a version, which is the name of the directory which we want to build. And finally, we are invoking OC, and we are building a new application. So this is a lot of information. Maybe if you've never used a command line interface, this might seem like a lot, but it's actually quite simple, right? So let's break it down. So let's start with the very simple thing that we know, right? We are starting with OC. When we are using OC, we want to, what do we want to do with OC, right? We want to create new application. So at this point, we should know that the command to build a new application is the new app, right? So we have our OC new app. Then what do we want to do? We want to name it, right? So how do we name our application? Well, there is a helpful flag or option rather, -- name, right? So we can use -- name, and the name for our application is going to be version. Then we will set the GitHub URL. So let's check our GitHub URL. The GitHub URL should be the HTTPS GitHub URL, right? So this is the URL to your fork. So that's all well and good. Let's delete the .git, which is not necessary. And then we have to specify the branch name. So this is the pound or hash, and then update-app, right? So we have our OC, we are creating new app, the name is version, we have our URL, and finally, we want to build the application in the context directory called version. So let's use the option context there. And the context directory is version. So what will it do? It will build this application, right? There is some app.js and there is some package.json. So this is a Node.js application. And it seems like a very simple application, basically that simply has a one endpoint which returns some text. So we have our OC new app command. Let's execute it. And so this OC utility has returned a lot of text. And especially in the beginning, a lot of users tend to skip a lot of text, especially when there is a lot of text at once, right? But this is actually very important. And I would definitely advise that when you see a lot of text, the first thing that you might find helpful is to see what it actually says rather than going away from it, right? So though the impulse might be of some people to turn away from it, it might be useful to see what it actually says, right? So we see that we found some image in an image stream, right? So, and the image is called OpenShift Node.js. So this seems really good, right? Because we know that our application is based on Node.js. So it seems like our OpenShift S2I image or S2I build image, right, found the Node.js builder image for our application. And we see that we have our Node.js match. We see that we have our source control URL, right? We see that the resulting image will be pushed to an image stream with the tag version latest, right? And we can also use OC start build to trigger a new build. So that's great. And we are creating some resources, which is the image stream, build config, deployment, and service, right? Note that there is no route. And so this application will not be accessible from the internet. This has been a lot of text from one simple command. It seems like we have done a lot by one simple command. So let's take a look in our web console. And in the web console, I see the version application, right? And so in the version application, I see that there is actually a build running. All right, so after a while, the build has finished successfully and we have our pod that is running successfully. So what do we do now? Well, the problem was that we have no route, right? And so we cannot test our application. So previously, when we created the application via the web interface, right, we could select whether we want to expose the application or not. And there are several ways how we could expose the application. One of the way, even at this point, right, would be to go to the administrator perspective, select the networking, routes, and we could create a route here, right? So that's one way. Let me switch back to the developer perspective. A much easier way that doesn't require the knowledge of YAML files or any of underlying details of the application is to move back to the command line interface and use OC again, right? So we know that basically the OC new app application or command rather created a deployment. So how do we know that? We know that from the text that we have read. So So I have the deployment. On top of that, we also know that the OC new app application created a service, right? And you can verify this actually in the web console as well. And so the service connects to the deployment. However, there is no route, right? There is no route. So what we can do is we can use a different command that comes with OC, which is expose. And this is the same command that comes with kubectl. However, in OC, we can expose services. And when we expose services, this creates routes, right? So I can OC expose service, and the service name is version. And this will create a new route, right? So I can clear all of this. And now if I go back to my topology view, I see that I have my my open URL button, which just appeared, and I have my route, right? So if I select my route, I see that this is the version 1 of the application. So this is all well and good. Let's take a look at our text. And one thing that I did want to stop at is that this OC new app command is quite long, right? And so I mentioned in the beginning that when we have very long commands, we break the commands with the / character, right? And this / character is used on Unix systems. On the Windows system, use the backtick character. Alternatively, just like I did, do not break the long commands. Depends on your preference. So I just wanted to point it out. If you have Windows, if you use Windows, this character will not work on your Windows PowerShell. So we have tested our application. It seems to be working, right? We have exposed our service. The service is named version, and that's why the OC expose worked, right? So we are using OC binary. With the OC binary, we are using the expose command. What are we exposing? We are exposing a service. And what is the name of the service that we are exposing? The name of the service that we are exposing is version, right? So that's why it's called, or that's why the whole command is OC expose service version, or OC expose service / version. The two are equivalent. Then we can open the URL and we see version 1 of the application. So then we can simply change the text, right? So we can change it from version 1 to version 2. So I have changed it. After this, we have to push this change into our remote repository. And so remember that what we are doing is we are pushing this to the update app branch, right? So let's switch to our source control view. We have one change. The change is in the version directory because that's what we are building, right? And so there is one change. So there is a modified file called app.js. So let's stage the change, right? And do we have any commit message update app to version 2? So let's use that. And we can commit this message, or we can commit this commit. We can commit these stage changes, right? And we can push the new commit, right? So at this point, we have modified the application. However, the application in our OpenShift cluster still uses the version 1. In fact, when I take a look at the topology, there is still only one pod running, and there is only still one build, right? There is no other build in the topology view that I can see. So what we can do is we can simply trigger a new build. So we can trigger a build in multiple ways. One way is to simply start a new build from here. Another way is to click the builds here, right? So we are in the developer view, we click builds, then we have our version build, and we can start a build, right? The two are equivalent, so we can start a new build, and this brings us to our version 2 build. So we can return to our topology view and click our version application. And we see that there is a build number 2 that has just started. So let's wait until build number 2 has completed. All right, so build number 2 was completed. So we have our new pod, which is running. So let's take a look at our previous route. And we see that this is version 2 is now showing. So we have successfully updated our application. So this is really good, right? We are capable of deploying our application to OpenShift from GitHub, from our source code, by using the command line interface, which is incredibly powerful, and we are capable of manually updating it. Now, what we can do is set up a GitHub trigger, right? So what we can do is set up the webhook trigger for GitHub. So let's navigate to our do101x-apps repository. And in the repository, let's click Settings, Webhooks, and let's add a new webhook. And at this point, what we are configuring is basically which URL will GitHub call every time there is some event, right? So what we are configuring is which event shall GitHub react to and what URL will GitHub invoke. So what we need to do is we need to get a URL of the OpenShift cluster that we want to invoke. And so this is not only URL of the OpenShift cluster, this is the URL of the specific build configuration that we want to rebuild, right? So it makes sense to return to the web console and take a look at the builds menu, right? And we select our version build config. And over here, when I scroll down, I see that we have two webhooks at the bottom of the screen. And let me make it a bit bigger. We have a specifically GitHub webhook and a generic webhook, right? And so these webhook URL are obfuscated. So the secret here is obfuscated. But what I can do is I can copy the URL with secret, right? So I've done that. Let me return to the GitHub interface. And so at this point, what I can do is I can set the content type, and the content type should be the application JSON, and the payload URL is the URL that we have just copied. So that's great. And I can add the webhook. After I add it, let's refresh the page. And it seems that the webhook trigger, the initial trigger, has been successful. So it seems like the webhook has been configured successfully. And after every push, GitHub is going to invoke the URL, and the URL will lead to the version build configuration, which means that it will trigger a build for the version application. So let's test that, right? So let's change the version 2 to version 3, right? So this is our app.js in the version directory. This means we have some changes, so let's stage them. Let's create a new commit. So let's update the application to version 3, and we created a new commit, and we push the new commit. So we pushed the new commit, and let's take a look at our builds. And suddenly I see version -3. Now I did not trigger this build manually, but GitHub triggered this build for me. Right? And so when I take a look at the webhook that I have just created, I see 2 recent deliveries. One of them was the initial delivery that GitHub tested whether the webhook is correct. And another of these deliveries has been my push to the repository, right? And so let's take a look at the topology, and I see that my build 3 has been completed. So let's take a look at my URL, and there we go. We have rebuilt our application, and now any changes that I make to the application will automatically trigger a rebuild of the application and automatically propagate to the OpenShift cluster, and I can test them in the OpenShift cluster. So this is an incredibly powerful technique, right? It comes with pros and cons, depending on your workflow. In some situations, for example, in a production environment, unless you have a really robust testing suite, you probably don't want to automatically rebuild your applications, right, in production environment. However, in some staging or development environment, you might want to actually, with every change and push that you make, you might want to see the changes in production or in production-like environment as soon as possible, right? So imagine that you have development environment and you want to get feedback as soon as possible so that you are confident that your changes work before you can deploy them to production environment. So that is all for our guided exercise. Now let's clean up, right? So what do we do to clean up? Well, first of all, let's delete the webhook, right? In our webhooks, in our GitHub repository, I can simply delete the webhook that I have just created. And after that, this means that every change that I make to the repository will not trigger the build config. So this is one piece of our cleanup. And then basically what we want to do is we want to delete all of the objects that we have created by the OC new app command, right? And previously, what we have done is we have gone through the user interface or through the web console, and we have deleted these one by one. Well, now we don't have to do that because we have our command line interface. And this is exactly what I love about command line interface. So you notice that one thing that the OC new app command does is it tags all of the objects with a label. And the label is called app equals something, right? App equals name. And in our case, the app, the name of the application was version, right? So we can get all of the objects that we have created by using OC get all, right? So OC get all, And OC returns to me everything that that the OC new app has created, right? So we would have to manually delete the service, the deployment, the build config, a number of builds, right? The image stream and a route. What we can do now that we have the command line interface is instead of get, we can issue the delete command. So OC delete all. And there we go. Our project is clean and we are ready to take a look at our next lesson and next guided exercises. So I'll see you in the next lesson. So in this lecture, we are going to be talking about secrets and configuration maps. So if you took some of our previous courses, this is going to be quite familiar to you. And if not, then this is going to be a new material. But when we talk about application secrets and configuration maps, we talk about externalizing application configuration, right? And so why do we want to do that, and what type of configuration are we talking about? So imagine that you have your cloud native application, right? And you have your application. Now we have been working with GitHub. It's quite common for this application to be deployed in multiple environments, for example. So what we want to do ideally is we want to have the identical application, right? We want to have the identical code deployed in different environments and have it just work with, for example, different databases or different runtime configurations, right? And the reason for that, the reason why we want to do that is so that when we deploy in production, we know that the code that we have tested in a different environment works with a production-like database, right? We have quite high confidence in our code or in our update, and we can roll out quite frequently our updates. So this was, for example, a database, different configuration option might be some kind of username, password, for example, connecting to your AWS or a different cloud provider, or authenticating to your LDAP or something similar, right? So basically, what you want to do is you don't want to hard code these values into your application, and you definitely don't want to push these values into GitHub, right? What you want to do is you want to refer to them somehow and defer at runtime, and at runtime resolve these values and inject these values at runtime in certain way, right? And so in this manner, we separate the configuration from the application source code. Not only can we deploy the source code in multiple different environments, but we can also verify that the same source code works, right? The same application works in different environments, which is exactly what we want. And we can easily manage and rotate, for example, these configurations. So if the username and password, for example, changes, then we can easily rotate this runtime configuration without changing or sometimes even redeploying our application, right? So in OpenShift, just like in Kubernetes, we have the concept of secrets and configuration maps, right? So configuration maps or config maps, as the name suggests, serve our objects. Both of these are Kubernetes objects, and they serve to store application data. Now, the big difference between the two is that config maps or configuration maps store the data in plain text, whereas secrets store the data in base64 encoded text, right? So the text is base64 encoded, and this has the advantage of being able to store larger files, for example. And I believe the limit is 1 megabyte file, but you can store a whole file. For example, an SSH key file, right? Or CRT file. You can store that as a secret. And we can actually take a look at the YAML file, right? So as a config map, we see that we can store, this is a basic YAML file, right? We have our config map right here. This is our type, and let me make that a bit nicer. So we have our config map type, we have our API version. So if you are not sure what this is just a way to communicate with the API server, basically with the OpenShift or Kubernetes rather API server, of what type of Kubernetes object are we using. So this is just the object of v1/config map, and this object takes the property called data, right? This is the configuration, and within the data configuration, we can have a number of options. For example, we can have username, we can have password, etc., right? And so we have key value pairs. So in the data, there is the key username and value my user, right? So in the config map, in this particular config map, right, the name of this config map is myconf. So in the myconf config map, when I reach out to the myconf config map and I want the username, the value that I get is my user, right? In a similar manner, I can also get the secret, right? And so again, this is a very, you see that the YAML file, the representation, the textual representation of the object is very similar to the configuration map, right? So we have the kind that is secret, the API version is the same. Then we still have our data, right? Which takes actually the same username and password, right? Which we configured, and it could be anything else. It doesn't have to be username and password. And then we have our metadata as name and type, right? And this secret is called mySecret. And this mySecret has the key username. And when I call this username, I will get some value. Now, from this actual text, I cannot see what the value is, right? Because it's base64 encoded. This is one of the main differences between the config map and secret objects, right? Because in the config map, it's simply a text. In the secret, it is not a text, right? It is a base64 encoded format. So one thing that I wanted to point out is that when you see this text, you might think that this is cryptographically safe, right? And that is not the case, at least not by default, and definitely not in this textual form, right? So when we have this textual form, this is just base64 encoded. And what this means is that this is the base64 encoding is not for security purposes per se, right? So when you have a secret YAML file, right? Something like this type of file, is not secure to put in something like GitHub, right? This file, when you have your username and password, can be quite easily decoded, right? So, for example, when you have a password, right, and if you put it somewhere like on something like GitHub and it's easily accessible, I could just take this text, right, this string, and simply pipe it or input it into this base 64 program, right, or utility, call -- decode, and get the actual value, which is secret, right? So secrets can be turned a bit more secure. And what I mean by that is you can enable the etcd. So everything we configure in secrets and config maps is stored in etcd or etcd, right? This is the distributed database that is the backbone of OpenShift as well as Kubernetes. And we can encrypt secrets in etcd. And I believe it is not done by default in OpenShift, and we can configure secrets to be encrypted in etcd. But this YAML file by itself is not cryptographically safe. In fact, this YAML file, though it does not look it, right, is just as insecure as the config map, just the YAML file, right? So the YAML file itself might not be safe. However, if you turn on the encryption in the etcd or the etcd database within your OpenShift cluster, then the secrets are reasonably safe, which is why they are called secrets. And furthermore, you can also configure different secret provider, right? Some secret provider that manages secrets in different way, possibly more safe way, right? But for us, this is quite enough. Both of these concepts are quite enough. Basically, what we want to do is we mostly care at this point. We mostly care about separating the configuration from the application, right? So we have configured our config map. We have configured our secret. One thing I would mention is that config maps usually take something like a runtime configuration that is non-sensitive, right? As the name suggests. Whereas secret usually, again, takes something that is more sensitive, something like a certificate, right? Something like username, password, something like a database connection value or something similar, right? When we have these two objects, what do we do with them, right? We have our objects, we have defined our secrets, our config maps. How do we use them? This is our last step in separating our source code from our configuration, right? First of all, we have to create them, right? We have some keys and values, right? Then we create these config maps and secrets. And again, we can take a look at the YAML files. We can either create these files, these text files, right? These textual representations, or we can create these in the web console, as we will do in this course. And then when we have created these files, we can inject, right, the files into our application, into our pods of our application, right? And we can inject it, for example, as environment variables, right? So what is an environment variable? It is variable that is available at runtime, right? So we have our application pod, and then, for example, if we have a JavaScript, then we can retrieve our environment variable with the process.env.key1, right? And so, for example, if we have a config map which has the key 1 set to value 1, right? So we set it over here. Then the variable key1 will result in the value value1, right? And so we can actually use it at runtime. So our program, our source code does not know what these keys will refer to, but at runtime they will resolve, provided that we inject the proper config maps or secrets, right? And one application path can inject one or more config maps as well as secrets. In addition, we don't have to inject these config maps and secrets as environment variables. We can also inject them as files, right? And so, for example, as I said, we can have a secret which has a full certificate file, right? And this can be something.crt, something.key, right? This can be public key, private key, some kind of a certificate file. In that case, we definitely don't want to expose the certificate as a environment variable, or we might, but it's more likely that we want to mount it as a file, as a read-only file, and that's exactly what we can do. We can also mount configuration files. So, for example, the core DNS, which is the DNS service within Kubernetes, mounts its configuration as a file from its config map. All right, so this was our intro to config maps and secrets, and let's take a look at how we can actually use them to separate our configuration from our application. All right, so in this guided exercise, what we are going to do is we are actually going to use application secrets to separate our application from an API key that we are going to generate, right? So in this guided exercise, we will be creating some configuration maps and secrets, and we are going to be using the OpenShift Web Console. So this is going to be we are going to leverage the OpenShift Web Console to pre-generate the YAML textual representation of the config maps and secrets, right? We will then update the deployment configuration, right? So basically we will update the configuration map and see what we have to do to propagate the changes. And we are going to deploy the application or a application that uses the config maps and secrets, right? So what do we have to do first? Well, what we are going to be using in this guided exercise is the Open Weather Map API. So this application that we are going to be using in this guided exercise uses the Open Weather Map API, and it basically fetches some data about the weather in a particular location. And so in this application, you input a city, and then the application goes to Open Weather Map and retrieves the data and displays the data for you. So to do that, we have to generate our API key. So what we have to do is we have to create our openweathermap.org account. So I have already done that, and I can click the services, and basically all we need is the free plan, right? So basically this is just a demo application where we get a 60 free calls per minute. So this is all we need for our application, right? And so once we have our free account, then we can generate our API key. So I have already generated my API key. So you can simply input a API key name and click generate. It might take a while for the API key to become active, right? And so what you want to do, just to make sure that the key works, is we can actually explore the API documentation. And whenever you're working with new API, this is exactly what you want to do, right? You want to see their API documentation, and you want to see what you can and cannot do with the API. So in their API documentation, we can see the current weather data, and I can select the API doc. And in fact, the Open Weather Map API is very elegant and simple. So it enables us to do what we want to do in a very, very simple manner, right? So all we need is we need to query this URL with a particular city, right? City name and API key. So I can simply copy this API call and just paste it into my browser. And as a city name, I can change that to Brno. That's the name where I reside in the Central Europe. And as the API key, I can select my key. And there we go. I got some JSON back. And in fact, I got a JSON with the response, right? So this means that the call was successful indeed, and that the API key works as expected. So now that we have our API key, we can take a look at our application that we are going to be deploying. All right, so now that we have our API key and we know that it works, we can take a look at our weather application. So our weather application is going to be in the weather directory, and we can take a look at the package.json file. And right away, we see that this application is a little bit more difficult than, or a little bit more complex than we are used to, but it's still a very simple application in general. So this application is still a Node.js application, right? We have our package.json file, which tells you it is a JavaScript application, of course, most likely a Node.js in the context of our course. In the script part of the package.json, we have our start script, and we are using our Node binary. In the dependencies, we have a number of dependencies. Most notably, we have our Express, right? Express.js dependency, which we use to declare endpoints. And we have our Pug, which we use for front end. So this is a templating, very simple templating front end dependency that we use to render and template at the front end that the user will see. So the entry point to our application, well, we can take a look at the bin www, and with a tiny bit of reading, we see that the first line that we require is the app.js, right? And then the remainder is just initializing the ports and the application itself. And so let's take a look at the app.js file. And in the app.js file, we see a number of things, right? We are creating our Express application. And most notably, we are setting up our endpoint, right? Our main endpoint. This is the entry point to our application, and we are setting it to be the index router. And our index router is initialized to be routes index.js, right? So we can open that one up as well. So we have our routes index.js. And this is the most interesting and important file for us. So this is the file that we will be working on with the most, or that is most interesting with the context of our guided exercise. And right away, we see two important routes, right? We have router.get, and this is the slash route. So this is the index page that you will query when you want to get to your application. And basically we simply render the index page. And this is basically rendering the index view. So this will be the index.pug or index.pug. And this is the template that we are going to render. So this template is going to have some form, right? And this form is a post form. And this form is going to have a label, which is going to query for a city, right? And so this form is a post form, as most forms are. And this form invokes the get weather endpoint, right? So likely we have an endpoint that is of post type at the /get weather, right? Get underscore weather. And that's exactly what we see here, right? We have a route that's /get weather, get underscore weather, and it is of post type. And in this route, we query the API, right? The Open Weather Map API. And that's exactly what we did, or almost exactly what we did in the browser, right? We basically take a look at the city that we took from the application, from the front end, right? And we put it into the URL of the API, right? Of the API that we are going to be querying. Very important to us though are the units and the Open Weather Map underscore API key, right? So these two variables are variables that that we will get from the environment variables, right? So if you recall from our lecture, and this is exactly how we get the environment variables that we want to inject at runtime into our pod, right? So we have units, and the application expects the environment variable called units, right? So the key is units, and the value should be set to something. And if there is no value, then the default value is going to be metric, right? So this is the typical OR. So if the first part of this expression is empty, then we default to metric, right? In the same way, we have our Open Weather Map API key, right? And we are querying the environment variables. And if this is this environment variable is not set in runtime, this value is set to invalid key, right? So this is our very, very simple application. We have spent some time in trying to understand how it works. I would definitely encourage you to take a look and see how the application works on your own, and feel free to modify the front end and back end or the actual routing, and see whether you can add some more functionality. But for now, let's take a look at whether we can actually deploy it to our OpenShift cluster, right? So we have taken a look at our application, and at this point, we are ready to create our branch. So as usual, we always create a new branch for every guided exercise. So that's perfectly fine. And our branch is going to be called weather, right? And remember, this branch, as always, is created from the main branch. So my branch is set to update app. And so I will switch to main. And from main, I can create a new branch called weather. So finally, I am on the weather branch. I can push the weather branch, and I want to push it. That's perfectly fine. And there we go. I have created the weather branch in my upstream repository. So for now, I can close all of these. All right, so at this point, we can actually create a secret that will store our API key, right? And so we can do that in the OpenShift Web Console. So in the OpenShift Web Console, in the developer perspective, I can click the secrets part of the navigation, click create, and key value secret as the name. This is going to be the open weather map dash API dash secret. A key is going to be open weather map underscore API underscore key. And the value is going to be the actual key that I created. So this is my generated secret. And I can take a look at the YAML file. So that's perfectly fine. We see that the data here is base 64 encoded. So it's not in the plain text format. In a very similar fashion, I can create the configuration map, right? So I can click the config maps, click create config map, and I'm presented with the YAML editor, right? And so here, this is it's very important that the white space here matters, right? So the number of spaces here matters. And so what I'm going to do is I'm going to delete all of the data here, and the namespace I can keep. The name is going to be weather config, right? Namespace is correct, and the key is going to be units, and the value is going to be metric. So again, very important to note that the number of spaces on the left after the data matters. Okay, so you can't have less than 2 spaces after data. Okay, and so after that's done, we have our config map or configuration map with the name weather config, with the key units, all caps, and the value metric. So we can do that. We can also view the YAML, and here we see that the YAML is in plain text because it is a configuration map. So our configuration should be ready for application. These are the only 2 configuration properties that we need to deploy our application. So we deploy our weather application, and this should be quite easy for us. So let's add it. And let's select our JavaScript, and we want a builder image, create application. The GitHub repository URL is my fork. It should be your fork as well. In the advanced Git options, we need to put our branch name. Context directory should be /weather, right? The application name should also be weather. The name should be weather. The rest is totally fine. And at this point, what we want to do is we want to configure the application to inject the secret as well as the configuration map that we had created, right? So we can click the deployment down here, and we could hard code the environment variables, but that means that we can't change the values later. So we can add them from our configuration map. And so, for example, I can do the units, right? And I can do the units. That is going to be the name of the environment variables. And that's because we expect the units, right? So this is very important. And it should be a config map weather config with the key units, right? And then we have the open weather map API key. And this is the open weather map API secret and our API key. And so there we go. We want to create a route, that's fine. And we have two environment variables, right? The units environment variable that we take from the configuration map weather config and from the key units, and then open weather map API key that we take from the open weather map API secret and from the open weather map API key, which is the key to the value that we want. So that all seems fine. Let's deploy this application. Okay, so our build has finished. So we have one build that is successful. We have a pod that is running. We have a service and a route that leads to the service, which routes requests through to the deployment to the pods. So let's take a look at our application. And it seems that we can reach our application. And let's see whether we can actually get some cities. And indeed, we can see we can send some requests. So this means that our application successfully got the open weather map API key, right? So we have successfully injected the API key by using the secret, and we were able to use that open weather map API key to query the servers and display the results, right? And furthermore, we are using the Celsius, right? The Celsius degrees, which are the metric units. We can also take a look at the pod, right? And the pod has a logs, which shows basically the response from the API server, right? So this is useful for debugging, and debugging is going to be a later chapter in this course. Let's take a look at how we can actually change the configuration property, right? So we used the metric unit, right? Which is the degrees Celsius. Let's try to change it to degrees Fahrenheit, which is the imperial unit. So we have our configuration map, which is the weather config. And this map has one key called units. And this key contains one value called, which is metrics, right? Or metric rather. So let's edit this config map. And instead of units metric, I'll change it to imperial. There we go, right? So when I reload, the units is imperial. Now, when you try to reload the application, and I will need to do this, you will notice that the application still uses the metric units, right? So the reason for that is that the pod that uses the configuration map, in our case, it is this particular pod, right? Uses the environment variable, or the environment variable is set at the time of spawning of the pod, right? So the environment variable is static when the pod spawns. The environment variable is set at that time, and it doesn't change later. So that's why you can do a number of things to remedy that, right? For example, you could scale the pods to 2 and then to 1, or something like scaling to 0 and then scaling to 1, right? So what this does is basically we destroy the old container, create a new container. The new container is going to have a new value injected at the time of creation. At the time of creation, the config map value is imperial and not metric. So at this time, if I check, let's do New York, we are using Fahrenheit, right? Instead of the metric system, we are using the imperial system. All right, so this concludes our guided exercise. Now let's clean up our environment. And because we have installed the OC command line utility, luckily this is much easier than before. And so I can open up a terminal application, and a simple OC who am I will verify that I'm still logged in. And because I am, I can delete everything with the selector app equals weather. So recall that when we use the OC new app, or when we add a new application, the new app will add this label. So app equals something, right? The name of the application. And so we can do that. And after this is done, remember that we created two new objects, right? We created our config map and our secret, and furthermore, the S2I application created 2 further secrets. So let's delete all of those, right? So we have our config map. Our config map is deleted. And then we need to delete 3 secrets. And after that, our cleanup is complete. So that is all for our guided exercise, and I'll see you in the next video. So in the previous videos, we learned how to externalize the configuration from our application, right? And this is very, very powerful, especially when we want to connect a database or our application to a database, right? So when we have our application, especially when we have multiple stages, for example, we have our production stage, we have our development, we have our staging environment, right? We very commonly have multiple databases, and we definitely don't want to change our application just to be able to connect to different databases, right? That seems like a scenario that potentially leads to many errors, that is prone to mistakes that could be quite easily avoided, right? And so this externalization of configuration is quite useful when we are talking about connecting our application to a database, right? So in production environment, for example, the database is quite commonly external to our OpenShift environment, but it is very useful in these other environments like development and staging environment to have a database deployed within, for example, our OpenShift cluster. And that's exactly why Red Hat OpenShift comes with a number of databases such as MySQL, PostgreSQL, MongoDB, or others that you can just easily deploy onto the clusters from the developer catalog, right? And so what I want to do is I want to pause here just a little bit and think about what do we need to have in order to connect to a database, right? So let's imagine that you go into the developer catalog, you in the web console, you click add, you find something like a MySQL, and you click deploy, and you have a new running pod, right? And this pod is a database pod with MySQL. And now, what do I need as a developer in order to connect my application to that pod, right? What are all of the configuration elements that I require in order to connect my application to the database, be it MySQL or Postgres or whatever else, right? So I want to scroll down a little, and quite typically, right? Not always, but usually, there is some authentication involved in connecting to a database, right? So we have some kind of a username and some kind of a password that we generally need in order to connect to a database. This username and password connects to a database within the database service, right? So there is a database, which is essentially a collection of tables, if we have a relational database, that is. And so our user is authenticated or authorized rather to, for example, make read and writes within a certain database, right? And this database is available on certain host or service, right? So this could be a Kubernetes service or OpenShift service, and this service also has a port, right? So these are a few elements that I need, and if I have these elements, my application can connect to a database. So how do I input it in my application? Well, this is what is called a database connection string, right? So it is a string, and the string has some special formatting. So we have in its general form, right? We have the connection string starts with a protocol. So this particular connection string probably or most likely connects to a Postgres database. After the protocol, we have some separator, and this is just some kind of a separator, so that's fine. We have our username, then we have another separator and password, right? We have our different separator. Then we provide the database service on which we can reach the service, and our port, right? And these two have our separator, same as the username and password. And finally, we provide the database name that is separated again from the port, right? So this is a connection string. It has quite a few separators, but that's just an implementation detail. But it provides basically all of the configuration details that we wanted to provide to the application in one string, right? And so to take a look at a concrete example of the connection string, we can have, for example, the Postgres connection string, or connection string that connects to most likely a Postgres database. And we have our username password, right? My app is the username, my pass is the password. The database is reachable on the MyDB service, right? So this is likely a Kubernetes service or OpenShift service. The port of that service is 5432, and the database for which the user is authorized is MyDB, right? In the same way, however, for example, if we go into production environment and this database is external to the OpenShift cluster, this doesn't have to be within the OpenShift cluster, right? It is just a database connection string. The application does not care where the database is located, and so instead of having a Kubernetes service here, we can have something like myhost.example.com, which can actually reach somewhere over the internet, or local internet, or wherever your database is located. And so we can take this this connection string or a individual parameters, and we can put it into something like a secret, or parts of it we can put into a configuration map and parts of it into a secret. And just like previously, we can inject it into our application pod and use it from our application. So before we go into our OpenShift cluster and try it out, the last thing that I wanted to talk about is returning to our developer catalog and our databases that are ready to go with OpenShift, such as MySQL, PostgreSQL, MongoDB, etc., right? So we have just talked quite a bit about what you need to have in order to connect to a database. And so when you go into the developer catalog and you spawn these databases, they ask you for a number of these details, but you don't have to fill them out, right? You don't have to fill out the username, and you don't have to fill out the password for a user or for the administrator user, and that might be quite surprising. You might be surprised as to, if you don't fill it out, how can you know the user that is authorized to do administrative tasks, for example, within the database? And the answer to the question is that there is actually a secret that is created with your database that contains all of the configuration details that you can mount into the application that will use the database, right? So in essence, the configuration details are just an implementation detail. They are auto-generated, and you as the user of the database don't care what the username and password, etc., is. You just know that there is some kind of a user and some kind of a password, and you inject it from a secret with a certain name, and you don't care about the actual value, right? So if you actually use these databases in your development experience, that's what you can do. Alternatively, you can create your own secret and delete the original secret. Okay, so let's take a look at how we can actually connect our application to a database in our OpenShift cluster. Okay, so let's take a look at how we can actually connect a database to our application in our OpenShift cluster. So in this guided exercise, we will be storing a database connection string in a secret. So that's fine. We are going to be spawning a Node.js application, and we are going to be spawning a PostgreSQL database, right, within our OpenShift cluster, and we are going to be populating the PostgreSQL database, right? Because by default, the PostgreSQL database is empty. So we will be seeding the PostgreSQL database with some data and communicating with that PostgreSQL database by using our application. Okay, so let's take a look at how we can do that. And the application is at our usual place. So let me open up my VS Code, and the application is in the contacts directory. So let's open up the contacts. And in the contacts directory, let's take a look at our package.json file. And so right away, we see this is another express.js application. And what I wanted to point out is this PG dependency. So this is our Postgres driver. This dependency enables us to communicate and connect to the PostgreSQL database, right? So we have our dependency list, right? We have our start script, etc., etc. So we can take a look at our app.js. And in the app.js, we see, as usual, we are initializing our Express on line 9. We are initializing our Express.js application, right? And for that, we need a router. And we have our index router on line 7, right? And we use this router on line 21. So on line 21, on the slash endpoint, we use our index router. So the index router uses the routes index, right? So let's open that up. We have our routes index.js file. And this file is a little bit busy, but don't let that discourage you. And right away, what I wanted to take a look at, and let me open this up, that's fine, is this pgcon variable, right? Because in this file, in this index.js router, we are going to use this pgcon, this PostgreSQL connector quite a lot. And so this file or this variable is initialized in the db-config file, right? So let's take a look at that. So this is the db-config.js file. And this is exactly what I wanted to see, which is we are using this PG driver, right? This is the Postgres driver that we pulled down in our package.json file. And this is exactly where we use our environment variable, right? This is exactly where our application expects the environment variable to be injected, and it has to be named db_config, all capital, right? And so again, this is a kind of a neat trick for development purposes. So when we were developing this application, if this environment variable is not provided, the db-config defaults to this value. So this is useful for when you are developing it. You can spawn this database, for example, as a local container, or you could actually spin up the database in OpenShift cluster and route port forward the traffic from your local environment to the OpenShift cluster, right? So this is exactly what I wanted to see. We have the db-config, db_config environment variable that we are using, and then we are spawning our pgcon connection to our database by using the connection string parameter, right? And we have our SSL false configuration parameter, and we are exporting this pgcon variable. So this is our configuration, connection configuration for the database, right? Once we connect to our database, we can actually use it in our index.js, right? So this is our router. This is our index. This is our Express.js router, right? And so when we hit the main endpoint, the slash endpoint, we try to execute some SQL queries by using the pgcon variable, right? We try to query our database, and then If there are some if there are some errors with the database connection, then we display these errors. If the database is empty, right, then we render on page 16, on line 16, we render the index, and this is again, we use the PAC just like in our previous guided exercise. We use the PAC templating engine. We render the index template, right, and the result is empty. And we also have the seed function, right, the /seed function, and basically if we execute this function, we query the database with this long SQL query where we drop the table if it exists, we create a new table, and we insert a few values into the table such that we have some values to display on the index page, right? So this is a very, very basic application, and you can browse this application. We have also provided this SQL directory just for you so that you can take a look at what this SQL looks like, and you can play around with the SQL. You can browse the PAC views and modify this application and rebuild and update this application in your OpenShift cluster after we have deployed the application and after you've seen it working. All right. So at this point, I believe we can create our branch, right? Because every guided exercise that builds and deploys an application has its own branch, right? So what is the name of our branch? The name of our branch is contacts, right? So I will switch to main and create the contacts branch. And in the SCM view, I can push this branch into my remote repository. So now that it's done, we can actually switch to the OpenShift Web Console. And in the OpenShift Web Console, we will first deploy the PostgreSQL database, right? So as we've said in the previous video, we can deploy a number of databases from the developer catalog. So let's click Add. This is the developer catalog. We have our databases, and we are looking for Postgres. And we have our PostgreSQL, and there are two databases. One is ephemeral, the other one is not. So for our purposes, the ephemeral is quite enough. And by ephemeral, what we mean is it is not backed by persistent storage. And later on in this course, we are going to talk about persistent storage. So for now, if you don't understand what ephemeral means, that's quite all right. Later, we will touch on ephemeral services and non-ephemeral services. So we can click instantiate. I am in my dev namespace. Memory limit is quite all right. Namespace is also quite all right. The database name is going to be different, right? And so what we want to do is name the service contactsDB, and we want to set the connection username to contacts, connection password to contacts, and database name to contactsDB. And the rest we leave the same. Notice that I don't have to provide the connection username and connection password, because if I don't provide it, it will be auto-generated as we said in our previous video. Okay, so that looks pretty good. We can create our database. And while our database is spawning, let's create our secret that will hold our configuration details, our database connection string that our application will use later on. So let me create secrets and create. I want a key value secret. And so the secret name is going to be contactsDB-secret. Our key is db_config, and our value is consists of our connection string. So that is our protocol, right? PostgreSQL with our separator, username, separator password, and then our service, ContextDB, our port 5432, so that's the default port, and our database name. So that's the ContextDB, which we just set. So that looks pretty good. We can click create, and I have my secret. And at this point, it seems like I can create my application. So let me just verify that my database is up and running. And it seems that my database pod is up and running, and it actually serves at the port 5432. And the service is ContextDB, just like I set it in the secret. So that all looks good. And so we can deploy the contacts application. Right. So let's click add. We have our all services. We can select Node.js builder image, create our application. Just like before, we select our fork. With advanced parameters, because we used our contacts branch, right? And our contacts directory. We can have our application name set to contacts, and as well as our name. And then we need to set the secret to inject into our application as the environment variable, right? So we click just like before, we click the deployment, add from config map or secret. We can delete the original one. Then the value was in the db config, right? And it has to be the db config. And then it was the ContextDB secret, and key was db_config, right? So that all looks good. And we can create our application. So our application seems to be running. Let's verify that the build was successful. The build seems to be complete. Our application seems to be running. Our service seems to be available on our port 8080. So let's verify our route. And we see that there are no contacts to be found. And that seems quite good. Because otherwise, if we misconfigured our connection string in our secret, then we could see an error right here, right? And so if we click seed data, we should see some database, some values here, and that's exactly what we see here, right? And so the last thing I can do is I can verify that the database actually has some values. So I can verify that the SQL that we performed from our application actually propagated in the database, right? So I can click the database pod and open a terminal in the database pod, right? And the terminal, the database pod contains a command line utility called PSQL, which enables us to connect to the database. And so this is a utility that enables us to query the database from the local environment of that application. And so in this terminal application, or in this terminal window, I can use the PSQL command line utility, which enables me to connect to the database. So I am using the contacts user, and I'm connecting to the contacts.db database. And I can display all of the tables. And we see one table, which is the contacts table. And I can query the table and see all of the data in the table. And we see that there are 5 rows, and these rows actually correspond to the seed function that our router executes on line 39 in the index file, right? And so this proves essentially that our application was able to connect to our database and execute both read as well as write on the database within our OpenShift environment within the cloud, right? And so we can go back to our topology. And this is essentially all that we wanted to do within our guided exercise. And so at this point, all we have to do is clean up. So again, because we now have the OC command line utility, it's much easier to clean up by using OC rather than manually clean everything up. And so what I can do is, let's open this one up and open a new terminal. Let's see whether I'm still logged in, and I am. And we can clean these. And first of all, we want to delete everything with the label app equals contacts, right? So this is our application. This is our S2I application that we are deleting. And then we want to delete everything as well as a secret, right? With the selector template equals to PostgreSQL ephemeral template, right? So this is our PostgreSQL database that we are deleting. And finally, we want to delete all of the secrets that were created by our application, as well as our contacts.db secret that we created to inject our configuration into our application. So that does it for our guided exercise, and I'll see you in the next video. All right, so welcome to our guided exercise. And in this guided exercise, we are going to take a look at how we can scale an application, how we can scale an application manually, and how we can deploy a horizontal port autoscaler to autoscale an application for us. So, as I said, we're going to take a look at the manual scalability, right? And this is going to be in the OpenShift web console. And then we are going to configure an automatic scalability by using the horizontal port autoscaler based on the CPU load, right? So let's take a look at our application in the Visual Studio Code. I can open up the PHP scale application, which is a simple PHP application. This could have been a Node.js application. It is a PHP application just to spice things up. And all it does is prints up the host name of the host that it's running on, In our case, it is going to be the name of the pod, of the OpenShift pod that it is running on. Right? So as usual, we need to create a branch, and the branch for this guided exercise is going to be scale, right? So we need the branch named scale. So as usual, I can create a branch from main. I can create the scale branch from main. There we go. When that is done, I can click source control, hide the hello world repository. Let's make this a bit wider and push the DO101 apps, right? And there we go. So the scale branch is in my repository. That's all well and good. Now I can use the branch to actually deploy my application, right? So let's switch to my OpenShift Web Console. I'm already logged in, and I can deploy my application. So switching back to the developer catalog, let's click all services, and this is a PHP application. So I can select the PHP builder image, right? We want a S2I application or S2I build process. So by this point, we know that we need a builder image. And as usual, we need our repository URL. And the Git reference is scale. So this is our branch, right? The context directory is php-scale. And let's verify. What else do we need? Application name, and that's about it. So let's do that. Application name is scale, name is scale, and we can keep a deployment as the main resource that will control our deployment pods, and we want to expose our route. We don't need to inject any environment variables into this deployment, so I can click create. And our build is complete. So let's take a look at our application. And there we go, right? So we have our application, and our application works because there's only one pod. The application output is always the same, right? So let's close this one, and let's spawn more pods. Let's scale the application to multiple pods, right? So I can click the application details and scale the application to let's say 3 pods, right? And so at this point, if I click at the resources tab, I see 3 scale pods. So that means that we should have 3 pods serving our application, right? So then the problem is that when I open up my application, I still see the same pod is serving my request, and the reason for that is that my web browser has cached a cookie, and therefore the route is by default behaving in such a way that it recognizes my web browser, right, my client, and it reroutes the requests. It attempts to reroute the requests to the pod that it rerouted previously, and so this is not consistent always, but it is consistent enough for our very simple application, right? So what we can do is we can actually modify the route. And the way we do it is by switching to our OpenShift Web Console, and in the Resources tab, we can scroll down into the Route section, and I can click the Scale route, right? And in the Scale route, I can select the YAML tab. And here, after everything has loaded up, what I want to do is I want to go to the annotations section right at the beginning of the YAML representation. And this is the textual representation of the route that OpenShift has created for us, right? And so I want to add 2 annotations, right? So we want to add the HA proxy router OpenShift IO /balance is round robin. So we want to serve the requests in a round robin fashion, and we want to disable cookies, right? So as usual, whenever we modify a YAML file, we have to make sure that the indentation is this it matters, right? Indentation is the same as the indentation above it. So right now I need basically 4 spaces, which is exactly what I have. And so I have the balance and disable cookies set. So let's save this resource, and there we go. So now if I reload, the annotation should stay. And if I go back to the topology, this should all stay the same. And if I reopen my application, I should be getting different results, right? Which is exactly what I'm getting. So my every request is routed to a different part, different application part, right? So this was a way to manually scale an application up, right? And I can scale it back down. So let's say that we do not need 3 parts anymore. So instead of 3 parts, we can have a 1 part again. And suddenly we have destroyed the 2 previous parts, but my application is still up and running, right? My application did not see any disruption in service. And so at this point, what we can do is we can actually configure the horizontal part autoscaler, right? And so as we said in the lecture, you could configure it from the web console, and we can do that by using the OC command line utility, because to be honest, it's simpler, right? Or it seems simpler. It's a one simple command that seems quite reasonable. So let's switch to our Visual Studio Code, and let's close this one because we do not need it. Let's open up a terminal, and we need it in the DO11 apps, right? And I am already logged in with my OC client. So I can verify that with OC who am I. And because I am already logged in, I can simply create it. So I'm using the OC command line utility, and I want to autoscale, right? I want to configure the autoscaler. So I'm using the autoscale command. Now, what am I autoscaling? I'm autoscaling the deployment, and the deployment is named scale. Am I correct? Yes. So we have a deployment, and the deployment is called scale, right? So the deployment is called scale. And then we have to configure a few parameters. So at minimum, we want to have 1 pod, right? At least 1 pod will always be available for our application. At most, we want to have, for example, 3 pods. And then we want to configure the CPU percent and, for example, to 80%, right? So we want to follow the collective CPU percentage of all of the pods to be 80%. If it exceeds 80%, we want to spawn a new pod. If it falls below 80%, we want to destroy a pod up until 1 pod, right? So let's configure our CPU percent. to 80. So that is our OC autoscale command. Let's execute it. And there we go. We have our horizontal pod autoscaler, right? So in the topology, we do not see any autoscaler. You can actually see that we have an autoscaler by clicking the application, and we see autoscaling pods, right? So that tells you that there is some kind of autoscaling going on. We can actually also switch to the administrator perspective, right? We can definitely search for it. Right? We can search for the horizontal pod autoscaler. And so this is the auto-generated YAML file that the OC command line utility generated for us. Right? So let's switch back to the developer perspective. And we have our scale deployment that is auto-scaled for us. And so now what we want to do is we want to simulate the traffic, right? We want to simulate a lot of traffic going on. And the way we do that is by using, let's clear this one up. And we can actually keep this one up. We simulate it by using the stress application, and the stress application is a simple container file which uses HTTPD base container image, and it uses the Apache benchmark utility. And basically, this Apache benchmark utility tries to send as many requests as possible to the scale service host at the scale service port, and these are environment variables that are auto-injected into this pod by OpenShift for us. So we don't have to worry about injecting these environment variables, because OpenShift does that for us for free, essentially. Right? So let's deploy this application from the developer catalog. So I can select deploy from or import from Git, right? And we are on the scale reference, right? This is the branch. We are in the stress directory, right? And there we go. We have a Docker file import strategy, which OpenShift knows how to build and deploy, right? So then we can change the application name. Application should be create application. Application is stress. And we do not want to create a route to this application. We do not need to expose this application because this is just an internal benchmarking application, right? So that's about it. At this point, we can simply create this application. Okay, so as we see, our stress application has been deployed. Our stress pod is running. And right away, I see that my scale application has been auto-scaling to 3 pods, right? So 1 is running and multiple are creating. And so we have our stress pod, and we can take a look at the logs. Usually we could do that in the OpenShift console. we can also get the logs from the command line, and we'll take a look at that in the future videos. But for now, I can simply get the logs by using OC logs, and we see that the benchmarking has started. So this means that the stress application has started the benchmarking, and the PHP application has actually responded to it, or rather the autoscaler has responded to it and has autoscaled the application. And so when I refreshed the window, we see that the 3 pods have come up and are running because of the autoscaler. And so now when I reduce the pod to 0, the stress pod, the benchmarking pod to 0, this means that I reduce the traffic, right? I simulate the drop off in the traffic. And after some time, the PHP application, scale application, will be auto-scaled to 0. Okay, so and after some time has passed, this can be quite a bit of time. The autoscaler will recognize that the traffic has reduced and will autoscale the pods back to 1. This was our guided exercise, and all we have to do at this point is to clean up our project. So let's delete everything with the app equals stress selector, right? So let's open up our terminal. And issue the delete all command. Then we have the delete all app equals scale selector, right? So that's quite simple. And we can delete the horizontal pod autoscaler, right? And we can delete the scale secrets and stress secrets, right? So we have OC. We need to delete the GitHub secret as well. And so that does it for our guided exercise, and I'll see you in the next video. So welcome to our next video, and in this video we are going to be talking about troubleshooting and fixing our applications that we try to deploy onto Red Hat OpenShift. So troubleshooting an application is definitely something that every developer spends a lot of time on, right? Every developer makes a lot of mistakes when they try to deploy their applications, whether be it typos, be it something not working as they would expect, and this is definitely something to be expected. And so we thought that we would just take a look at some of the techniques that might help you to hone in on where the issue is and what are some of the common issues that you can encounter while deploying your applications on Red Hat OpenShift, right? And so, for example, a very common way of deploying your application is by using the S2I process, right? In this course, we have used S2I almost exclusively, right? And so S2I, there's nothing wrong with S2I. S2I is a very simple way to take your source code and deploy it onto OpenShift. So if you are using S2I, and we are going to take a look at S2I into some depth in future, it it is useful to understand that there are actually two steps going on in S2I, right? And we have seen that in the course so far. So there is the build step, right? And there is the deployment step. So the build step takes your source code and it compiles it. It downloads all of the dependencies and packages, right? And pushes the resulting image, compiled image, into the internal Red Hat OpenShift Container Platform registry, right? And so this is something that we have the build config resource that does for us. So this is the build process or build step, right? And then we have the deployment step. And the deployment step takes the resource that the build step created, right? This is the already compiled application, and with all of the dependencies, it's packaged, right? And it tries to start the application pod, right? It tries to make the application running, right? And so this is quite useful to understand, because this means that there are two places where you can encounter an issue, right? So for example, did you make a typo in the package.json file? If you did, where would your S2I process fail, right? Well, it would fail in the build step, right? Because the build step would try to download all of the dependencies, package the JSON would not compile, like would not be readable by, for example, NPM, and therefore the build step would fail. On the other hand, what if you make a typo in the start script of the package.json file, right? So for example, your package.json file is correct, syntactically correct, but the start script does not start your application. Well, in that case, the build step completes, right? But the deployment step will fail, because the deployment step will actually try to issue npm start, right? And the npm start will not execute because you made a typo in the start script. So it is useful to understand which step did your application fail at, and try to debug and know where to hone in on which type of an error, right? And so, we can inspect these errors in both the web console as well as with the CLI, right? With the OC command line utility. And in the web console, for example, if the application, the S2I process fails in the first phase, in the build phase, we see that there is this type of an error, right? If the build process succeeds, we see that there is this kind of a check mark, right? Green check mark. So in the web console, this signifies a success or failure of the build itself. So this is the first step of the S2I process. And then there is the second step, right? The deployment step. So we take the artifact from the build process and try to deploy it. If the build process is successful, so notice that both of these have green check marks, right? So the first step was successful, and then we try to deploy the artifact. If the artifact can be deployed, then we have this blue ring around our application. If it cannot be deployed, then we have this red ring around our application, right? And note that if we scale down our application, and you could have seen that in our previous guided exercise, this ring, right, is just white. It's just empty, right, to signify that there are no pods. So this just tells you very basic information on where the issue occurred, in which step, right, of the S2I process, and then you can actually click the application, right? You can click over here, and we can hone in. For example, if we have a failed build, right, we can see that over here. Then we see that the build has failed, and we can view the logs, right? The logs are extremely important in any kind of debugging because they provide us with the error message, and the error message usually tells us, for example, could not parse package.json file, right? And so we know, okay, the package.json file, there's something wrong with it. I, as a developer, have to go and check the package.json file, for example, or vice versa. Could not download dependencies, right? So that tells you that there is something wrong, for example, with the internet connectivity, and that package.json might be fine, but there might be some transient issue with the internet connectivity, and that if I retry the build, it might succeed, right? Or, for example, that the dependency that I want to download is not in the registry that my OpenShift cluster is trying to call, right? So this is the build log, and then we have our successful build, right? This is the second case. So the build was successful, right? But our deployment phase is not a success, right? The deployment phase fails, and so then in the same manner we can click our application. The pod is in the error state, and we can take a look at the logs of the pod as well. Again, very important to see why the pod is in the error state. So, for example, we might be accessing something that we don't have permission to access, or we might be expecting something that is not there. For example, some kind of variable or something else, right? So what happens when our S2I process finishes as it should, but our application does not behave as it should, right? So our application builds and deploys, our pod runs, but the application has some bugs in it, right? Well, we can actually access the running pod. We have done that actually in the past. We can open a terminal window into that pod, and this helps us to debug some issues. So for example, we can see whether the application has everything that it needs, right? So this could be one cause for bugs. A different thing that you can do is actually you can connect a debugger, right? You can connect a remote debugger to your application. For example, Node.js and Java support remote debuggers, where you can actually debug your application that runs in the cloud while using your local IDE, right? And this is definitely outside of the scope of this course, but it's good to know that this exists, right? That this possibility exists in case when you can't deploy the application locally. Now, returning to the console, right, to the terminal application that you can open in the pod, this is also extremely useful, for example, for some debugging of network connectivity. For example, you might your OpenShift your OpenShift might experience some kind of network partition, right? One node of your OpenShift might not be accessible to a different node, or for example, in your organization, there might be some security constraint where one application is not reachable to the other application, etc., etc. So you might be able to verify that one application can reach a different application by using terminal window, and you might be able to see what the OpenShift environment looks like from the application perspective, right? So this is kind of this can lead to somewhat of advanced debugging, this terminal window. But again, it's very useful to know that it exists, right? And you do not need the OpenShift Web Console for the terminal window. You can actually use the OC command line utility to connect to your pod, and you can also actually copy files to and from your pods in the OpenShift cluster. This is also very useful to know, right? So you can use the OC command line utility, for example, to download a log file from your pod, and then you can explore it on your local environment, right? So we have our, we can access our running pod. So that's perfectly fine. We can debug our running application on OpenShift by attaching our remote debugger. Of course, when we identify an issue that needs fix to the source code, we have to redeploy the application, right? If you modify the source code, you have to rebuild the application. If you deploy the application to OpenShift by using S2I, in that case, you have to start a new build, for example, and then wait for the application to redeploy, and then you can test your fix. Remember that we said that we configured the webhooks, right? The webhooks in the past, and this can be quite helpful to configure for temporarily. In case you are doing some debugging, you might want to configure a webhook until you are satisfied with the fix, and then you take the webhook down, for example. OpenShift events are actually one of my favorite ways of seeing at a high level what's happening in the OpenShift cluster. So let me open up my web console, my OpenShift web console, and we can actually see that this is kind of a high level logging of what's happening within your OpenShift cluster, right? And so this is in the administrator perspective. You select the home and events, right? And so just like almost everything else, you can get the events by using the OC command line utility. And so, for example, when something is failing and you don't know why, the events might provide a hint as to what's going on. So, for example, when you have a failing application and everything looks perfectly fine within that pod, you might want to see the events, and you see that there is some kind of a catastrophic failure. For example, a machine has died, or a network connectivity has been lost, or something similar, right? So events kind of zoom out and give you a more high-level overview of what's going on. And especially when there are some high-level failures, events are really good at showing you what the failures are within your OpenShift cluster, right? So these are events, and definitely environment variables are extremely common way of making your application fail. And this is not me arguing for not using environment variables. Environment variables are extremely useful, and we have seen environment variables we have used environment variables in order to decouple the configuration from our application, right? But it's very easy to make a mistake within configuring the environment variables, right? So mistake number one is simply not including the environment variables. So our application might expect a certain environment variable, and we do not provide it. So in that case, the application might simply fail, and we have to see in the logs why it fails. Depending on the application, some application log these failures better than other, right? A very common issue with missing environment variables, or rather with environment variables, is that an application expects a certain environment variable while you configure it in a different way, right? So, for example, an application could expect something like env prod, right? Environment variable, whereas you configure it as env prod, right? And suddenly this does not work, right? Because these two variables are not the same, of course, right? And so, for example, this could lead this key could lead to some kind of env prod could lead to some address, or for example, a database value or something similar. And suddenly, we might not, our application does not know where the prod is, right? Extremely common typo. Usually it happens once or twice, and then you will be quite careful. These typos are quite easy to prevent if you have automation in deploying your applications. When you don't have automation in deploying your applications, you have to be careful in configuring the environment variables. So for example, when you have something like Helm, or when you have something like OpenShift templates, or even a operator that deploys your application, right? Then these you can test these quite easily, and you know that your application works. When you're deploying your application kind of pod by pod, these typos are bound to occur. Another quite common typo or issue is that you misconfigure the actual value, right? So for example, for your database, you set the password to be X, right? And for your, so this is the DB, right? And for your app, for your actual application, you also set the password environment variable, but you misconfigure it to be Y, right? So both of these applications expect, for example, an environment variable that is called password, like PW, and that is all correct. However, you set the database password environment variable to be X, and the application environment variable password to be Y, and therefore the application does not authenticate to the database, right? And so that's why, let me clean this up. That's why we recommend setting the value once in something like a secret or a configuration map, right? And simply sharing this value with the database pod as well as your application pod, right? So how do we troubleshoot it? Well, again, as we have seen above, logs, right? Taking a look at the logs, taking a look at the behavior of the application, and taking a look at the configuration of the application. Basically, those are our three main ways of how we can troubleshoot the parameters. So that's it for this lecture. And now let's take a look at how we can troubleshoot and deploy a failing application in Red Hat OpenShift. All right, so welcome to our next guided exercise. And in this guided exercise, we have prepared an application that has several issues within the application. And so the goal of this guided exercise is to take an application that might have several issues and deploy it to OpenShift and successfully reach the application, right? So we will use the S2I deployment process, right? We will identify build and deployment issues, if any, right? We might use some OpenShift logs to diagnose the issues, and we will fix the issues and redeploy the application as necessary, right? So let's take a look at our application. And the application that we are going to be using is in the context troubleshoot directory, right? And so this is the same application as our contacts application that we deployed previously. So remember that this application requires a Postgres database, right? And so let me just open up the proper application, right? This application requires the Postgres database, and in the database config, it requires some environment variables that requires the Postgres connection, and in the routes index, right? It uses the pgcon variable in order to issue some Postgres SQL to that database, right? So this was the context application. We want to deploy the context-troubleshoot, right? As we always do, what we want to do first is create a new branch. The branch name is going to be troubleshoot, right? So let's do that. I will create a new branch. So the branch name is going to be troubleshoot, and I'm going to create it from our main branch, right? So that's all well and good. I will switch to our source control and I will push the branch, right? We have no upstream branch, so that's perfectly fine. And actually, let's close this terminal for now because right now we do not need it. And so our branch should be up and available. And so at this point, let's deploy our database. So we need our PostgreSQL database with the contacts.db database name, right? So let's do that. And let's open up our OpenShift web console, right? Let's add our, in the developer perspective, let's open up our development catalog, right? In the -dev namespace, I'm going to add a database. And what we want is the Postgres ephemeral database, right? So let's instantiate that. And what we want is a database service name is PostgreSQL. So PostgreSQL, that's already set. And the database name is contacts.db. So that's all well and good. Let's switch to our developer perspective, and we see our application, right? Our application is running. We have a PostgreSQL pod. We have our PostgreSQL service, right? One thing that we are missing, or that you might think we are missing, is the PostgreSQL username and password that we can use to authenticate to this database. So let's take a look at our secrets, right? And we have our PostgreSQL secret. And within this secret, we have our database name and database password, database user, right? So you can actually reveal this value. The database name is as we set it. And then we have some database password and database user. All right. So then let's add a different, let's actually spawn our application. And so at this point, if you want to have an additional challenge, what you can try to do is try to spawn the application by yourself without trying to follow the steps, and try to make it work. And pause this video and come back if you have any issues. And if not, then let's try to do it together, right? And then you can try to do it on your own after you've seen the video, right? So we have all services. Now our application, we know that it's a Node.js based service. So let's search for Node.js, and we want a builder image. So let's create our application. And of course, we need our Git repository URL, right? So that's all well and good. We have our Git reference branch is troubleshoot, right? Our context directory is the directory that we want to build. So that's contacts-troubleshoot, right? And then let's take a look at what the name should be. And the application name should be contacts, and the name should be contacts, right? Contacts, name is contacts. We want to create a route, and let's try to deploy this application. So we see that there is a build going on, right? When I click my application and resources, build one is pending, right? And I can take a look at the logs from the build. And so there we go. We have our logs, right? Where we have a lot of interesting information. So we have downloaded the base image for the S2I, right? The Node.js base image, right? Then the S2I tried to the build config, the build step, tried to download all of the dependencies, right? And suddenly we see some npm errors, right? So we have installing all of the dependencies, and we see npm error, right? Something with package.json file, and we failed to parse the JSON, right? Unexpected token D in JSON at some position, right? So our build seems to have failed. Let's take a look at our topology. And indeed, we see that our build has failed. So let's take a look at our application, context troubleshoot, right? We see that, or we know that package.json, there is something wrong with package.json. And right away, when I open it in VS Code in my IDE, I see that something is wrong, and probably there is misformatted JSON, right? my dependencies are missing a quote sign, right? So this JSON is incorrect. So let's correct this JSON file. So these dependencies should now be correct. And what we have to do right now, so I have corrected my package.json file. What I have to do, of course, is commit this file, right? I had to stage this change. I have to commit this file. So correct the package.json file, right? Create a commit and push the commit, right? And only when I have pushed the commit and I have pushed it into the troubleshoot branch, because that's the branch that we are using for our S2I build, right? Only at that point, I can restart my build process, right? So at this point, we know how to rebuild our build, right? We have done that already. So let's restart our build. And in fact, the error is also visible right here. So let's restart our build. And let's see if that actually fixes the issue. Okay, and at this point, we see that our second build was correct, right? Second build finished successfully, right? But the pod that it spawned seems to be erroring out, right? There seems to be an error with our second pod. So let's take a look at the error of the pod. And sometimes the sandbox environment can take a while to load the logs of a pod. And so what you can do also is either wait for the logs to come in, right? Or you can take the name of the pod and you can use the OC command line utility, right, in the terminal, and you can issue the OC logs command with the pod name, right? And so we get the logs of the pod, and let's take a look. And it seems that there is the start script, right? Launching via npm and node bin www.js. And we cannot find the module bin www.js, right? So we cannot find some module. So the question is, where do we call this bin bin/www.js, right? And we still haven't, the console still haven't given us the logs, but we have gotten them through the command line. So that's quite all right. So let's take a look at our application. And the question is, where do we call our www.js module, right? So what we are trying to do is we are trying to launch the application, right? We are trying to start the application. So let's take a look at our package.json file. And in fact, right away, I see that there is a start script. And in the start script, I see the node bin www.js, right? So let's take a look at this script, this /bin/www.js, right? And let's open up bin. And I see there is www, but it doesn't have .js, right? So we could correct this this mistake in multiple ways. Either we could try and give this script a .js, right? But probably what we want to do is remove this .js extension. So let's do that, right? Again, we have modified the package.json file, but at this point, what we have to do is we have to create a commit and push that commit into our branch, right? And so let's let's stage the changes, right? Create a new commit. And push that commit. And at this point, what we have to do is we have to rebuild our application, right? Because our source code has changed and therefore our application has to rebuild. So let's go back to our topology view, start a new build. Okay, and so we are back. Our third build has finished successfully, right? Our pod is finally in the running state. And so at this point, we can go have coffee, right? We are done for today. Our application is up and running, right? Well, let's take a look. Let's actually open up the URL and see that our application is not working, right? So we see a database connection failure, right? And so the reason for that is that our application is actually not connected to the database, right? The application does not know the username and password for the Postgres database. And so the reason for that is that we did not set the environment variables, right? So let's take a look at how we can do that. So let's open up our context troubleshoot. And we know from our previous, let me close all of these terminals, right? We know from our previous experience with this application where to look, but let me just look from the beginning, right? App.js is our main entry point to the application. We see that this is an express.js application. Express.js takes a router, right? And so we see the main entry point to the application uses the index router, and the index router is defined on line 7, and the index router is in routes index, right? And so let's take a look. And routes index defines the DB config, right? And so let's take a look at the database configuration, because that's what we want most likely, because we are suffering from database configuration failure. And so let's take a look, and there we go, right? We want the database user, database password, and database name. So lines 6, 7, and 8 seems to be missing, right? And so note that when I open my my web console and I take a look at the secrets and I examine the PostgreSQL secret, that's exactly the data from the PostgreSQL secret, right? There is a database password, database user, and database name, right? So this is all prepared exactly for us, such that all we need to do is inject every variable from this secret into our application, right? So how do we do that? Well, let's take a look. Let's switch back to our topology view. We have our contacts application, right? And let's click at this contacts deployment at the top, right? So this is the manager of our application. This is the deployment that manages our application. So let's do that. We need to switch to the environment section, right? And there we go. We have our environment variables here, and we can add them from a config map or a secret. You can delete the initial one. And this is exactly what we can do in the source to config deployment stage, right? In the developer catalog. But here we can do it after the application has been created. But we don't want to create a single value, right? What we want to do is we want to add all of the values from an existing config map or a secret. So we want to select a secret, and the secret is PostgreSQL. And we don't want to put any prefix because the names match exactly to what we expect. And all we have to do is select PostgreSQL, click Save, and there we go, right? Let's reload to see whether our configuration has changed. Okay, and PostgreSQL is still here. So let's take a look at our topology view. And I see that a new container is creating. So that's excellent. That means that a new container is spawning with our environment values, right? With our environment variables. Let's refresh to see whether our pods, whether we have only one pod. And there we go. So we now have only one pod, and this pod should now only have should have the correct environment variables in addition to the previous environment variables, right? So let's take a look at our URL, and let's refresh. And there we go, right? So our application is finally seems to be working. One last thing that we can try to do is we can try to take a look at the pod, and let me try to open a terminal window. And actually, what I can do is I can use the command line utility, right? And this is a little bit beyond the scope of this course, but I think this is also helpful. This is the name of the pod that we are using, right? So let me copy and paste it. And what I can do is I can use the OC command line utility, and I can execute, right? Execute in that pod. I can execute in that pod a command called env, right? And so this command should print all of the environment variables within that pod. So if I execute that, that should be quite fine. And now I see all of the environment variables within that pod, right? And 3 of the environment variables are database name, database password, database user, right? And so these are the 3 environment variables that the application is using on lines 6, 7, and 8, right? And so these are the variables that were missing previously, and these are the variables that we are using on line 10, right? So this has been our troubleshooting session, right? And so I can do that also in the interactive terminal, right? env. It's the same. I can also do env and pipe it into grep just to find something like database, right? And then it will print only values which have database in it. So these are kind of slightly advanced Unix or Linux concepts that we can use to troubleshoot the actual environment, the runtime environment of the pod, right? So this has been our troubleshooting experience of our application. And I hope that it has been helpful to try to see how we could go about and troubleshoot missing environment variables and see how we can troubleshoot the failing S2I build. And it seems that all that we have left is to clean up our environment, right? So at this point, all we have to do is delete everything, all of the OpenShift objects with the selector app equals contacts. So let's do that. Then I need to do the same, but also include a all and a secret for the selector template equals PostgreSQL ephemeral template. And there we go. And finally, I need to delete some secrets. So this is the contacts secret. And there we go, right? So we deleted the contacts generic webhook secret and the GitHub webhook secret. This concludes our guided exercise, and I'll see you in the next video. So welcome to the final chapter in this course. And so far in this course, what we have been doing is we try to be very hands-on. We try to take a look at our code and deploy our code and really take a look at OpenShift and try to learn OpenShift by doing. And what I want to do in this video is I want to step back just a little bit and try to take a look at the architecture of Kubernetes and OpenShift. And I want to see the components that OpenShift consists of, right? I want to take a look at some of the resources that Kubernetes as well as OpenShift provides, right? And this is quite useful for us so that when we talk about OpenShift and Kubernetes, we know what these two offer to us. And when we deploy and develop applications in the future, we have a general overview of the landscape of Kubernetes and OpenShift, right? So when we talk about Kubernetes and OpenShift, it is quite useful to know some very, very basic terminology, right? Kubernetes as well as OpenShift uses the term node to mean simply a server that is a part of the Kubernetes cluster, and a node can form a function, right? It can be either a control plane or a compute node, right? A control plane node is basically a node that serves as that runs the workload that pertains to the cluster, right? So think something like the DNS resolution service, right? This is a workload that is critical for the operational capability of the cluster, right? And so this is something that the control plane will host. On the other hand, compute node is a node such that it executes workloads for the user, right? So for example, the application pods that I want to schedule will run on a compute node, right? And so we then have the term resource, and I have used this term resource throughout this course, right? And this is any kind of a resource that we can deploy or spawn on Kubernetes or OpenShift, right? This can be a pod, this can be a deployment, a resource, any similar service, right? Route, etc. A controller is very important concept within Kubernetes as well as OpenShift. And a controller is basically a manager, right? A controller or a manager, these are kind of synonymous terms. It's basically a program. It's a program that operates on a watch loop, right? And it watches a state, right? And whenever there's a change in that state, this controller contains logic that tries to move the state towards the desired state. And so this sounds all incredibly complicated, but for example, a deployment or replication controller is a controller, right? So an example of that is that we specify that we want to have 3 pods of our application, right? We deploy our application and we want to have 3 pods. And then one of our pods dies, right? One of our pods gets destroyed for whatever reason, and suddenly we only have 2 pods running, right? Well, this is a change of a state, and then the controller reacts to this change of a state by spawning a new pod, right? So this is a controller that responds to the state change on a watch loop, right? We then have labels. Labels are incredibly useful within Kubernetes. We have used actually labels quite extensively for our cleanup, right? So whenever we have done OC delete -- selector, right, we have used labels. So app equals something was a label. Label is a key value pair that that can be assigned to any resource, and it simply marks a resource as something, right? And these labels can be used by a number of things, be it, for example, like we have used just to signal that a number of resources, a set of resources belong to one application, right? For example, and a namespace is simply a group of resources, right, that are bounded together. So there is essentially a set of boundaries within which we can instantiate a set of resources. If you have been using the OpenShift within the cloud, the cloud environment, right? Then you have the -dev namespace and -stage namespace, and in fact these are projects, as we will see in a little bit. And if you create your own Kubernetes cluster, you can create as many namespaces as you need for basically delimiting a set of resources, right? Then we have our own OpenShift terminology. We can have our infrastructure node or infra node, and this is a node, a server within the OpenShift cluster, right? That contains some infrastructure services like monitoring, logging, routing, etc. Right? We then have our console, right? Which is the web UI that we have been using a lot in this course. And of course, because we have been using it a lot, this web UI has to live somewhere, right? There's an application like any other, and this application is hosted somewhere within the OpenShift cluster. And so this is a pod or set of pods like any other. And project is, like I said, an extension of the Kubernetes namespace. And it adds just very few niceties to the namespace. But for our understanding at this stage, you can think of them as somewhat similar, right? So this is just very, very basic terminology of OpenShift and Kubernetes. So let's take a look at some components that OpenShift uses, right, in order to operate, in order for us to use Red Hat OpenShift. We have a number of components, and especially if you use OpenShift in the cloud, you don't see a lot of the underlying components, but you can also deploy OpenShift onto your computer, onto in your environment at work, at school, right? And if you do, then you have to maintain a lot of the underlying hardware, and then you come into contact with something like the Red Hat CoreOS, and this is the underlying operating system on which we deploy Red Hat OpenShift. And Red Hat CoreOS is an immutable container-based operating system that enables us to deploy and manage OpenShift, or rather, it enables us to integrate OpenShift with the operating system, right? So where the operating system uses containers as a first-class citizens, right? So the Red Hat CoreOS is the operating system on which we can deploy Red Hat OpenShift. Of course, the operating system has to have some kind of container runtime, and so we know that within Red Hat OpenShift, as well as Kubernetes, we can spawn pods, right? And pods are basically our applications. One pod contains one or more containers, right? And so we need to have a way to spawn our containers. previously, in previous versions of OpenShift as well as Kubernetes, we used Docker as our container runtime. This has been deprecated, and right now we use CRI-O as our container runtime, right? So we have our CRI-O that is deployed and installed on top of our operating system. And this is, by the way, this is just a single node that we are talking about. This Red Hat OpenShift consists of multiple nodes, of course, right? And so this CRI-O container engine enables us to spawn containers that OpenShift manages for us, right? So when I tell OpenShift to create a application for me within a pod, the CRI-O is responsible at a low level for spawning that application container, right? One very interesting component that I definitely want to mention is etcd, right? Etcd. Now, recall that when we talked about scaling and scalability, I paused at databases and I posed the question, right? What will happen when we scale up something like Postgres database to 2 pods or multiple pods, right? Without any further configuration. And the answer by default is that you have 2 databases that do not talk to each other, right? Well, etcd is actually a distributed database, right? It is a cloud native database, which is one of the core components of Kubernetes as well as Red Hat, as well as Red Hat OpenShift, right? etcd is a key value store database, which stores all of the configuration and state of your OpenShift, and only the control plane can talk to it via the API, right? So etcd, if you want to take a look at it, I would definitely encourage you to deploy it. You can spin it up as a separate application, right? It's a very interesting piece of technology, very highly scalable, very interesting piece of technology to just play around with and take a look at, right? Core piece of technology within Red Hat OpenShift as well as Kubernetes. If you ever managed Kubernetes just by itself, right, and it crashed or there was some kind of catastrophic failure, you might have had to do some backup or restore of the etcd database maybe. So this is the etcd, very, very basic component, very crucial component of every Kubernetes as well as OpenShift cluster, right? Then we actually have Kubernetes, right? And Kubernetes is a part of OpenShift. It is the engine, it is the container orchestration and management engine of OpenShift, right? OpenShift uses Kubernetes and adds more, right? OpenShift is Kubernetes and more, right? So this is why OpenShift can be compatible, fully compatible with kubectl, right? Because OpenShift is Kubernetes, right? kubectl uses, communicates with Kubernetes, while OpenShift is Kubernetes. The thing is that OpenShift adds more things on top of Kubernetes, such as S2I, which we have been using in this course, that kubectl knows nothing about, right? And so kubectl does not know anything about S2I because it's not part of Kubernetes, and so you can't use S2I within kubectl. And so for that you need OC, as we have been using within this course. Well, what other parts are part of OpenShift? Well, then we have our operators, right? We have our CRDs, and operators and CRDs. These are our managers. I have mentioned some operators in the scalability sections as a way to scale some databases, right? This is essentially a manager, right? It's a part of the same watch loop as I described previously. that you can code up and deploy yourself, right? So this is kind of an advanced topic, but OpenShift provides a number of operators by default, and OpenShift actually provides a number of operators that it uses for itself, right? So these are operators that keep OpenShift running. OpenShift also provides a number of runtimes and something as a service, right? So this is something like the S2I for Java, Ruby, Node.js, etc., etc. So these are the developer niceties that we have been using throughout this course, right? So thanks to the work that Red Hat has done to enable developers to just sit down and spawn an application, right, and to bring these runtimes to OpenShift, we can simply our experience of developing on OpenShift is much, much faster and easier than what we have been doing in the pure Kubernetes way, right? Part of OpenShift is also containerized services, right? Most notably, for example, there is the image registry, an internal image registry, which you might have seen also in the S2I, and at the topmost, there is some other dev tools and user experience, such as the web console that we have been using very extensively throughout this course, right? So these are some of the components, some of the main components that OpenShift consists of, right? And one of the things that I definitely wanted to highlight is that Kubernetes is part of OpenShift, right? It is the engine that powers OpenShift, right? So this was our OpenShift component stack. Let's take a look at the very basic architecture. So this is what our cluster might look like, right? We have our control plane over here, which runs the API or authentication service. We have our data store, which is the etcd, for example, right? We have our scheduler or management replication, and these are all workloads that pertain to the cluster, right? To the OpenShift cluster, without which the cluster could not run. And that is why these workloads run on the control plane nodes, right? This does not mean that there is only one control plane node, but for simplicity, we only show, for example, one control plane node. If there is some storage needed, which of course there will be some persistent storage needed, there can be multiple persistent storage providers, right? Gluster probably not anymore, but Ceph, right? Ceph is definitely used nowadays, and there is also some other vendors that can provide persistent storage, right? For our cluster. For example, off the top of my mind, like something like AWS can also provide persistent storage to our cluster, right? Then we have some infrastructure node that runs our infrastructure. So, for example, this could run our console, right? Our console, and then we have our node. This is our regular node, right? Which could run our applications, such as our contacts application, right? And so this all consists, this is all our OpenShift application or our OpenShift cluster, right? We can have multiple of our nodes and our infrastructure nodes and our control plane nodes. And all of these nodes can be in the cloud, they can be local, right? They can be in AWS, in Google Cloud, in the IBM Cloud, wherever you want them to be. They can be in your local cloud, right? You can have your own cloud with the Red Hat OpenStack, for example. They can be on your bare metal machines, right? You can have your own data center. You can have your own machines. You can deploy Red Hat OpenShift there. And in fact, you can have them in both of these clouds at the same time, right? You can have some of the nodes in your local environment and some of them in AWS, for example, and these nodes will communicate quite well. And you have your developer user, which uses some tools like Git, right? And some CI/CD, so continuous integration, continuous deployment, to talk to our cluster, and uses our cluster to do what needs to be done. And we might have some traffic via the routing layer, which might route our external requests to our actual pods, right? So this is just a very, very basic architecture of Kubernetes. So new features in Red Hat OpenShift 4. Well, when Red Hat OpenShift 4 came out, so if you have been using the cloud environment within this course, you have been using Red Hat OpenShift 4. Red Hat OpenShift 4 has been with us for quite some time at this point. Red Hat OpenShift 3 is still supported within so far, right? But will be deprecated within 2022, I believe. So Red Hat OpenShift 4 was a huge step within the Red Hat OpenShift and Kubernetes space, right? But at this point, we have been with Red Hat OpenShift 4 for so long that it is not as relevant as it used to be. One thing that I would definitely point out is the operator SDK, right? So if you want to look at something very interesting, operators and trying to deploy and write your own operator is is a little bit of an advanced subject, but it's definitely something that will give you a lot of knowledge into how OpenShift works, right? And sadly, you can't deploy your operators into the cloud cluster that I have been using throughout the course. But if you spawn your own Kubernetes or OpenShift cluster, then you can deploy your own operators into your small cluster, and you can test the operator SDK and package your applications as operator, right? So we then have our resource types, right? And throughout this course, we have been using a lot of resources already. We have gotten we got our hands dirty with a lot of resources, and so this is just a formalization of a lot of knowledge that we already have, right? And of what we already used, right? So we have our pods, right? And a pod is a basic unit of work within Kubernetes. Pod consists of one or more containers, right? And each pod is given a unique IP address, right? Within a Kubernetes cluster, each pod should be reachable to any other pod, right? So if each pod should be reachable to any other pod, where do we need services, right? So a service is a concept where basically it is a resource that gives a single IP and port, right? Which leads to a set of pods. Well, the reason why we use services is that pods are ephemeral, right? Pods often get destroyed and recreated, and services lead to a set of pods, which can be dynamic. And so we don't want to keep remembering or keep trying to discover new pod IP addresses. We just want to discover one single IP address of a service, right? Or even better, get a DNS name for a service and use that instead of using ever-changing IP addresses of pods, right? We have our replication controllers. And replication controllers, we have not used replication controllers throughout the course, but the truth of the matter is that we have used replication controllers indirectly. And the reason for that is that replication controllers are used in scaling the pods up and down, right? A replication controller is a controller which manages the number of pods. So when you say that you want a pod, you want an application to have, for example, 3 pods, it is a job of a replication controller to keep the number of pods to, for example, 3 pods, right? Now, you might say that we have not used replication controllers, but we have used a deployment or a deployment config. And that is absolutely true. And my response to that would be that deployments and deployment controllers use replication controllers. Okay? So then we have our persistent volumes and persistent volume claims. Now, this can be confusing especially to new users. Persistent volumes are storage, or is storage that is defined by an administrator, right? So for example, an administrator provisions storage within AWS and configures it for Kubernetes, and a developer claims some of that storage by using persistent volume claims and uses it in their application, right? So these are kind of two sides of the same coin. However, persistent volume is used by an administrator and persistent volume claim is used by a developer, right? And then we have our config maps and secrets. Now we have used both in our previous videos and in our previous guided exercises, and so I will not spend a lot of time on that. So we then have our OpenShift resource types, right? And the main OpenShift resource type that is specific to OpenShift, or one of the main resource types, is the deployment config, right? And so it's interesting that when you create, for example, if you notice when you create a Postgres database, I believe that still to this day, it spawns with a deployment config rather than deployment. So both deployments and deployment configs are controller type resources, right? Which manage the pods for the applications. And as I said, both of these resources used replication controllers underneath, right? And deployment config is specific to OpenShift. And there are some niceties that deployment config provides to you that deployment does not, right? So for example, the lifecycle hooks are definitely nice for the deployment config object, right? And deployment object does not support the lifecycle hooks. Now, if you are not sure, for example, what the lifecycle hooks are, right? Then my advice would be to use deployment, because that means you are your application is compatible with upstream Kubernetes, and you might move your application between Kubernetes as well as OpenShift. However, it might be interesting to research exactly what the lifecycle hooks are, especially for something like a database, right? And see whether it might help your use case. And in that case, you might want to use the deployment config in case that you might need it, right? Another resource is the build config. We have used it extensively, right? This is also specific to OpenShift, of course, because it uses the S2I feature. And yeah, we have used it extensively throughout this course, so I'm going to spend a lot of time on it. And the route is also quite, specific to Red Hat OpenShift. The upstream Kubernetes has a similar resource called ingress, right? But within OpenShift, we have ingress as well as a route. And a route we have used throughout the course as well. It gives us a DNS host, right? DNS host name. And basically what this means is that it gives us a resolvable address, right? A URL that we can access from our browser so that our application is accessible to us, right? And so OpenShift comes with something like OpenShift comes with a router. This router is HA proxy, I believe, and this router routes the requests to the pods, right? Then we have the last section within this high-level overview is networking. Networking is a huge subject within the Kubernetes and OpenShift community, right? The main thing that I wanted to point out here is that there are many pieces within the cluster that need to communicate together. What I wanted to talk about when it came to networking is that we have several pieces of architecture, right? We have one type of node, right? We have a different type of node. We have a third type of node. And all of these types of nodes must be able to communicate with each other, right? So for example, all of the workload nodes, right, must be able to communicate with each other, right? Because these nodes, there can be multiple of these nodes, right? There can be multiple of infrastructure nodes, right? There can be multiple of control plane nodes. So all of these nodes must be reachable, right, to each other. But all of these nodes must be reachable between each other as well, right? But what's more, all of the pods has to be reachable to each other across these nodes, right? So not only does pod 1 from a single node be reachable to pod 2 from a single node, our application must be able to reach the API authentication if need be, right? And so this becomes extremely complicated when we start to have hundreds and hundreds of pods with hundreds of nodes, and each of these nodes has hundreds of pods, and we have hundreds of services, right? This image does not even have any services that connect each of these nodes, right? And this image does not even have routes that route to each of these pods externally, right? And so when we talk about networking, what we do within OpenShift is we deploy something called software-defined networking, or SDN, which essentially enables us to create complex networking rules and routes. And this enables us to solve these complex routing rules and even at some point, for example, create rules such that some applications might not be able to talk to other applications for security reasons, right? So networking is a very broad topic, a huge topic within the Kubernetes community. And if that interests you, then there is a lot of reading to be done, right? And it is a huge rabbit hole. But for our purposes so far, it is enough to understand that there are many different IP routes, right? and many different routes, many different ways into which we need to connect within our OpenShift cluster. And the way we solve that issue is via software-defined networking layer. Okay, so this does it for our lecture, and I'll see you in the next video. So welcome to our next video. And in this video, we are going to be talking about how we create Kubernetes resources, right? And so in this course, we have created a number of resources. And so what we mean by creating Kubernetes resources is what I want to do is I want to go down and kind of take a look at how we create resources in depth, right? What it means to define a Kubernetes resource, right? How do we represent some resources? And we have seen some resources throughout this course, but what I want to do is I want to codify it, right? I want to delve into it, and I want to definitely delve a lot deeper into the OC command line utility, right? Into the OpenShift client command line utility. All right. So throughout this course, we used OC, and we are familiar with OC. We know that whenever we want to use the OC, right, we invoke OC, and then it follows some commands depending on what we want to do. OC get, OC delete, OC describe, etc., right? Before we can start using it, usually we have the OC login command, and we can get this OC login command quite conveniently from the web console. So let's take a look at our first resource, which is the pod, right? The pod resource definition. And each resource in OpenShift as well as Kubernetes can be defined as a YAML file. And if you have taken our previous courses, for example, focusing on purely Kubernetes, this is going to be quite familiar. And if you have not, then this is going to be some new information, right? But this file, this representation of a pod, is a YAML format, right? And we have come into contact with YAML file. Each representation can be either JSON or YAML format, right? So this format is a YAML format. We see that this is a pod definition, right? So we have some kind of a kind, and the kind is a pod. We then have a name. So this pod is going to be named Wildfly, right? We set certain labels. So we have our labels, right? And each of the definition formats has a spec property, right? And the spec takes an object. And in the case of a pod, the pod defines a number of containers, right? One or more containers. And so within the YAML format, whenever we have one or more files, right? This we mark with the dash, right? This marks an array of things, right? So in the same way, we have, for example, ports takes an array, right? And the env takes an array of things, right? So as we have said previously, pod is one or more containers, right? In our case, in this course, one pod equaled one container, but we can have multiple containers within one pod. And so the pod takes a property called containers, right? So that's why there is an S, it is in plural. We can define multiple containers, and within the container array, each of the objects defines an image for the container, right? So this is the container image that we want to spawn. So this is going to be our container image, right? And each container, for example, defines some number of ports, right? So in this particular case, this container defines the port 8080, and this is just metadata for the container, right? This enables us to expose this port by a service, which we'll take a look at in just a little bit. And we name this port. This is not necessary, I believe. And then we define our environment variables, right? So in this particular case, we hard code the environment variables into the port definition file, right? So we have our MySQL user as user1 and MySQL password as myPA55, right? And so this is hard coded into the port definition file. And so remember that whenever we write YAML file, the white space is important, right? The white space matters. And so the distance, right? The amount, the number of spaces between each of these properties has an actual meaning, right? It signifies what is an object of what, right? So the YAML file is quite human readable. It is a bit difficult to write because of the white space constraints, but once you get used to it, it is not that difficult, right? But definitely easy to read. We then have our services, and we know from our networking section from our previous video, we know a little bit about networking, right? And so we know that within multiple nodes, each pod has to be able to communicate with each other, right? So this is what this image is trying to depict. When pod 1 is trying to communicate with pod 3, they must be able to talk to each other, right? And this is due to the thanks to the Kubernetes pod SDN, right? SDN is the software-defined network, and within Kubernetes, each pod has to be able to communicate with any other pod within the cluster. So let's make it a little bit cleaner, right? And so what is the problem with this style of networking? Well, as we said in the previous video, what if pod number 3 dies, right? And pod number 4 is a replica of pod number 3. Well, in this case, pod number 1 has to look up pod number 4 address, right? IP address. And then instead of communicating with pod number 3, we have to communicate with pod number 4, and we have to manually manage the IP address, right? Which can be quite easy when we have 4 pods. It can be quite difficult when we have hundreds of pods, right? And so what services are solving for us is that every pod sees a service, right? And this is what this image is trying to depict. So if this image seems a bit busy for you, let's try to follow the arrows, right? So for example, on node 2, right? The pod number 4 communicates with service 1, right? And so what service 1 does is that service 1 routes requests to pod number 1, right? So service 1 routes requests to pod number 1, as well as pod number 3, right? So these 2 pods, pod number 1 and pod number 3, are part of the same application, for example. And in the same way, pod number 2, right, talks to service 1. And I see that we have 2 service 1, but this actually should be something like, let me change, this should be something like service 2, right? And the service 2 talks to different pods, right? This service 2, and let me change the color as well. This service 2 talks to pod number 3, right? And pod number 1. And so pod number 2 does not have to look up the IP address of any pod. All we have to do is know the name of service 2, right? And so when or if pod number 1, any of these pods, right? So let's clean this up a little bit, actually. Right? That's fine. And let's say that pod number 2, right, wants to talk to pod number 1, right? So that's all well and good, and they communicate with each other. When pod number 1 dies, right, pod number 2 still talks to service 2, and the service 2 simply reroutes the requests to pod number 3, right? And pod number 2 does not care that pod number 1 died. It is an implementation detail, right? Pod number 2 does not care about any of the IP addresses. Kubernetes manages that for us, right? All we care about is what is the name of the service, and we can actually even hard code that in our application, but we don't have to hard code that. We can look that up from our environment variables. And when that's done, Kubernetes manages these for us. So this is why we use services. And again, if you have taken our previous courses, this is all a repetition for you. This is all quite familiar for you, and this is all enabled by the software-defined networking, right? And so we have another definition file of a service, and in this case we have the JSON syntax definition. So as we said, we can have a YAML file, we can have a JSON file, and both of these can define each resource, so that's perfectly fine. So what we want to do is we want to set the kind, right, to service. So remember that previously we had kind set to pod. In this case, we have kind set to service. And we have some metadata as name, right? We have the name of the service is quote_db, and this is important for us. And why it's important is that this is how we call the service, right? So pod number 2 will call quote_db, right? It will not try to reach some IP address. It will try to reach quote_db. And because of DNS resolution within Kubernetes, it can reach quote_db. And then we have some specification. Just like previously, we have our spec, right? And within the spec, we have our ports. And so this can be a little bit confusing in the beginning because each service has 2 ports, right? 2 ports. So why does a service have 2 ports? Well, one is simply a port and another one is target port. Well, a service specification configures the service from the perspective of a service, right? And so from the perspective of a service, the port, right, is the service's port. So this is the port on which the service responds. So this is the port of the service. The quote_db will respond on the port 3306, and the target port, right? The target port is the port that it will send requests to the target pod, right? So a service routes requests to a pod, and remember that a service is a pair of IP, right, of a number of pods and a port. And so this is the port that it will use on one of those pods, right? So it will use a port 3306 on that pod. And so it is entirely possible, for example, that you have a service that responds on port 80. However, it reaches, it communicates with a pod on port 8080, right? So it is entirely possible to have two different ports, one for the service and one for the pod that the pod uses, right? And then we use a selector, and this is extremely important. The selector defines which pods does the service target, right? And so this service will target any and all pods that have the label with the key name set to MySQL DB, right? So any of these pods, right? Any of these pods that have doesn't matter, right? Any pods within your Kubernetes clusters with the label name that is equal to MySQL DB will be routed by this service, right? So this is our service definition, right? And I mentioned that we can use the name of our service, right? Well, we can discover the name within a single project. We can actually just use the service name, right? Within a single project or within a single namespace, we can simply use service name. Within multiple namespaces or multiple projects, we can actually use the fully qualified domain name, right? Which is the service name dot project name, right? Dot, and then there is the domain of the cluster, which is the by default the service cluster local, for example. Another way of discovering actually the IP address, right, of a service is by using environment variables. So if you don't want to use the DNS resolution, right? You don't want to use this service name dot project name dot service cluster local. You can actually, whenever you spawn a pod, OpenShift and Kubernetes automatically inject the IP addresses of all of the services that are in the same project by following this convention, right? So it's service name underscore service host is the key, and the value is the IP address, and then there is the service name service port, and the value is the TCP port, right? We can have also multiple types of services. A common type of service that is used in Kubernetes is the node port, right? Where essentially, and let me zoom in a little, this is a way of exposing our application to external users, where in OpenShift, we can use routes, right? By default, Kubernetes does not have routes, and ingress is not enabled in Kubernetes by default, right? You have to install additional software. And so the simplest way is to use just service and the node port service, right? Which in essence, what it does is the node port service exposes a certain port on every node of your OpenShift cluster, and whenever you reach your node, right, externally outside of your OpenShift cluster, right? So this is external traffic from outside your OpenShift, your Kubernetes cluster, on this particular port, right? The service can route to your application, right? Through that port. So it's a very simple tunneling mechanism. This still works in OpenShift. It can be a bit of a suboptimal solution, especially when you have multiple services that you need to expose. It is kind of a difficult solution to scale, and especially when you need to configure TLS and additional routing and you have additional concerns, right? But it definitely works for very simple use cases and development purposes, right? So this is just let me clean this up a little bit. This is just our node port service, right? OpenShift also provides the OC port forward command. This is one of my favorite debugging capabilities, right? Port forwarding. So we have our OC command, and then we have our OC utility. We use our port forward command. We have the name of our pod, right? This is the name of our pod that we want to port forward. And essentially what we are doing is we are routing the traffic from our local machine to the pod that is inside of our OpenShift cluster, right? So what we are doing is we are routing traffic from the port 3306 on the developer machine to the port 3306 on the pod that we have specified over here, right? So this is very useful for debugging, troubleshooting, but also sometimes development purposes, right? So also related to networking. Then we have creating complex applications, right? And we have done that extensively within this course so far. And so we have our OC new app, and again, we have done that mostly throughout the web console, right? And OC new app, just like the web console interface, OC new app is extremely versatile, right? Depending on what you feed to OC new app, it spawns different type of resources, right? And so, for example, we can spawn the deployment, the application stream, right? So basically, OC new app, in this particular case, we probably gave it a S2I image, or rather a Docker image, container image, right, from Docker registry. And OC new app subscribed that image to an application stream, and some service that routes requests, right? So depending on what we give to OC new app, we get different results from OC new app, right? Different resources from OC new app. And so, for example, here we can specify the container image from my registry. We can provide some name. In this particular case, this is more of what we used, right? We provided the GitHub URL and again provided some name, but we also provided some context directory, because within one GitHub repository, we had multiple applications, right? And so this would be a more complex example of the OC app command, where basically we give it a template, right? And the template is simply a predefined template within OpenShift that takes a number of parameters, right, that we define within the template. And remember that within a Unix system, so for example on Linux and macOS, we break long commands by using the backslash, and if you were to try to execute this command on Windows, you would use the backtick character, right? So this is all about the OC app command, and we are going to use the OC app command again just to practice a little bit with the OC utility. And so at this point, we should talk about persistent storage just a little bit. Now remember that when we spawned our database, we used the ephemeral database template, right? And so what this means is that when you delete the pod, all of the data that you saved into the database is gone, right? Because pods by default are immutable, and all of the data that you write into the pod will be lost when you delete the pod. That's why we need persistent storage, right? And in Kubernetes as well as OpenShift, we manage persistent storage by using persistent volumes or PVs, right? And so we can take a look at the persistent volumes by using the ocget command, right? Ocget PVs or persistent volumes. In this particular case, we have 2 PVs shown, right? Persistent volumes. And in fact, if we want to have more information about the persistent volumes, we select the output -o in the YAML format, right? And this gives us a lot more information about the persistent volume. So for example, right, we see that there is the name of this particular volume, and this is what is most important to us. This is the spec file, right? This is the spec. This is the spec of the persistent volume, and we see the access modes, right? We see the capacity, and we see that this is a host path type of persistent volume, which means that this persistent volume is a directory on a node, and the directory is located on this path, right? And so if we had this this YAML file available somewhere, we could actually create it with the ocreate command and feeding it the YAML file, right? Provided, of course, that we have enough permissions. If you use the cloud playground, right, that I have been using throughout the course, then we don't have enough permissions to create persistent volumes because that is an administrator task, of course. Now, as we have said in our previous video, we can, however, we cannot request or do something with persistent volumes, but we can request persistent volume claims, right? We can provision persistent volume claims. We can claim some space from the persistent volumes that some administrators have provided for us, and thus provide some space for our applications, right? Some persistent volumes for our applications. So we do that by using the persistent volume claim. In certain access mode, right, we can request a certain size, and once we request that persistent volume claim, we can verify by using the get command, right? The persistent volume claim can be shortened to PVC. We can verify that the status is bound. This means that some persistent volume backs this persistent volume claim. And if that is the case, we can actually mount it, right? We can mount it as into our application, right? So we have we have then our pod, right? We have a kind pod, and we mount it as a volume, right? We create a named volume. This is going to be a pvol volume, and this volume is of type persistent volume claim, right? And so the claim name is my app, and this is going to be the same as in this particular case, right? My app. So we are using the same persistent volume claim that we have created previously. And then in the pod definition, we are using this persistent volume claim volume to mount it at a certain path, right? So in this case, it is var www.html. And what this means is that this pod then uses a persistent volume in certain location. And so when we delete this pod and recreate it, the data in this location, right, data in this particular location will be the same as in the previous pod, right? It will not get deleted with our pod. The data in that particular directory and its subdirectories will be persistent, right? And so that was our persistent volumes. We can take a look at how we can manage our data with the OC command line utility, and we have done that throughout the course again. But just very quickly, we have done the get all. Well, we have done delete all, but we can also get all, which means that we can take a look at all of the resources within a particular project or namespace, right? And this does not get all, does not provide all of the resources. For example, it does not return the secrets and config maps, right? But it provides the summary of the most important resources that we most likely want to get. Then there is the OC describe command, which is also quite useful for getting some more granular information about certain component. So for example, OC describe certain pod is what we have just here, right? And let me do that again, actually, what we have just here. So the name is over here, OC describe pod, and the name of the pod, right? And this is what we have gotten. And so, for example, we can see the IP address of that pod. OC get is what we have done so far. If you want to get more information about the resource, we can use the -o YAML option, and OC create creates the resource, OC edit edits the resource, OC delete deletes the resource, which we have done quite a bit, and OC exec execute a command inside a container. And last but not least, when we talk about resources, we can't forget the labels that are connected to resources. So we've seen that labels are used, for example, by services to target pods, right? So labels are extremely important, and they even they are even used for certain functionality, such as the services, right? But within the course, we have used the labels just like here, right? Only that we did not use the shortcut -L, but we have used the -- selector. And so this is to get all of the resources that have a certain label, right? So we can even add or change the labels. The labels are within a YAML file in the metadata section, and we could use the OC edit command to add or change the labels section. So this was a lot of information. I would definitely encourage you to browse the PDF and come back to this video if you have any more questions or if you are uncertain about a certain topic. And I'll see you in the next guided exercise, where we will put some of this information in practice in our OpenShift cluster. So welcome to our next guided exercise. And in this guided exercise, what I want to focus on is getting us familiar with OC. So far in this course, we have done a lot of work with OpenShift, and mostly we have used the web console. And so in this guided exercise, what I want to do is I want to explore OpenShift in more depth, and we are going to use OC to do that, right? And we are going to get more familiar with OC. So we are not going to do things that we are unfamiliar with, but we are going to do them in new ways by using OC, and we are going to explore them maybe in more depth. So far throughout the course, when we used OC, we used the Visual Studio Code terminal, and that's perfectly fine. So if you want to use the VS Code terminal throughout this guided exercise, that's absolutely fine. What I will use in this guided exercise is my terminal application. And the reason for that is that there is more space and it will be easier to read. It will be easier for me to write. Because we are going to be using OC, the first step, of course, is going to be logging in. I am already logged in, and you can verify that by the OC who am I command. If you are not logged in, log into the OpenShift web console, click your username, copy login command, and you can log in from there, right? So step number 2 is our first step, and we are going to instantiate the MySQL persistent template. And so before doing that, what I wanted to do is I wanted to step back and see what we are doing, right? So within this course, in previous guided exercises, when we wanted to instantiate an application, what we would do is we would go into the developer catalog and we would click databases and see the application that we wanted to spawn, right? And we actually see that there is a MySQL application and it is actually a template, right? And so this is likely the MySQL persistent template that we are using. And we can click instantiate the template, and this template has a number of parameters that we have to input, right? And this is exactly what we are doing by using the OC command line utility, only that we have to have a way to provide these parameters, and that's exactly what we are doing. So we are specifying the template, and we are specifying a number of parameters. There will be 5 parameters, and each parameter has to be preceded by -p, right? So there'll be 5 times -p, 1 -p for each parameter, right? One thing that I did want to note is that this command, remember, uses the / character to break long commands. And the / character works only on Unix systems. So this is a Windows and, this is a Linux and macOS system, right? If you are on a Windows system, either do not break this command or use the backtick, right? As we said in one of our first videos. So let me switch to my terminal and create this command. So I have my OC new app command. I am using the -- template to specify that I want the MySQL persistent template. And then I have 1, 2, 3, 4, and 5 parameters, right? 4 of them have MySQL underscore prefixes, right? 1, 2, 3, 4, and one of them is simply volume capacity, right? Volume underscore capacity. So it's quite important for you to not make any typos here. if you make a typo, here, this command will spawn a lot of OpenShift and Kubernetes resources, right? If you actually make a typo here, the easiest way to rerun this command is actually go to step 5 and delete all of the resources, right? Clean up, and then return to our previous step, to step number 2, correct the typo, and rerun the command. Also note that I'm not breaking my command. I'm not breaking it into multiple lines. It's simply one line, right? So I can execute this command, and OC new app will give me a lot of output, which is good, right? I can see that it listed the parameters that I used to instantiate my MySQL application, my MySQL database. And I can verify that I have typed my parameters correctly, right? So I am using the user1 as my user. The password is also set correctly. The root password is also set correctly. And my database is set also correctly, right? And last but not least, my volume capacity was 10 gigabytes, just like I specified here, right? So this is my application, right? And if I take a look into my topology view, I see that my application is there, right? But we don't want to use, in this guided exercise, what we want to do is we want to practice with OC. So let's switch to our terminal application, and let's take a look at the status of the application by using the OC command line utility. So let's issue OC status. And we see that the deployment has been deployed about a minute ago, and we have one pod that is deployed by the deployment controller. Okay, so let's take a look at the pod that was deployed. We can issue the OC get command as we described in our previous video. And what resource we want to get? We want to get the pods, right? So we have our OC get pods, and right away we see a detail that was hidden from us in the web console, right? We realize that the deployment config spawns 2 pods and not 1, right? We have a deploy pod, and then we have a running pod. And so the deploy pod is a helper pod that helps us, for example, to execute hooks, lifecycle hooks, if there are any, right? And then we have our actual pod, which is in the running state. We have our pods, and we can use the OC describe command in order to get more information about a resource. So what resource are we describing? Well, we are describing the pod resource, right? And after we specify what resource we describe, we want to specify the name of that resource, right? So we want to get more information about a pod. So we want to specify OC describe, right? We want to describe a pod because that's the resource that we want to describe. And then which pod are we describing? Well, we are describing our running pod, right? So the name of that running pod is this one. We do not want to describe the deploy pod because we do not care about that particular pod. So I can execute this command and I get a lot of information, right? Already this is, if I know what I want and if I know how to get it, this seems a lot faster than clicking through the web console, right? And this is why OC is an incredibly powerful way of getting information from OpenShift, right? If you know what you want and how to get it, it's incredibly fast to get that information, right? By using OC. And so we see that there is a name and a namespace, right? But what I did want to take a look at is the IP address, right? We have our IP address. We have our port, right? And the port is TCP. And we have our state. It's running state, right? And then we have some further information. So we have our IP address, which is 10.128.4 and 224, right? We can also take a look at the service that the OC new app created. So again, we use the OC get command to get a resource, right? OC get service. And we see that we have our MySQL service. And this service has a different IP from our pod, right? This service has an IP of 172.30.24.250. So we have two IP addresses, right? So how do we know that this service called MySQL actually routes requests to our pod with the IP address of 10.128.4.224? Well, we can describe that service, right? We can issue, and let me clear this up a little. We can issue OC describe. What am I describing? I want to describe a service, and the service name is MySQL, right? And so then we see that the IP of the service is 172.30.24.250, and it routes to an endpoint which is 10.128.4.224, right? And so this endpoint is actually the IP address of the MySQL pod, and we can actually verify that, right? Which we have right here. So we have 10.128.4.224. So this means that this service acts as a bridge. It provides us with a static IP, right, that routes requests to a dynamic set of endpoints, right? So if we actually OC get pods, if we kill this pod, right? OC kill, OC delete. If we delete this pod, right? If we delete this pod, new pod will spawn in its place. This pod will have a new IP address, most likely, right? OC describe pod, and we get its IP address, right? So this is the original IP was 224. The new IP is 229. And if we once again describe the MySQL service, we see that the endpoints have changed, but the IP address of the service has not changed, right? So this is exactly the use case of a service. I don't want to rediscover the IP addresses of a pod. I want to have a service, and the service keeps track of the IP address of the pod. So that was just a simple demonstration of why we have services. We then have PVC, right, which we spawn with the OC new app command, which is the persistent volume claim, right? So we can issue something like OC get PVC. This is equivalent to saying OC get persistent volume claims or even persistent volume claim, right? All three of these are equivalent. And so we have one persistent volume claim, which is MySQL. The main thing to note is that the status is bound, which means that it has some persistent volume, right? Which backs this persistent volume claim. So when I deleted the pod, right? When I deleted the MySQL pod, if we put some data into that pod, due to this persistent volume claim, which is bound, the data would not be lost, right? If we had an ephemeral pod, the data would have been lost, right? And so just like with any other resource, we can, just to get a bit familiar with OC, we can describe this resource. So we can OC describe, we can issue the OC describe command, OC describe, and we can use the short name, PVC, and the PVC name is MySQL, right? And we get more information, such as the capacity, access mode, the volume mode, and what pod is the PVC used by. So that was our PVC, right? And we can actually execute some commands within the pod, right? So let's do that. And so if we want to execute some commands within that pod, what we want to do is use the exec command, right? So we have the exec command, then we specify the name of the pod where we want to execute the command. So in our case, it is this pod, right? Then we separate the command that we want to execute within that pod with double dash. And then we simply specify what we want to execute, right? We want to execute the MySQL, and then we specify the username, the password, the protocol, localhost, and what we want to execute, right? So if I execute this command, we see that we have two databases, right? What I'm executing is show databases, which is an SQL command. And we have two databases there, information schema and testDB. And the testDB is actually the database that we have created. And one last thing that I did want to show, though you will probably have difficulties executing this on your own, but I just wanted to demonstrate the port forward function of OC, is that I can actually, on my machine, if you have the MySQL utility installed on your machine, right, you can actually execute this show databases, right, this SQL function locally by using the OC port forward command. So let's try that, right? We can do we can execute the OC utility with the port forward command. Then which pod do we want to port forward? It is the MySQL pod, right? And then which ports do we want to forward? Well, on my local machine, I want to port forward the 3306, and all traffic from my local machine, I want to forward to that pod, excuse me. I want to forward to this pod, right? MySQL pod on the port of 3306, right? On the same port, because that's where the MySQL database is listening, and that should be actually it. So I'm port forwarding all traffic from my local host on port 3306 to the MySQL pod on port 3306, right? And then I can open a new terminal window, right? And I can actually execute this MySQL command, right? It should be quite simple. And because of the port forwarding setup by OC, this should respond, but I need to end this show databases. And there we go, right? So this is incredibly useful, for example, for debugging, for developing applications, right? For some local development, or just for seeing what is actually in some databases, or for seeing how an application behaves, right? Usually for debugging, or for some temporary opening of tunneling of traffic, right? So this is definitely not something that you want to have open in database, in production database, right? But it's definitely useful for developers, right? Where you just want to see, why something doesn't work, or you just want to see how something could work, etc. Right? So this was our port forwarding. I can close this terminal. I can close this port forwarding function, right? And if you do this port forwarding, do not forget to close it, because otherwise it will be always open in the background, right? And in fact, we have this log of handling connection for 3306. And so I can close this. And that is it for our guided exercise. So now all we have to do is execute our good old OC delete command. And what we want to delete is our app equals MySQL persistent application with the label MySQL persistent, right? So let's do that. And there we go. So that does it for this guided exercise. I hope that you got a little bit more familiar with the OC command line utility, and I'll see you in the next video. So welcome to our next video. And in this video, what I want to do is take a look at routes. So throughout this course, we have used routes, and we have used routes just as a way to enable access to our applications in the OpenShift cloud environment, right? When we deploy our application, it is not available to us through the internet, right? External access. And when we create a route with our application, we can access the application externally from the cluster, right? And so in this video, I just want to explore routes in a little bit deeper way, right? We want to take a look at how the routing works below the surface level, right? So right away, what I want to do, and what I think is very useful for us, is just to take a look at the YAML or the JSON representation of the route, because that reveals to us, the representation reveals to us just the logic of a route, right? So we can scroll down just a little bit and see that we have the JSON syntax for a route, and this could be YAML, this could be syntax, and we have a few most important parameters here, right? So we see our kind here, and so we see that this is indeed a route, right? We have our name here, so we have our quote app route name, and unlike service name, the name is not the main thing about the route, right? We do not look up route by its name, but we can take a look at its spec, right? Just like most of the Kubernetes resources or OpenShift resources. And remember, route is a OpenShift resource, actually. A route takes a spec, and we have our host, right? And so a host, we have our host name. And so this is actually the URL, the resolvable DNS name, right? That we can use to access our application. So this is the host name. This is the DNS name. This is the public DNS name that we can resolve, right? And what do we get to the other side? What does this DNS name resolve to? Well, it resolves to the service, right? It resolves to a service, and the service is set to here, right? The service is looked up by its name, and the name is, in our case, quote app, right? So within the representation of a route, within the JSON representation of a route, we see that on one hand, we have some kind of host name, and on the other hand, we have some kind of a service. And so we can actually bridge a service within an OpenShift cluster, right, to a resolvable DNS host name, which we can actually open up, for example, in our web browser, provided that our web browser knows how to resolve this this DNS host name, right? So this is the representation of a route, right? And you can write this manually, or you can use something like OC to create this route. And we'll take a look at how we can create a route in just a little bit. But how does the routing work, right, with an OpenShift? And so we have this slightly interesting and complicated or complex diagram, right? But this diagram looks complex. It's actually not as complex as it looks, right? And so the main thing about this diagram is that at this point, we know that we have the pod network, right? And we have the service network, because services have different IP address from the pods, right? And we have seen that from our previous guided exercise. And so services, a service provides a static IP address, right? Or rather static IP address, whereas pod IP addresses can be dynamic. Pods can be killed quite easily, right? And pods can respawn quite quickly. And so services bridge this gap and provide a rather static IP address. And so routing within OpenShift is done by this router pod, right? We have this router pod, and this is by default an HA proxy, right? HA proxy is a piece of software that is deployed on OpenShift by default. And basically every time you create a new route, right? So for example, you would issue OC expose or OC create, right? You would create a new route by some command. And then there would be some kind of traffic on that route. This traffic would be routed, right? We would get this traffic to the router pod. And if this host name would be matched, right, against one of these routes, in a very simplified manner, it does not actually under the hood, it does not actually work like that. But we can think of it as the router pod would route to one of these services, right? So for example, the router pod would match the route with service 1, and the service 1 would match the request, the traffic to the pod, which would actually provide the response, right? So in a very simplified manner, our request gets routed to the router pod. The router pod would route it to the service, and the service would finally route it to the pod, right? So this is how we can think in a simplified way about routes within OpenShift, right? So for now, this is how we can think about OpenShift, Red Hat OpenShift routes. And this is the representation, right? So all that remains right now is how do we actually create these routes? And so, as I've said, we can use the OC expose, right? So we are using the OC command line utility. The command is expose, right? What are we exposing? Well, you can expose actually multiple resources. So if, for example, you expose a deployment, you create a service. If you expose a service, you create a route within OpenShift, right? So we are exposing a service. Then we provide a name for that service, right? So this is the code DB is name for that service. And then optionally, we can provide this dash name parameter, right? Is name for that route. So this is an optional parameter that you can specify. The route by default generates the host name, right? The DNS name on which the route serves, right? And the generated name has the following form, right? So it has the route name, right? And then it has the project name, and then it contains the default domain of the cluster, right? These are the three components of the generated DNS name of every route. And we will see that in the guided exercise that will follow, right? And so you can rewrite that, but generally speaking, the default domain is extremely important because it corresponds to the wildcard domain, the wildcard DNS domain, and this wildcard DNS domain is required for this HA proxy router pod, right? This HA proxy router pod requires this wildcard DNS domain. This was our creating how do we create our route, right? And of course, you can create the YAML representation or JSON representation of the route, and then use the OC create command as we have said in our previous lecture, right? And last but not least, we have talked about the router pod. If you have admin privileges within your OpenShift cluster, you can take a look at the router pod, right? You can, for example, get all pods, right? So you can use the OC command line utility. You can use the get command, right? You want to get the pod resources. You can get the resources in all namespaces, and then you can, this works in a Linux or Unix systems, right? So on Linux and Mac OS systems, you could pipe it, or you could take everything, all of the output of the previous command, and input it as the input into the grep command line utility, which I have actually shown you in the guided exercise that I have used previously. And you could find the pod with the name router, and you would find that there is some kind of router default pod, right? And the router default pod in this example is in the OpenShift ingress namespace. And so this is the routing pod for the HA proxy that routes all of the routes for us, right? And so you can use something like OC describe, right? You can use OC describe in order to just see the configuration of that pod and see how that routing pod is configured, right? So for example, we can see the canonical host name for that router pod. All right, so this was just taking a little bit of a deeper look at the routes within Red Hat OpenShift. And so let's take a look at how we can manage, create, No, sorry, Ben. Let's do it again. All right, so that was just a little bit of a deeper look at routes. And so let's take a look at how we can create and manage routes in Red Hat OpenShift. Sorry, one more time. All right, so that was a little bit of a deeper look at routes in Red Hat OpenShift. So let's take a look at how we can create and manage routes in Red Hat OpenShift in our guided exercise. All right, so welcome to our next guided exercise. And in this guided exercise, what we want to do is we want to get a little bit more insight into routes. So previously in this course, we have used routes, but in this guided exercise, we want to use OC, the OpenShift client, right? To get a little bit more insight how routes work at a deeper level, right? And so because we are going to be using OC quite a bit, of course, we need to log in. So if you are not logged in yet, go into your OpenShift web console, right? Click your username and copy login command. And because we are going to be using the OC client quite extensively, again, as in the previous video, I'm going to be using my terminal application. But of course, you can keep using your Visual Studio terminal application as well. So what we want to do is we want to deploy a PHP-based application, right? And this is going to be a container-based application. And the container image is going to be this image, right? And so what we want to do is we want to use the OC new app command, right? And we want to use the Docker image option and specify the image, right? And we want to name it. We want to name our application as PHP Hello World. And so that's quite fine. Remember that if you are on Windows, do not use this backslash, right? Either use backticks or type out the command as a one-liner. So in my terminal application, I have prepared the OC command, right? And we have our OC new app command. I have set the image to be quay.io with our value, right? And you can specify either the Docker image or simply image, which is the non-deprecated value. And the name of our application is the PHP Hello World, right? So that seems to be a success. We have a number of resources that were created, right? And we can actually take a look at the pods that were created by using OC get. Right? And I hope that by this point, you are starting to appreciate how fast it is to use the OC command line utility as opposed to the web console, right? So let's take a look at our pods, and our PHP application is already in the running state. So let's take a look at our service, right? So we have our PHP Hello World service, and we can actually describe that service. And actually, before we do that, let's take a look at our application still. Let's issue OC log command, right? OC logs for our PHP application, and we have some logs from our application. In the guided exercise, we have OC logs -f, right? So we can do that as well. Let's clear this up a little bit. OC logs -f. So that means that OC will not return my command prompt. It will wait for the application to print more logs. So this is quite useful when you are watching some application, right? You're watching what the application is doing. or you are trying to see the logs of an application, right? And so if I want my command prompt back, I have to type Control-C. So this prints a !C, right? And I get my prompt back. And so at this point, I can take a look at the service, OC-get service or OC-get SVC, and I can verify whether that service is correctly routing requests, right? So we can do that by the describe command. So OC describe. What are we describing? We are describing a service with the name of PHP Hello World. And how do we verify that the service is correctly configured? Well, two things, right? We have our IP address of the service and we have our endpoints. So this means that our service has an IP address and that our service routes requests to at least one pod, right? So at this point, we are reasonably sure that our service is correct, and we can use the OC expose command in order to create our route. So let's do that. So we are using our OC expose, right? Actually, let me clear this up. Let me see the service, and we are using our OC expose command. What are we exposing? We are exposing a service. And which service are we exposing? We are exposing our PHP Hello World service, right? So we have created a route, right? We have created a route, and the route was named PHP-Hello World. So that seems to be the case, right? We have our route, PHP Hello World, and the full host name is exactly as we have predicted, right? So this is the full host name of the route, and we have our PHP Hello World, which is the name of the service, dash, then the project in which the route resides, right? Then dot, and then the DNS wildcard for the router pod, right? And so I can actually take this host name and open something like a Firefox or Chrome or whatever browser you are using, right? And I can reach this application, right? And so to demonstrate this fully qualified domain name generation, what we can do is we can delete this route, right? We can delete this PHP Hello World route, and we can create a new route. So we can still expose a service, and we are still exposing the service called PHP Hello World. But now we will create, input a parameter, right? And it will be a name parameter. And for example, it will be my name, right? My username, XYZ, right? So this will create a new route with the name specified here, right? And so at this point, right, we should be able actually, without looking up the route, to see what is the host name for this route, right? So we have our old route, and this old route should no longer be accessible, right? Which is true because we have deleted it, right? And so returning to our terminal application, basically what we have deleted is the PHP-Hello World, right? The name has changed. And what did it change to? Well, it changed to my username, right? Everything else stayed the same. So let me just try and copy paste this new DNS, and that seems to be true, right? So what did I just guess, right? Well, I didn't guess anything. I just know the rules for auto-generating the fully qualified domain name for a route, which basically all it did was take the name of the route, right? Then separate it with a dash, take the name of the project in which we are, right? Which we are in the RHT myname-dav project, right? And then separated by dot, right? And then we have the wildcard domain for the routing pod. And of course, what we can do is we can also describe the route. Right? And we have our default router. And this is the router host, right? And we did not configure any TLS termination or anything similar. So that's quite all right. So this is all for our guided exercise. Now, all that we have left is to delete all our resources. And I hope that I'll see you in the next video. Welcome in the last video of this chapter, and in this video what I want to do is explore source to image in a little bit more depth. So we have used source to image extensively throughout the course, right? It was the main method of deployment of our applications to our OpenShift cluster. But again, as we have been doing so far in the last week, in the last chapter, what I want to do is take a look a little bit deeper as to what's going on within the S2I process in OpenShift, right? So what I want to do is I want to take a look at this diagram. Essentially what S2I does, right? And there is a number of things that happens, right? S2I is somewhat of a complex process, but when we, for example, when we execute something like OC new app command, or when you click the add, and when you go to the web console and add a new application and kick off a new S2I process, right? The most important piece is this build configuration, right? And at this point, we know that the S2I has two main phases, the build and deploy phase, right? And so essentially everything except for this phase, so everything on this side is the build phase, and only the deployment is the deploy phase, right? So in essence, most of this diagram is simply the build phase of the S2I process, right? So let me make that a little bit cleaner, right? And so we have our build configuration, which creates the builder pod, and this is where most of the magic happens, right? This is where the builder pod, right? We have our builder pod, and the builder pod downloads our source code or whatever we give it to, right? So for example, if we give it the GitHub URL, the builder pod clones the GitHub URL, then it needs to pull down our builder image. So for example, we have deployed our Node.js based applications. So it needs to pull down the Node.js based builder image, right? And then what we are doing is of course, the builder pod will download all of the dependencies, as we know, right? The application dependencies. It will try to compile our application if compilation is necessary, for example, for Java, etc., right? It has all of the build scripts and run scripts, etc. And then it will try to compile the image, and subscribe the image into an image stream, right? And we are going to talk about image streams in just a moment. And so when that is done, right, we have an image stream. We have a container image that the builder pod will push into the image registry, right, internal image registry. And this image is subscribed to an image stream, right? And so at this point, if all went well, the image stream has a image, right? And the build is happy. And if the build is happy, right, our deployment is notified. And at this stage, we can finally try to deploy the final image, right? We can finally deploy the container image. So this was our S2I process, right? And so let's take a look at our image stream. Why did we use image stream? What is an image stream? Well, remember that S2I, right? The whole S2I process is a fully OpenShift specific process. It has nothing to do with Kubernetes, and builds are also OpenShift specific, and image streams are also specific to OpenShift, right? Image streams do not exist in Kubernetes. And so image streams, in a very simple sense, are simply a collections of images, right? Of container images. And so the reason why we have image streams is that in essence, we have one image stream where we can have multiple images that we subscribe to that image stream, right? And so we can have, for example, right? We can have one image stream, right, with multiple tags, or rather, for example, here, and we can have multiple actual images under this image stream. And so what happens in our build process is that when this image stream changes, right, when we run a new S2I build and we have a new build, because we have subscribed our deployment, right, our deployment over here is subscribed to an image stream and not an image. When the image stream changes, we can automatically change our deployment, right? Redeploy our deployment, redeploy our pods with the latest image, right? And vice versa. If the latest image is not working as we would like, we can roll back to our previous image that worked as we would like, right? So that's the benefit of an image stream. It's a simple abstraction over a set of images, right? So we have our image streams. And of course, how do we create an application, an S2I application, by using the CLI? Well, we have actually done that, right? We have done it simply by using the OC new app, right? So let's do it like this. So of course we have used the OC command line utility. Then we have the new app command, and then we have used the GitHub URL, right? And we have used the context directory, which specifies where in that GitHub URL is our application, right? In addition, we also specified a branch by using the hash or pound after the GitHub URL. Well, what you can also do is, for example, if you are in a directory with your source code, you can simply specify OC new app dot, right? Which means OpenShift, which basically tells the OpenShift to build the current directory, right? Which is very cool. or you can actually specify the builder image or the image stream that you want to use as the builder image by using, for example, the I as the image stream, right? Or you can specify it by using the tilde, right? The tilde is this character, right? This squiggly line, right, over here. So that's a tilde. You can specify the image stream by the builder image stream on the left side of the GitHub or Git URL. It doesn't have to be GitHub actually. The Git URL on the left side of the Git URL separated by tilde, right? So you have an image stream, tilde, and the Git URL, and this explicitly tells the S2I process that you want to build your application by using S2I with the PHP image stream builder image, right? And so when you don't provide the builder image, when you don't provide or when you don't specify the builder image, S2I will try to guess which image stream it should use, right? And it will try to guess based on a certain marker file, right, within the directory that you specify. And so, for example, if the directory that you specify has pom.xml, well, then it's going to, S2I will attempt to use Java EE as well as the Maven build tool, right, to try to build and deploy your application, right? If we have something like package.json, right, as well as app.json within our application or within our repository, then the S2I will try to use Node.js based builder image stream, right? So there are a number of supported languages that you can use, and S2I will try to guess which language you're trying to use unless you specify which builder image stream you are trying to use, right? So as we know, each time we issue an S2I build, right, an S2I process, this creates a number of resources, and we can actually take a look at these resources. And so, for example, here we are examining the resources, and we see that we are creating the image stream, and this is going to be the image stream for the resulting image, container image that our S2I process is going to output, right? Right. And there is a number of other resources such as the build config, right? The build config is going to build your application, right? It's going to generate the build that is going to build your application. And we see actually that we have the source for the build, and the source is git from a particular URL. And strategy, we have some kind of a strategy. So we are using the PHP 7.3 image stream tag. So this is our builder image, right? And we are outputting the result of this build into another image stream, right? And this is the my app image stream that we have defined above, right? So this is our my app image stream. So this is an auto-generated S2I build process, right? And so last but not least, in our S2I process, we have the deploy phase. And so in this S2I, we are using the deployment resource, right? And the deployment resource has a name, my app. And in essence, what we are doing is we are configuring a trigger, right? So we are configuring some kind of a trigger. And so basically what we are saying is configure a trigger for the image stream tag, right, with the name of my app. And every time that the container image that the image stream tag points to changes, right? So the underlying image, when the underlying image changes in the image stream tag. So when we rebuild our S2I process and the container image changes in the image stream tag, then rebuild or redeploy this this deployment with the latest image. And so this is the default behavior of S2I deployments. So as usual, a build config, right? A build config is a resource that you can get, right? You can get and you can describe and you can find more information about the build config. And when you want to start a build from a build config, this generates a build, right? So a build config generates a running build, right? So if you issue OC get builds, right, this will select running build or actually finished builds, right? So you can see how many builds there have been issued and how many builds have completed, and you can actually see the logs from the builds by issuing OC logs, right? And you have to specify that you want logs from the build, right? And then the name of the build that you want the logs from. So the last thing that we wanted to mention is a note on relationship between build and deployments. And so this can be a little bit confusing to some people, but in essence, this is the relationship between the build phase and the deployment phase, right? So we know that we have some build phase and the deployment phase in the S2I process, right? And this is exactly the relationship between the build or build config and deployment, right? So we have our build config, right? And when we start the build for the build config, right? We instantiate the build, right? So we start a build. The result of the build is some kind of image, right? In case of success, of course. And this image is then used, right, by our deployment. We have our deployment, and the deployment will use that image in order to spawn our pod, right? And this is our deployment phase. So this is the basic relationship between the two, our build phase and our deployment phase. I hope that you have gained a little bit more insight into how the S2I process works, and I'll see you in our guided exercise. All right, so welcome to our next guided exercise. And in this guided exercise, we continue our exploration of source to image. And again, we are trying to get a little bit deeper into source to image by using the OC command line utility, which enables us to explore the underlying inner workings of S2I, right? The inner workings that sometimes are hidden from us in the web console interface, right? And so what we are going to be doing is we are going to be deploying a basic PHP Hello World application from our do101x-apps repository, right? So let's take a look. And the first thing that we are going to be doing is creating the S2I branch, right? So let's open up our Visual Studio Code and create a new branch. So open up source control, and I seem to be in the hello Node.js repository. So let me switch to my do101x-apps repository. Now I'm in the troubleshoot branch. So let me check out into my main branch, right? Remember that that's very important. And let me create a branch, which is called S2I, right? So this is my new branch. Let me push it. And I would like to publish this branch. And there we go, right? So this is my branch. And at this point, we can take a look at our PHP Hello World application, right? Which is a very simple application. So this is the PHP Hello World application, which is a simple application that prints out the PHP version used in the application, right? So what we are going to be doing is, of course, we are going to be using the OC command line utility in order to gain a little bit more of an insight, right, into the S2I process. So if you are not logged in, log into your OpenShift web console and click your username, click copy login command, and you'll be able to log in, right? So I'm already logged in, and in my terminal application, I can verify that by using the OC whoami command. So at this point, we can start our S2I build. So in my terminal application, I can issue my OC new app command, right? So of course, we are using our OC command line utility. The command is new app, right? We are using the PHP latest builder image, right? The name for our application is PHP Hello World. And then we are using the GitHub URL, right, for our repository. Remember to use your user, right? This is your fork that we are using. Then we have our do101x-apps. Then we have our branch, which is S2I. And finally, the context directory is where our application is located, right? Which is in the PHP Hello World directory. So this looks fairly good. I see that we have used the PHP 7.4, right, as the builder image. And I see that we have spawned the image stream PHP Hello World, right? We have a build config, we have a deployment, and a service. So we have 4 resources that the S2I process created for us, right? So let's take a look. We can take a look at our pods, right, to see what pods we have spawned. And we have our PHP Hello World build pod. So at this point, you know what the build pod is, right? This is our builder pod, which clones our application, right? Which clones our source code, and tries to build our application and push our application to the image stream. It pushes our application into the internal registry, right? And registers the image into the image stream. So we can actually take a look at the logs. And we can use the -f, right? And so these are the logs of the builder pod, which tries to assemble the final image of our application that is going to be used for the deployment phase, right? And so we have done this multiple times, but we have not stopped to pause and think about what OpenShift is doing for us in the build and deploy phases, right? And so when I take a look at my finished build, right, we see that in the beginning we were downloading some image, right? And so this was the builder image, right? This was the builder image that we wanted to use. This was the PHP image. And then there was the build process, the assembly process, right? Generating of our image. And then we pushed an image into my PHP Hello World latest, right? And so we generated an image, right? And subscribed that image into an image stream. So we can take a look at the image stream. And we have our PHP Hello World image stream. And if I describe that image stream, I see that it has one image which is subscribed to it, which is the image that we have just built, right? And so if I clean all of this and take a look at the running pods right now, I will see that I have one build pod, which is in the completed state. So this pod is no longer running. It is in the state completed. So it is there in case we want to take a look at the logs, take a look at what happened, right? And then we have a pod with the application that we have actually built, right? And so let's take a look. We can describe the deployment, right? So we have a deployment which uses the image that we have just built. So we see that we have this annotation for the trigger, right? So we have the trigger that whenever there is a change in the image stream tag, right, for the containers, then we want to redeploy. We want to redeploy the pod, right? So this is the deployment PHP Hello World, and the image is the image in the image stream registry. So then we can, of course, we can create a route, and we can do that by simply exposing the service, right? So we have done that already. Let's clear this up. Let's take a look at the service name. The service name is PHP Hello World. So let's expose that service. And we can reach our application at this DNS name, right? So at this point, I can open my browser and reach my application, right? And our PHP version is 7.4.6, which is exactly what we used as our builder image, right? So then we can change our application, of course, right? For example, and of course, let's add the new line. And then let's push our change into the remote repository. So whenever we make a change, let's stage the change and create a commit. Right? Let's commit this change. Let's push this change, right? And now let's start a new build, right? So how do we start a new build? Well, we have the OC start build command, right? And the start build command takes a build config. So OC get build configs tells you the name of a build config, and we can start a new build with the OC start build command. And then we can give it the name of a build config. And this starts a new build, right? So this means that we now have two builds, right? PHP Hello World 1 has completed, right? And PHP Hello World 2 is pending at this point, right? This means that there'll be a new builder pod, which is exactly what has been happening, right? PHP Hello World 2 build has spawned, and after PHP Hello World 2 finishes, there'll be a new image that will be subscribed in the image stream tag, right? And this means that this pod will terminate, and we will see a new pod in our deployment, right? Our deployment will trigger a redeployment, which means that this pod will terminate, a new pod will spawn, and our application will redeploy, right? And so our second build has just finished. So what does that mean? Well, let's take a look at our image stream, right? So we see that we have pushed our second build, right? And we can describe our image stream. Our image stream is named PHP Hello World. And suddenly we have two references, right? We have two container images in our image stream, right? One was added 11 minutes ago and one 43 seconds ago. So this means that this image stream points to this particular image, right? Which is the latest right now. But if this image does not work, right? If this container image does not work, we can very easily switch from this image to the first image, right? So this is what the star signifies. The star signifies that this image stream points to this particular image, right? And so because this image stream points to the latest image that we have just built, right? This means that our application should be updated, right? This is now a new pod, which we can see by its age. Our two builds are both in the completed stage, right? Or status. And so if I take a look at my web browser and refresh, we see a change in the output, right? And so that does it for our guided exercise. All we have left is to clean up our environment. So let's delete all of the resources with the label app equals PHP Hello World. So I hope that you gained a deeper understanding and appreciation for Red Hat OpenShift, and I'll see you in the next Red Hat course.